Hey everybody. I'm gonna give it a couple of seconds here for a couple of my friends to show up as well, and I'll go ahead and play you a little bit of some Electric Universe.
Give it a
stuff.
couple
Talk
of
about the
seconds here
sun. I'll
for
work out
a couple
the
of my
bugs. I'll
friends to
shut off
show
my
up as well.
extra volume. All right. Yeah, I love being able to show some of the alternative from mainstream theories on our solar system, our universe. It's fun stuff.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. How does the sun work? For the better part of a century, the scientific consensus has been that a nuclear reaction within the sun causes the sun's light, heat, and radiation. But rather than confirming this model, modern space discovery has only provided seemingly endless riddles and anomalies. Nevertheless, today, institutional science gives no indication of its readiness to explore real theoretical alternatives in solar physics. In this episode, Bishop Nicholas Sykes contrasts in clear and simple terms the fundamental differences between the electric universe paradigm and the standard view of the sun and all stars.
Video number 6, The Workings of the Sun. The currently generally accepted model of the Sun, as well as other stars, operates on the premise that it functions as a nuclear furnace. The electric universe paradigm offers a radically different theory of the workings of the Sun, as has already been indicated in these Space News videos. I would like now to sow some further seeds of doubt in viewers who are content with the current generally accepted model of the Sun, before going into any further detail about the electric universe paradigm. We should first note that what has become the nuclear furnace model of the Sun was developed by theoretical researchers in the years between the First and Second World Wars by Sir Arthur Eddington, at a time when the theory of relativity was beginning its dominance. Soon after this, scientists and engineers began to be greatly impressed by the proposed new applications of nuclear technology, both for peaceful purposes and to the ends of war. Furthermore, it has by now been assumed for many years that it will just be a matter of time and the refining of research to discover some way of controlling the process of nuclear fusion, which is at the heart of nuclear bomb production. When a nuclear bomb explodes, the nuclear reaction is said to be uncontrolled. There is no ability to slow it down or have it produce a smaller amount of power over an extended time. To discover and master controlled nuclear fusion has been an aim of scientists and technologists for over 6 decades, with the incentive that the basic fuel for it is plentiful and readily available. It was never envisaged, when nuclear technology began, that the tough nut of controlled fusion would prove to be such a hard one to crack. And so nobody had any qualms about modeling the Sun on just this basis. Not being, obviously, an ephemeral phenomenon like a hydrogen bomb, here today and gone tomorrow, if the Sun is to be modeled upon nuclear fusion, it must be a controlled fusion furnace that can continue producing energy for many millions of years. Electric universe theorists have noted that the nuclear model of the Sun had its beginnings in a time when physicists were turning away from the experimental verification of their thought-based models. And indeed, Albert Einstein's work was a prime example of this. Eddington himself became the chief supporter and expositor of relativity in Britain. Previous videos have noted how the corpus of Einstein's work achieved almost universal acceptance without any experimental component in its conception. And such verifications as have been claimed for it are now under severely critical scrutiny from an increasing body of independent scientists.
I'm actually playing this for wide 000, everybody, for the most part, because the user was interested in knowing some of the electric universe proponent, ideas and how they conflict with mainstream and how they actually predict things that we're observations that we're seeing, which the mainstream version, standard version, does not and cannot, and calls them anomalies and tries to make renormalization math to create a reality out of a mathematical model instead of out of observation, which is what we're doing in the electric universe. It's really incredible. So if anybody wants to help, a lot of people here are very well informed on the electric universe wide 000. So if you have any questions, just drop them in the chat, and this chat will definitely take care of you. And if not, I will definitely take care of you. But if you have any requests or other questions, this is for you. So you ask me, what do you want to know? You want to know more about what we were talking about black holes? I'll throw that on there and we'll talk about that. You know what I mean? So you kind of like, I'm just your DJ, man. You request them songs. All right, thanks.
An educational website has stated the core is extremely hot. Under these conditions, nuclei that would normally repel each other fuse together instead.
Be quiet.
In the core, hydrogen joins together to make a helium nucleus. This releases positrons and neutrinos and radiation energy called gamma ray photons. The fusion in the sun's core also creates 99% of the sun's heat or thermal energy.
Remember, he's reading
the
standard
model. The rest
model
of the sun
right now.
becomes warm when the heat created by fusion moves outward from the core through the layers outside.
In case anyone's confused, he's saying that's what the standard model says.
There is one huge unstated problem for this model.
He's not saying that's what it is.
Presumed as factual by many textbooks and websites. The observation, as opposed to the widespread contrary presumption, that by far the hottest part of the sun is not within the core, where the assumed furnace would have to be, but outside of it, at the corona. An international team of researchers points out that the deepest observable surface of the sun yields a temperature of about 6,000 degrees Kelvin. As we peer into the darker interior of sunspots, we see cooler regions, not hotter. But moving outward to the bottom of the corona, the temperature jumps spectacularly to almost 2 million degrees. Thus, the superheated shell of the sun's corona reverses the expected temperature gradient predicted by models of internal heating. It is clear that an internally heated furnace of any sort, nuclear or otherwise, does not and could not work this way at all.
Yeah,
the sun's temperature gradient, increasing where a furnace model would predict a decrease, is given an explainable cause by the electric universe model. And this ought to make the EU model a realistic contender for the minds of scientists and the general public. Indeed, it ought to make the electric universe paradigm an irresistible contender for research opportunities in the science departments of any new university that was brave enough and ultimately proved wise enough to take it on.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
Okay, where are we moving to next? I wanted to see the electric stars.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. The fundamental difference between the electric universe and standard cosmology can probably be summarized as follows. The electric universe is a connected universe, where nothing is born or exists in isolation. Filamentary networks of electric currents pervade space, producing the magnetic fields that are now detected in virtually all scales throughout the universe. Yet even as the existence of electric currents in space has slowly entered the astronomical literature, astronomers still view gravity as the predominant force in the cosmos. Today, Bishop Nicholas Sykes discusses the electric universe foundations for a new understanding of many phenomena in nature, including our own sun.
David Talbot points out that the ancients spoke of the thunderbolt ruling the universe. When we transpose their conceptual language into our own, the ancients seem to have got it right. Electric universe theorists maintain that it is the transportation of electrical energy that the plasma facilitates that makes the stars shine, including our sun, and produces all the electromagnetic radiation found in nature. The solar wind, so-called, the galactic currents, and the intergalactic electric circuits all play their part in maintaining the existence of the universe and in maintaining human existence. These electrical power systems form connected parts of the great plasma engine that rules and empowers our universe. The above statements are in conflict with most of today's accepted astronomy and cosmology theories, which operate on the premise that electric fields, currents, and plasma discharges are not important mechanisms in space. Until recently, only gravitational fields were asserted to be important. But more recently, the importance of magnetic fields has also been admitted. Even so, such a premise is becoming increasingly difficult to maintain with any honesty, on two accounts. One, that it is generally known that magnetic fields of all sorts are caused by electric currents. And two, that in the era of the space age, it becomes increasingly difficult to avoid the natural conclusion of many observations clearly showing the universe to be highly electrical in nature. Furthermore, since we observe in everyday life that electrical forces are vastly stronger than gravitational forces, how long can it be maintained in all seriousness that for driving the universe, the vastly stronger force is to be ignored, while the much weaker gravitational force is to be asserted? Electric universe theory does not postulate where, when, or how such a vast electrical power transportation might have come into being. EU theory is concerned very much with producing tangible evidence that the things about which it speaks are indeed true and verifiable. Dr. Donald Scott, for instance, produces convincing calculations showing that the collection of electrons from the space around the sun can be enough to produce the sun's output of radiation, given the observed features such as the electrical potentials and the temperatures of the various spheres, photosphere, chromosphere, corona, and heliosphere, by which the sun is characterized. In the EU model of the sun's photosphere acts as an anode and will continue to do so for as long as it maintains a sufficiently positive potential difference to the plasma of the heliosphere from which it collects negative electrons and to which it discharges positive ions. The magnetic field-aligned currents called Birkeland currents that sustain this positive potential are generated by the great plasma engine of the universe. The sun is empowered from outside itself, as are the stars in general. And as Dr. Scott points out, there is no telling when or for how long the sun or any other particular star will be sustained. There is considerable evidence coming to light about the variability of star sustenance and output. But thankfully, there appears to be a verifiable mechanism that greatly stabilizes our sun's light output in spite of its varying electrical environment. The plasma state is characterized by matter in subatomic form, be this form positive ions or electrons or both. The particle inhabitants of the plasma state exist therefore in a state of lower organization than their counterparts in the three other states. The higher organization makes for greater stability, but the electrical nature of the energy transfers across lengths of plasma, as in fluorescent lights, or expanses of plasma, as in space, requires a medium of charged but movable particles. It was demonstrated to me and many others as school children that one, plasma through which a low current density passes operates in dark current mode. You cannot see any glow, but radio waves can be radiated. 2. When the current density is increased, a point is reached at which the potential difference up to this point increasing between the electrodes connecting to the plasma suddenly drops, and the plasma starts to glow. An example of this is the fluorescent lamp, which needs some sort of starter to get it going. This mode is called the normal glow mode. There is a third mode of plasma operation called the arc mode, which cannot be demonstrated with the same sort of equipment, which would be destroyed if the current density were increased further. Nevertheless, it may be demonstrated by generating an electrical spark between two metal spheres or by the electric welding arc. Again, it has long been known to be necessary to begin the spark with a relatively high voltage difference, which drops when the discharge begins to operate. In these cases, the air between the electrodes, even at atmospheric pressure, breaks down to become a conductive plasma. A useful primer on these discharge characteristics by D.E. Scott is published on the internet. Armed by the familiar knowledge of these three modes in which plasma operates electrically, it is possible to make much better sense not only of our own sun, but of an abundance of cosmological observations, including those customarily accounted for by the much-touted magnetic reconnection. Stephen Smith relates, for instance, that astronomers using the Wide Field Infrared Survey Explorer, WISE, are reported to have located a star, Zeta Ophiuchi, whose, and I quote, powerful winds push gas and dust out of its way and into what is called a bow shock. It is conventionally assumed that the star's velocity compresses gas and dust in front of it as it flies through space because its so-termed stellar wind shoves gas and dust out of the way. So-termed bow shock is said to heat up the interstellar medium, ISM, until it glows in the infrared frequencies that WISE can see. However, Smith points out that instead of treating the interstellar medium like an inert medium, the electric universe model sees it as an electrically charged material that is affected by the plasma sheaths around stars. Stellar plasma and the interstellar medium are different plasmas, so they develop Langmuir plasma sheaths or double layers between them, while the photospheres of stars are where galactic electric anode discharges are focused. Double boundary layers form the corresponding virtual cathodes, and in the case of our sun, this is the heliospheric boundary.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info.
Arc blasted moon or whatever. All right. This is what I was talking
Welcome
about.
to Space
this is
News
what
from
I
the
started
Electric
off talking with you guys about over at the other hangout. So I want to go ahead and cover it real fast before I forget.
Universe, brought to you by the Thunderbolts Project at thunderbolts.info. New scientific reports are again forcing planetary scientists to rewrite the history of our moon. A new study into the lunar surface contradicts the notion that cratering on the moon occurs incrementally over vast eons of time. A team of scientists studied several thousands of before and after images of the moon's surface, with the visual data covering nearly 1 million square miles. What they found is that lunar cratering appears to occur at a rate more than 100 times faster than the standard impact model has predicted. The lead author of the study states, "Before the Lunar Reconnaissance Orbiter was launched in 2009, we thought that it took hundreds of thousands to millions of years to change the lunar surface layer significantly. We've discovered that the moon's uppermost surface materials are completely turned over in something like 80,000 years. A Phys.org report on the study states, the number of craters is greater than anticipated by standard impact modeling rates used by lunar scientists. The discovery has the effect of giving lunar surface features younger ages. Theory says that a lunar geologic unit should accumulate a certain number of craters of a given size in 1,000,000 years, for example. But if it turns out that impacts are making craters more quickly, then it...
I just want to say, I came up with my theory about the moon's orbit, the dielectric, electrical discharge, basic theory that I came up with about how the moon, does its, orbit and what happens and occurs and all the effects and everything. Before this video came out, before they were even talking about this kind of stuff about that, because I got the idea from their Dr. Christian Berklin's Berkland current and understanding the what people would call the break wall of a magnet, but really the dielectric plane of the magnet, and and how the dynamics of the fields operate and with each other, and seeing it firsthand with my own eyes and stuff. So I know, so I put this together, being trapped, the moon being a neutral trapped in between, two oppositely charged rings, cylindrical cylinders of the Berkland current, with a slightly conductive medium, which would be the plasma in the space around it, off very conductive. But so that's interesting that then this came out and I was like, wow. And then another thing came out after that, and I was really like, excited because it started to really come together. And it's like, when does anybody get the chance to be the guy who creates an idea about something as big as how the actual moon is in orbit, or the earth and everything else, because it's all relative for that matter. Woo!
It takes less time to reach the benchmark number, and the geologic unit is in reality younger than theory predicts. Unfortunately, the only process the scientists have considered for the astonishingly high rate of cratering is impacts from space. However, many recent discoveries reported on this series should provide a doorway to alternative theoretical possibilities.
Just look at all the hexagonal
The clue
shapes.
can be found in investigations into dramatic electrostatic dust-raising events on various bodies in the solar system. In August, we reported on a recent NASA-funded study which confirms that electrostatic dust transportation occurs on airless bodies in space. This includes the electrostatic dust storms and electrical discharges that are regularly observed on the moon when it passes through the Earth's magnetotail. As described by NASA scientist Tim Stubbs, Earth's magnetotail extends well beyond the orbit of the moon, and once a month, the moon orbits through it. This can have consequences ranging from lunar...
And that's an incorrect idea of what's really going on. The Earth's magnetotail, and once a month it passes through it. That's epigee and perigee of the moon's orbit. When it reaches probably epigee, it does its biggest discharges when they're talking about it being further away like that, or passing through the magnetosphere. Tail, because that's all like an improper interpretation of the diagrams, because it's all laid out. It's like taking a globe, cutting it open and then laying it down flat and saying, no, it's all flat. See, you know what I mean? They just crisscross their wires there. I think eventually they're gonna fucking know it. I think
dust storms to electrostatic discharges. Could at least some of the new lunar craters be the result of this kind of electrostatic activity? Electrical discharges to solid surfaces and to plates of dust, result in cratering and many other geological features familiar to planetary science, as we've repeatedly referenced in these experiments by Billy Elverton. In fact, in recent years, the scientific mainstream has begun to recognize the role of electrical forces in altering the lunar soil. A scientific paper in 2014 explored the possibility that so-called electrical sparking may occur under the moon's surface. But the surprisingly high rate of new
Which they couldn't
lunar
do.
craters is only the latest of many unresolved
They're
problems with the moon's speculative history. In the 20th century, the discovery of apparently discrepant ages of melted lunar rocks contributed to the invention of an era called the Late Heavy Bombardment, though astronomers do not roundly accept the theory, and it's not clear where the bombarding objects would have come from. In the electric universe theory, as developed by the chief principles of the Thunderbolts project, the massive cratering on the moon and every heavily cratered planetary body was a product of electrical discharge scarring at an interplanetary scale. Numerous references to past presentations on this theory can be found in the description box of this video.
Which is not what
Of course, any
about.
new electrical cratering occurring on the moon today would be at a vastly smaller scale than the events that violently scarred its surface from pole to pole. In any case, new scientific data will continue to make it more clear that cratering is not the result of periodic impacts from space over eons of time. Electrical cratering is just one of many new pathways of discovery waiting to be explored in our electric universe. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Throughout our culture, certain figures stand as iconic symbols of... Welcome to Space News from the...
Another topic we discussed, gravitational waves. Let's go over that.
Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. On February 11th, 2016, a team of scientists ignited one of the greatest media firestorms in modern history. The team announced they had detected the signature of gravitational waves, or so-called ripples in space-time, which were supposedly produced by the collision of two black holes a billion light-years from Earth. Celebratory news headlines around the world have declared the, quote, discovery a definitive confirmation of Einstein's general theory of relativity. However, this is not the first instance that the world has been informed of the so-called discovery of gravitational waves. In 2014, scientists using the BICEP 2 telescope pronounced they had discovered direct evidence of Einstein gravitational waves and cosmic inflation. Yet despite the initial media frenzy, the claim was later withdrawn due to the admission that the alleged signal the team had detected was caused by a cloud of cosmic dust.
But most people
Today,
don't know that it was withdrawn.
The chief science advisor
They
to the
still run
Thunderbolts
around
project,
with the
Wal
same idea.
Thornhill, begins our
Tell you
coverage
that,
of the
no, this
issue with
happened.
a skepticism that has been completely absent in science media. Have gravitational waves actually been discovered? And do they even exist for anyone to detect?
The science media circus is in full swing. The headlines shriek, "Gravitational waves have been discovered. Einstein proved right again after 100 years." From an electric universe perspective, the irony is quite telling, since it shows the Einstein bandwagon careening off into a black hole of its own creation. Phys.org.com says, "For the first time, scientists have observed ripples in the fabric of space-time called gravitational waves, arriving at Earth from a cataclysmic event in the distant universe. This confirms a major prediction of Albert Einstein's 1915 general theory of relativity and opens an unprecedented new window to the cosmos." Once again, we see science journalists thirst for sensational headlines, with academics feeding a media frenzy. Some would call this more a theory of funding, not gravitational waves, but gravy waves. The more sensational the headlines, the more news media attention and funding potential. Unfortunately, as a result, the public can no longer distinguish science from its opposite, pseudoscience. There is no fearless investigative journalist to ask the awkward questions like, how in real terms does matter tell space and time how to curve? What does it mean to curve time when it has no physical dimension or direction? The word space simply signifies locations in 3 dimensions. So how can you weave a fabric of space-time out of non-physical concepts? The language is meaningless, used to impress rather than inform, and the scientists remain unaccountable to the tax-paying public. Some incredibly detailed claims are made to the effect that the signal originated in the last fraction of a second before the fusion of two black holes somewhere in the southern sky. It is said, based on computer modelling, that the black holes joined about 1.3 billion years ago, and their mass was 29 and 36 times greater than the Sun. None of these claims can be substantiated. A mathematical computer model is not real evidence for those claims. It isn't science. The image of Einstein, the embodiment of genius, in front of a blackboard where he had just scrawled R sub ik equals 0, says it all. As Steve Crothers has noted, that simple expression says there is no matter outside the black hole. By its own definition, the black hole exists in an empty universe. No partner to orbit it, and no observer to witness it. The principle of superposition, that is, multiple bodies, in a flat Newtonian universe does not apply in the asymptotically flat space of the fictitious black hole universe. Decades ago, I sat in a public meeting at the Australian Academy of Science to hear the well-known English physicist and science fiction writer, Paul Davies, author of The Mind of God and God and the New Physics, drumming up support for government funding of the Australian Gravity Wave Telescope. Davies is a past winner of the lucrative Templeton Prize for bringing science and religion closer together. Scientists and the public don't seem to realise they were never separated. Big Bang cosmology amounts to archaic religious concepts disguised by wearing a mortarboard. I had the impudence to ask a question at the time, whether it wouldn't be a good idea if scientists understood gravity before they began spending hundreds of millions of dollars on a gravity wave telescope. The Englishman Davies arrogantly dismissed my question by suggesting that my question was typical of the colonial cringe. But after $1 billion spent on the advanced version of the gravity wave telescope LIGO, the question appears to have been answered as I had anticipated.
You could have ended world poverty with that shit,
didn't understand gravity. What's more, it appears he didn't understand light either. At the Electric Universe 2015 conference, I presented the culmination of my research into gravity since the 1980s. My choice of title, The Long Path to Understanding Gravity, reflected the difficulty anyone faces attempting a paradigm shift. As the inspirational teacher Evan Camp said at an earlier Electric Universe conference, a journey in the wrong direction of 1 mile becomes a much harder journey of 2 miles to correct. The difficulty is, as the educational psychologist Dr. Harry Linden's research shows, when confronted with evidence that conflicts with your paradigm, the usual response is denial, followed by accelerated forgetting. It requires being confronted again and again before acceptance slowly dawns. It takes both time and persistence. Meanwhile, beginners think it obvious. The first hurdle was easy to jump, and it's the one that shows the signal detected can have nothing to do with gravity. There are 2 L-shaped LIGO detectors, each about 2.5 miles or 4 kilometers long, one in Hanford, Washington, the other in Livingston, Louisiana. The 2 instruments are 1,800 miles or 3,000 kilometers apart, and since both obtained the same reading, scientists consider their discovery confirmed. The important thing to note is that the signals did not arrive at the same time in each instrument. But as Newton's law of gravity demands and simple observation confirms, time isn't involved. For example, if gravity traveled at the slow speed of light, the Earth would be pulled to where the sun appears in the sky and not the sun's real position in space. This would result in a slingshot effect and toss planets out of the solar system in short order.
That simple thing right there confuses people, and they're like, well, it's always connected. No, you're not understanding. It's pulling it to the place where it was. It's not where it is because of the magnetic reconnection idea. They don't seem to get that. They think, oh, well, it's always, well, you would think that, right? But that's not what the theory says. Your brain's filling in the gap to what's proper, and you're applying it on accident to the theory, which is improper. Their math doesn't keep that connection like that. You're assuming that it does because it only makes sense that it should. You know more than you think you know, guys. That's the point.
Observations of close binary stars where the effect would be extreme and quickly noticeable show that gravity must operate at a speed in excess of 20 billion times the speed of light to prevent spiraling orbits. Einstein's speed limit of light is evidently not a universal speed limit. The Sun and the Earth have instantaneous information about their locations. Of course, quantum experiments have proven that subatomic particles know about each other instantly at great distances, but rather than state the obvious, meaningless terms like entanglement and non-locality are used to remain politically correct to the dogma of relativity. This simple example shows why we should not put blind faith in experts. Their shared beliefs have repeatedly held back progress and cost us dearly. Einstein's artificial speed limit has delayed understanding of quantum mechanics and cosmology for 100 years. That's not something to celebrate. So if the LIGO signals were caused by a gravitational disturbance, both detectors should have received it at the same instant. They didn't, so the signal has nothing to do with gravity. Then what could the signal mean? Phys.org.com reports, according to David Shoemaker of MIT, the leader of the advanced LIGO team, it looked just like physicists thought it would. The waveform that we can calculate based on Einstein's theory of 1916 matches exactly what we observed in 2015, he said. It looked like a chirp. It started at low frequencies, 20 or 30 hertz. That's like the lowest note on a bass guitar, sweeping very rapidly up over just a fraction of a second, up to 150 hertz or so, sort of near middle C on a piano. The chirp corresponded to the orbit of these two black holes getting smaller and smaller, and the speed of the two objects going faster and faster until the two became a single object, he explained. And then right at the end of this waveform, we see the wobbling of the final black hole, as if it were made of jelly as it settled into a static state. Does this reasoning really make sense? Or is the public being baffled by mathematical abstractions? Black holes are a flawed theoretical concept used to make the minuscule force of gravity responsible for the most energetic compact bursts of energy in the universe. But black hole theory doesn't relate to the universe we observe. The problem is that gravitational dogma doesn't equip theorists to deal with the colossal energies and unrealistic mass concentration required by the theorized black holes. What can succeed without stretching either space-time or credulity is the most concentrated form of stored electromagnetic energy known to science, a plasmoid. According to the foundational principle itself, E = mc squared, concentrated energy is equivalent to concentrated mass. So, if not due to gravity, what might the LIGO chirp be? The advanced LIGO interferometer relies on super accurate measurements using laser light traveling along each arm of the instrument. The LIGO instruments have the largest sustained ultra-high vacuum in the world, 8 times the vacuum of space, keeping 300,000 cubic feet, that's about 8,500 cubic meters, at 1/1,000,000th the pressure of Earth's atmosphere.
8 times the vacuum of space. 8 times the vacuum of space. I've heard it said by people out on different forums that, oh, they can't even achieve the vacuum of space on Earth.
In an effort to prevent any effect on the laser beams that are being used to detect motion, equivalent to the width of a single hydrogen atom over 4.
If you say anything against it, they're like, you fucking mental midget, retard, asshole, just too much stuff, too much weirdness going on these days in these hangouts. People aren't able to actually use their brain. They can only repeat shit that they've, have heard through establishment appealing to authority on everything. It's ridiculous.
4 kilometers. So the results obtained critically depend on our understanding of light being correct. But here again, Einstein did away with Maxwell's ether medium without explaining how an electromagnetic wave could travel through nothing. You cannot wave nothing. It is remarkable that Einstein...
A wave is not a noun. A wave is a verb. You cannot wave nothing. That's the whole point. Einstein, go suck an egg.
Einstein ignored the fact that the vacuum is known to have the properties of a dielectric medium. There is no perfect vacuum devoid of matter. The electric universe proposes that the dielectric medium of the vacuum is a plenum of neutrinos, which, like all subatomic particles, must have internal structure that distorts to form electric dipoles when exposed to an electric field. Of course, the designers of the experiment didn't consider that neutrinos occupy the space inside those 4 kilometer arms. There is no way of removing them or keeping them out. They pass through the earth as if it weren't there. Now, a linear chirp signal is well known to acoustic and radio engineers. It could signify a wave pattern imprinted at the source of the burst of neutrinos, or it could be due to a wavefront moving at an angle across the boundary between two different media. In any case, a wavefront moving across the LIGO arms will generally affect each arm differently due to simple geometry, giving rise to a slight difference in the velocity of light in each arm and producing an oscillatory output signal that's mistaken for movement of the test masses. Whatever the answer, the results of the LIGO experiment have nothing to do with imagined gravitational waves. The heart of the issue here is that Einstein didn't explain gravity. As many scientists are beginning to acknowledge, a new paradigm is now required by the sheer force of discovery. Looking back on his life at age 70, Einstein gave a clear evaluation of what he believed were his accomplishments. And I quote, "You can imagine that I look back on my life's work with calm satisfaction. But from nearby, it looks quite different. There is not a single concept of which I am convinced that it will stand firm, and I feel uncertain whether I am in general on the right track." This confession, in a personal letter to Professor Solovine dated 28th of March 1949, was not made public until many years after Einstein's passing. But rather than inspire critical thinking,
And most people have never heard of it.
thinking,
Which is awesome.
today's worship of Einstein creates an unresolved enigma. Two philosophically incompatible views of physics, quantum mechanics and relativity, standing side by side in scientific lectures as if such a horrific contradiction can be profitably overlooked. Einstein will continue to be proved right for another 100 years, because when all of the standards of physics, the observer and the observed, are relative and arbitrary, the theory is unfalsifiable.
That's right.
It's not science.
Garbage. It's like saying,
Simplicity is
"Prove
the key to the
unicorns
electric
didn't make
universe,
the moon."
and perhaps a little humility
What?
wouldn't hurt either.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at
We'll start right back with
thunderbolts.info.
the mythology of celebrity and Einstein.
In part 2 of this presentation, physicist Walt Thornhill continues his exploration of the cultural phenomena surrounding the life and career of Albert Einstein. With the passage of time, it seems that both the popular culture and much of institutionalized science have only grown more certain that Einstein was right. However, as Thornhill explains, the mythology of celebrity has the ability to distort perceptions and rewrite history.
Einstein won the Nobel Prize belatedly for his services to theoretical physics, and especially for his discovery of the law of the photoelectric effect, and not for his highly publicized theory of relativity. Although physics students today are often taught that it was a quirk of the Nobel Committee to give the prize to Einstein for his quantum work rather than relativity, the truth is that everyone at the time, including Einstein, believed it to be the more surprising result. He proposed that light consists of small massless particles, or quanta, called photons, which carry energy that is proportional to the frequency of light. Here again, he indulged in mysticism by introducing a physically impossible zero-mass particle carrying energy, in defiance of E equals mc squared. This introduced the absurd wave-particle duality into electromagnetism. But by discarding the mystical paradoxes of relativity theory, it is possible to see that classical causality can be reinstated to our understanding of quantum interactions of light with matter. Light merely imitates something carrying energy at the speed of light from a transmitting atom to a receiving atom. However, it is now proven that there can be a so-called subtle, non-local connection between subatomic particles. They are said to be entangled. Both of these terms are euphemisms for an instantaneous connection and are symptomatic of the stultifying effect of Einstein's postulates. Clearly, there is an instantaneous longitudinal electrical signal via the polarizable ether that establishes resonance between two separate atoms. So when the transverse light wave arrives later, a fixed quantum of energy is accepted by the first in-phase resonant receiving particle. And since all matter is connected in real time by the subtle longitudinal electric force, also known as gravity, the energy of the light wave is not available to any other particle once it has been accepted by the resonant receiving particle. Light is a combination of two signals between atoms, the direct longitudinal resonating signal and the slower transverse electrical wave. The classical approach also removes the confusion of physical clocks with the concept of time intervals, which is absolute. Clocks simply tick at different rates depending upon their energy, which is directly related to the potential and kinetic energy of all the particles in the clock with respect to all other bodies. The most profound objection that can be raised to special relativity theory is its total reliance on relative motion. Thomas E. Phipps Jr. points out in his excellent book, Old Physics for New, that timekeeping depends asymmetrically upon state of motion. Which of two clocks runs slower depends on which has been moved, yet relative motion of the clock does not depend on which has been moved. The latter results in the well-known twins paradox, where the twins separated at high speed age at different rates. But who is to choose which frame of reference is the high-speed one when the choice is arbitrary? Phipps asks, is that too profound an antinomy for the professorial mind to encompass? He earlier concludes, the search for a physical cause of clock behavior must ultimately conduce to Markian thoughts. The mere fact that the fiducial system is inertial already sets up recognition of a subtle influence of distant matter on timekeeping. The global positioning system merely adjusts for a slower clock tick in Earth orbit. It does not confirm Einstein's relativity. Installing Einstein as an icon of genius was a cultural and historical phenomenon. It was Sir Arthur Eddington who championed and publicized Einstein. In 1975, Subramanian Chandrasekhar wrote about conversations in 1933 in Cambridge, England, which included Eddington and Ernest Rutherford. Rutherford is reported saying to Eddington, "You are responsible for Einstein's fame." He was referring to Eddington's post-war expedition to measure the bending of starlight close to the sun during a total eclipse. Chandrasekhar writes, I expressed to Eddington my admiration of his scientific sensibility in planning the expeditions during the darkest days of the war. To my surprise, Eddington disclaimed any credit on that account. Indeed, he said that, left to himself, he would not have planned the expedition since he was fully convinced of the truth of the general theory of relativity. Eddington was driven by his need to re-establish his authority following his pacifist role in the First World War, that irrational paroxysm. In the catharsis that follows such outbursts, people were looking to forget the unbearable memory. It could be said that Einstein's mysticism was an escape picked up in the arts by the surrealists. Salvador Dali was inspired by Einstein to paint melting clocks and distorted figures and landscapes. Einstein's ticker tape parade reception in New York reveals that this was not about science. In Chandrasekhar's words, astronomy had always appealed to public imagination, and an astronomical discovery, transcending worldly strife, struck a responsive chord. The meeting of the Royal Society at which the results of the British expeditions were reported was headlined in all the British papers, and the typhoon of publicity crossed the Atlantic. From that point on, the American press played Einstein to the maximum. With his oxymoronic thought experiments, Einstein became the unacknowledged but leading New Age mystic. The Big Bang creation myth built upon his work welded science and religion back together. As Einstein remarked, the only deeply religious people of our largely materialistic age are the earnest men of research. If anything shows how far we have strayed from real science, consider the poignant story of the post-mortem examination of Einstein's brain. Dr. Harvey, who sliced the brain, found no unusual traits in form, volutions, or size. Einstein was a normal human being who was thrust early in his life by Eddington into the celebrity circus. His iconoclastic papers on relativity would not pass peer review today. Einstein's popular image was untarnished, although he achieved little after the Bohr-Heisenberg Copenhagen School theory of acausal quantum mechanics gained acceptance in 1927. In real science, cause and effect cannot be divorced. Einstein complained of quantum mechanics, God doesn't play dice with the world. But ever since, students have been taught two unscientific philosophies that are mutually exclusive. Ironically, Einstein's postulates stand in the way of understanding gravity, light, and quantum interactions in simple classical terms. Looking back on his life at age 70, Einstein gave a clear evaluation of what he believed were his accomplishments in a personal letter to Professor Solovine dated 28th of March 1949 and made public many years after his passing. You can imagine that I look back on my life's work with calm satisfaction, but from nearby it looks quite different. There's not a single concept of which I am convinced that it will stand firm, and I feel...
Welcome to Space
heard that in
News
the
from the
last
Electric
video.
Universe, brought to you by the... Scientists working at the Lawrence Livermore National Laboratory are proposing a radical new theory about the nature of invisible, theoretical dark matter particles. The scientists have developed what they call a, quote, stealth dark matter model, which suggests that dark matter is composed of electrically charged particles, and which are bound by a mysterious, unknown force. The theorists are hoping to use the Large Hadron Collider to try and verify their model. A recent Science News story describing this research states, dark matter is currently thought to be completely inert to electromagnetic radiation, so it would be remarkable to discover that it is in fact composed of electrically charged particles which have somehow managed to avoid detection. However, today in our discussion with physicist Eugene Bagashov, we take a step backwards to ask a more fundamental question. Why should anyone assume that dark matter actually exists?
First of all, we need to remember what was the actual reason for inventing dark matter in the first place and how the idea of it evolved in the last decades. The initial problem dates back to 1930s when astronomers like Jan Oort and Fritz Zwicky have discovered that there is something wrong with the motions of stars and other objects in galaxies. The problem was pretty simple. Newton's law states that the square of orbital velocity of an object should be proportional to the force that keeps it in its orbit. In gravitationally centered orbital mechanics, gravity is considered to be the only acting force. So here the velocity of a body should be proportional to the gravitating mass around which this body is revolving. Thus, the velocity of a star or molecular cloud or any other object that moves around the galactic center should be proportional to the mass of a galaxy itself. We're talking about the mass that lies inside the body's orbit. And the actual measurements of velocities made using Doppler effect have shown that they are too big. There is simply not enough mass on the other side of the equation. Mechanically speaking, the centrifugal force should have thrown these stars away long time ago with such orbital velocities, since there is not enough gravitational force to counteract it, to keep them in place. This became known as the galaxy rotation problem, or the missing mass problem. So to provide the necessary mass, Zwicky first proposed to take into account not only the luminous matter, such as stars and nebulae, the mass of which we might estimate to at least some degree of reliability, but also various non-luminous stuff, such as, I quote, cool and cold stars, macroscopic and microscopic solid bodies, and gases. It was in his articles that the term dark matter have appeared for the first time, at least to my knowledge. But as we can see, at least in this quote from 1937, it means just normal matter that simply doesn't shine so bright. Over the coming years, this idea that there should be some sort of invisible matter that might govern the behavior of normal observable matter grew stronger. It was further reinforced from the other side of the universe in terms of scale, and by that I mean the microworld and high-energy particle physics. Theoretical particle physics was in its bloom at that time, with more and more new particles discovered and theoretically proposed every year. So this way or another, it soon became a commonly shared idea that there might be some other, yet undiscovered invisible substance or a set of some unusual particles that correspond to dark matter. By the time when the new observations of galactic behavior were made by Vera Rubin, Kent Ford, and others in 60s and 70s, this idea was already anchored in many people's minds, and one might say that not much has changed ever since. It was generally accepted that the lack of force equals lack of mass, and the latter was accounted for by the action of some yet unknown particles or fields or other quantum objects. For example, it was proposed that supersymmetric particles might be the answer to the problem. Supersymmetry, or SUSY, is a theory that proposes that every particle species should have a partner particle species that is described by other quantum statistics. This means that there should be an undiscovered fermion paired with each known boson, and vice versa. There should be an undiscovered boson per each known fermion. It is worth noting that none of these partner particles were discovered since the inception of the theory in 1966 and wide recognition in the early 70s. In general, modern physics recognizes four fundamental interactions: gravitational, electromagnetic, weak, and strong. The range of the latter two is limited by the size of an atomic nucleus, so they cannot make any difference at astrophysical distances. So we are left only with gravitation and electromagnetism here. And once again, since it is generally supposed that there is no charge separation and there are no electric currents in space, there is only gravitation left. And we're back in the same mousetrap with missing masses and mysterious behavior in violation of Newton's law. By the way, since I mentioned fundamental interactions, in the second half of the 1980s, there also was a proposition that the so-called WIMPs, or weakly interacting massive particles, could be the main component of dark matter. So people tried to construct various types of dark matter particles, including the possibility for them to interact not only by means of gravity, but also through weak interaction. But again, that only gives us the ability to detect them when they hit our sensors, and it doesn't concern the ability to keep galaxies together, which is still considered to be due to gravitation. In this slide, one new article looks interesting. It states that, I quote, "Dark matter may be composed of electrically charged particles." This is an interesting step forward because an electric charge is, by definition, an ability to interact electromagnetically. So in this sense, if dark matter has an electric charge, it is no longer dark, and we actually can see it, although it might not emit a lot. One might say that thus we return to the original interpretation of this term proposed by Zwicky. Of course, that doesn't mean that the authors state that it is the electricity that governs the behavior of galaxies, but we're one step closer to this idea here. In fact, the authors state that these charged particles might then combine to form electrically neutral particles, which they are referred to as stealth dark matter. Thus, they still keep to the standard gravitational scenario, ignoring the possible electromagnetic nature of galactic behavior. It seems like it would still take years for the scientific community to turn to plasma physics and electromagnetism as a significant part in this play. Although it should already be quite clear that instead of violating Occam's razor by inventing some 5 times more matter than there is, maybe it would be better to use the forces and interactions that we already are aware of with the matter that we can observe with reliability. With that being said, and for the sake of completeness, I also want to mention a couple of other options that are somewhat out of the field of mainstream science these days. In general, as I've already said, Newton's law contains not just gravitating mass, but a force, with this mass being only a part of the whole expression. The square of velocity should be proportional to the gravitational constant multiplied by mass around which the object is revolving, and inversely proportional to the distance between them. So if the velocity on the left side is too big, not only we can artificially enhance the mass through injection of dark matter, but we also can suppose that the gravitational constant is not constant. It might, for example, depend on masses or distances. So for big objects like galaxies, it would be different than in our solar system or on planet Earth. And we actually know that the gravitational constant is very hard to measure. Maybe that's because it is not actually constant. It also might be somehow governed by the electric forces, which is not far from the ideas of Walt Thornhill, if I'm not mistaken. There are also attempts in rewriting the Newton's law itself. For example, there is so-called modified Newtonian dynamics, or MOND, developed in 1983 by Mordechai Milgram. While being quite successful in explaining the behavior of galaxies, it still faces significant problems on a slightly bigger scale in galactic clusters. So in my opinion, the field of possibilities is quite broad here, and the idea of dark matter is not in any way more preferable than modifications of Newton's law or consideration of electromagnetic forces. The latter, however, may be somewhat more comfortable since it doesn't require any adjustments to what is considered today as fundamental laws. We just have to discard the hypothesis of charge neutrality in space and consider the actual work of electricity across vast cosmic distances.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
Hey everybody. So as you can see, it's not so crazy of an idea. What's really crazy is the idea that's already in place. That's what's freaking crazy. This doesn't match up with anything observationally.
Welcome to Space News from the Electric.
Oops, I don't even know where I just went.
Welcome to Space News from the Electric Universe. Welcome to Space News from the Electric Universe. On an cold. Half a century ago, at the height of the Cold War, the space race between two competing superpowers set mankind on an accelerated path toward placing a man on the moon. In addition to its geopolitical significance, the moon was central in the evolution of planetary science. The discoveries of the Apollo missions sparked debates and helped solidify new consensus theories about the solar system's history. One of the great surprises was that the pervasive cratering on the moon seemed to come in a single catastrophic period, which astronomers dubbed the Late Heavy Bombardment, a stupendously violent epoch of asteroids or comets supposedly ripping through the inner solar system roughly 3.8 billion years ago. Scientists admit that the cause of this hypothetical event is unknown, though perhaps the most popular theory involves Jupiter and Saturn somehow readjusting their orbits, with another giant planet being ejected from the solar system. However, more recent discoveries have placed the Late Heavy Bombardment theory under fire. Scientists performing new analysis on a melted lunar rock say they have found evidence of no fewer than 4 so-called bombardment events, supposedly over the course of 500 million years, between 3.3 and 3.8 billion years ago. Analysis of another lunar rock, which was found just a few hundred yards away, supposedly shows evidence of still another bombardment, which the scientists say happened precisely 3.83 billion years ago. As one of the scientists told Time magazine, this calls into question just how well we know the chronology of lunar impacts. However, despite the surprising discoveries, it seems that scientists remain unready to question the underlying assumptions about the moon's history. One assumption is that radiometric dating techniques provide with bedrock reliability a timeline of the moon's history over billions of years. Another assumption is that the craters can only be the result of impacts from space. To accept these assumptions requires that one ignore mountains of evidence that high-energy electrical discharges have defined the lunar surface, events that would have left their signatures in the forms of radiation, remnant magnetism, and global electrical scarring. It's useful to look back at the evolution of the consensus theories about the moon in the face of unexpected discoveries. In fact, many of the most surprising discoveries from the Apollo missions affirm catastrophic electromagnetic events in the moon's recent past. It must be noted that one of the great scientific heretics in modern times, Immanuel Velikovsky, made several outrageous predictions about the Apollo findings, including the discovery of remnant magnetism, a steep thermal gradient, radioactive hotspots, and regular moonquakes. A colleague of Velikovsky's, the engineer Ralph Jurgens, conducted a comprehensive investigation and analysis of the puzzling, sinuous rills on the lunar surface. A sinuous rill is a long, winding valley, usually with steep walls and often emerging from a crater, which can be found on the moon at countless scales. Prior to the Apollo missions, astronomers' early hypotheses suggested that the rills were, quote, cracks on the moon's surface. Later guesses included flowing water, until planetary scientists settled on flowing lava as the agent. Today, the accepted theory is that the moon's sinuous rills were created either by lava flowing across the surface or beneath the ground to form a, quote, lava tube, portions of which eventually collapsed. Jurgens compared the respective point-by-point requirements of various competing theories versus the actual observed characteristics of the rills. Unlike planetary scientists, Jurgens included among the possible agents high-energy electrical discharge. On every evidentiary point, The electrical discharge hypothesis is either predictable or permissible. And unlike every competing hypothesis, in not a single instance does the observed evidence preclude electrical discharge as the cause of the rills. However, even prior to Jurgen's investigation, several mainstream scientists had noted that flowing liquids, whether water or lava, could not have caused the observed features of the lunar rills, including the strings of craters along the rill's floors. Today, planetary scientists favor the notion that the famous lunar feature Hadley Rill is a collapsed lava tube. However, the rill does not match the required characteristics of lava tubes on numerous points. Most importantly, the collapsed areas of a lava tube will be rubble-filled depressions. High-resolution images of the rill reveal no rubble and no collapsed roofs. It is simply an empty, sharply cut channel, which matches the expected characteristics of an electrical, quote, breakdown channel. Both the width and the length of the largest lunar rills, extending up to 300 kilometers long, is vastly greater than anything achieved by lava on Earth, with the longest terrestrial rill a mere 35 kilometers long. However, the precise opposite should be expected.
Let's see you there.
On the Earth, the atmosphere is insulating, allowing lava to retain its heat. In the vacuum of space, heat will be much more rapidly radiated away. On Earth, as lava flows for long distances, counted at most in a few tens of kilometers rather than hundreds, the cooling at the surface causes a, quote, roof to form. It may then continue to flow as a, quote, tube beneath the surface. That is the only way the lava tubes can achieve even their modest lengths. Consider the most prominent lunar rill, called Schroeder's Valley, 160 kilometers long and up to 10 kilometers wide. Its depth at points reaches up to an amazing 1,300 meters. Flowing lava eating away surface material to cut a deep channel would have to show up somewhere. We should see either breaches in the deep walls or evidence of abundant outflow. But instead, the channel simply dwindles until it disappears. Curiously, the so-called flow of rills in other worlds isn't limited to, quote, downhill like lava and water-carved channels on Earth. All fluid erosion theories have chosen to ignore that the apparent mouth of the, quote, stream is on high ground, and the narrowest part of the channel is on lower ground. We also note that within Schroeder's Valley is a much more narrow secondary rill whose defining feature is a chain of small craters. Indeed, crater chains on countless planets and moons present yet another puzzle that planetary scientists have failed to adequately explain. Consider this image of the extraordinary lunar crater chain, Katina Devi. Scientists today recognize that neither so-called secondary cratering from a source impact nor volcanism are likely causes of the crater chain. Since there is no evidence that ejecta from any crater overlays any neighboring craters, they are thought to have been formed at the same time in a single event. The consensus today is that a single body broke apart due to tidal effects and somehow produced the exquisite, evenly spaced crater chain. The official website for the Lunar Reconnaissance Orbiter camera describes the crater chain as follows. As was seen with Shoemaker-Levy 9, a weakly held-together planetary body, such as a comet or rubble pile asteroid, can be fragmented and separated by tidal forces if it comes within the Roche limit of a larger body and drawn out into such a string of objects. Similar crater chains have been discovered on several moons of the outer planets where the gravity wells of these gas giants are sufficient to pull bodies apart in this way. What might have done this within the inner solar system where planetary tidal forces are weaker? In the case of Katina Devi, where the impact craters rest shoulder to shoulder, the impactors may have been pulled apart shortly before impact and struck the moon in a rapid-fire sequence of short duration, rather than having been widely separated and striking over time. Among its many problems, this conjecture fails to disclose what we learned in Shoemaker-Levy 9's encounter with Jupiter. As described in detail in the previous space news, Why Don't Comets Melt in the Sun? The extraordinary electromagnetic energies the comet produced were exponentially greater than anything astronomers had anticipated. Whereas astronomers had expected the encounter to be as trivial as, quote, pebbles falling into the ocean, Jupiter's radiation belts brightened and revealed a source of, quote, extra electrons that shocked astronomers and remains a mystery. If Jupiter were a rocky planet, the extraordinary electromagnetic energies would have surely produced the kind of electrical scarring effects routinely reproduced in experiments with electrical discharges, including chains of craters, which appear indistinguishable from the crater chains seen on every rocky body, including the moon. Imagine the improbability of a stream of rocks flying at thousands of miles per hour, creating this chain of cleanly cut, circular craters, all of which appear to have been excavated from directly above, rather than from side-swiping impacts. And here we see emphasized yet another unresolved crisis in the theory of lunar impact cratering. More than 90% of circular craters on the moon require the supposed impactors to hit the surface vertically, forcing theorists to suggest that hypervelocity impacts cause explosions that occur above the ground and generate circular craters. But it's surely no coincidence that electric arcs always strike the surface from directly above. Like every other rocky body in the solar system, countless craters on the moon will never be explained by either volcanism or the impact hypothesis. In a forthcoming Space News episode, we will continue our exploration of the lunar surface, and we'll look more closely at several so-called anomalous craters on the moon and the ideal analog they find in laboratory experiments with electrical discharges. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Today, physicist Wal Thornhill begins a series of reports on some remarkably significant recent discoveries in the space sciences. Like many dozens of previous discoveries we've reported on in this series, we see stunning affirmation of the predictions of the electric universe. A foundational prediction was outlined in the monograph, The Electric Universe, written by Wal Thornhill and Dave Talbot. In the book's synopsis on the electrical formation of stars, Thornhill and Talbot wrote, "Plasma physicists argue that stars are formed by an electromagnetic pinch effect on widely dispersed gas and dust. The pinch is created by the magnetic force between parallel current filaments and are part of the huge electric currents flowing inside a galaxy. Scientists using the Herschel Space Observatory have observed in unprecedented detail filamentary structures throughout the Milky Way galaxy." A recent Phys.org report states, ESA's Herschel Space Observatory has been a true game changer. One of the key aspects that emerge from these observations is the presence of a filamentary network nearly everywhere in our galaxy's interstellar medium. The picture that is emerging is that these structures are closely linked to the formation of stars. The principal investigator of the survey states, "The greatest surprise was the ubiquity of filaments in these nearby clouds and their intimate connection with star formation." Wal Thornhill explains the enormous significance of this discovery for the electric universe theory.
In a few weeks, the Electric Universe Conference for 2015 will begin in Phoenix, Arizona. Supportive evidence for the electric universe paradigm arrives almost daily, and we find each new discovery is either predicted by the electric universe model or else provides more detail. This is the mark of a more correct theory than the present Big Bang model of the universe, where surprises are routine and great effort is concentrated on force-fitting the data to consensus beliefs. In the last few days, 3 important discoveries have been made at 3 very different scales that show we live in an electric universe. First, it was reported that observations with ESA's Herschel Space Observatory have revealed that our galaxy is threaded with filamentary structures on every length scale. From nearby clouds hosting tangles of filaments a few light years long to gigantic structures stretching hundreds of light years across the Milky Way spiral arms, they appear to be truly ubiquitous, so says the report. It goes on, "The greatest surprise was the ubiquity of filaments in these nearby clouds and their intimate connection with star formation. But there's more. These observations revealed that filaments, which may extend to several light years in length, appear to have a universal width of about 1/3 of a light year. This suggests that something fundamental is lurking underneath." End of quote. Of course there's something fundamental lurking underneath. It's called electricity. On Earth, a lightning bolt of constant width can stretch for miles. That researchers have no idea what they're looking at is highlighted by the reference to dense interstellar fibers and the desperate attempt at a solution. Turbulent motions of the interstellar gas and dust create an intricate web of filamentary structures. This is a conspicuous example of force-fitting the observations to century-old, pre-space age beliefs about an electrically sterile universe. Notably, the most prominent filaments are seen drawing matter from their surroundings through a network of smaller filaments. Smaller coronal filaments are also characteristic of electric discharges in plasma. The dysfunctional nature of over-specialized science is highlighted by this report, since plasma cosmologists, including Nobel Prize winner Hans Alfvén, demonstrated empirically decades ago that spiral galaxies like the Milky Way are formed like glowing Catherine wheels strung axially along intergalactic current filaments. Such unexplained galactic alignments have been remarked upon, and stars are formed by powerful long-range electromagnetic dust and gas accretion along the smaller power filaments threading the spiral arms of the galaxy. But astronomers don't attend plasma cosmology conferences, with one notable exception: the radio astronomer Gerard Verschuur. You see, these cosmic power filaments radiate in the radio, microwave, and infrared region of the electromagnetic spectrum. So it was, some years ago, that Verschuur teamed up with a leading plasma cosmologist, Anthony Peratt, to show unequivocally that current filaments, like those Herschel has now confirmed, exist near the Sun. Priority for this discovery should go to these scientists. Characteristically, the report ends with a claim that despite this surprise, everything is under control. And I quote, "An increasingly coherent picture is now emerging from combining the analysis of these data with predictions from theory and numerical simulations as astronomers continue to study the physical processes underlying the fascinating origin of stars and planets." End of quote. Computer simulations are worthless when the theoretical concepts being modeled are incorrect. At incalculable cost, the Big Bang universe has become a computerized virtual reality game. Anything you can imagine can appear real. Such an infinitely adjustable cosmology is unfalsifiable and therefore unscientific.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
Ooh, I'm slacking. Sorry.
Welcome to Space News. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. The Greek writer Nikos Kazantzakis once said, "Since we cannot change reality, let us change the eyes which see reality." Today, countless thousands of inquirers are looking at the world and the universe beyond with changed eyes. When one gazes at our celestial neighborhood, the planets, moons, comets, and asteroids we see defy the speculative history we learned in school. These bodies testify to events not included in any geology textbook. The evidence seems undeniable. High-energy electromagnetic events have indelibly scarred, and in some cases devastated, the rocky bodies in our solar system. Today, this seemingly outrageous theory is being put to the test experimentally. One of the most remarkable of these experimentalists is Billy Elberton, who has successfully replicated countless planetary features through experiments with electrical discharges and electric fields. Here we provide a brief overview and introduction of Billy's research. We begin with a discussion of an especially fascinating experiment that produced features resembling cellular structures, which are also seen on some planetary surfaces.
It started with the two copper conductors or two metal conductors. The bottom plate was generally an iron plate we use in our tests, and the upper plate happened to be a copper sheet. First time that we noticed them, and it's during the time when we do the lifting effect, which raises these columns of sand or clay. And if you look under the plate after the discharge is over, what we found is that there tends to be some sort of condensation of moisture, either must be from the atmosphere or, the humidity in the air. However, it tends to, condense in the sand and the clay there. It causes it to harden up, and it also causes it to cake up on the bottom of the electrodes in these same patterns that we see, cellular shape, fairy circle. So it's pretty incredible to see that. To be honest, my jaw fell open, really. I really didn't know what to think. I called Ben up. He and I looked at the pictures and whatnot and discussed it. He put it in the morning news the next morning. The first thing that came to mind was cellular. I know we can't say it's biological because it's not at all biological, but nonetheless, it had a biological appearance to it. Central Africa has quite a bit of those fairy circle features. And the Giant's Causeway in Northern Ireland is where these columns.
I noticed first thing you got to do is get people to understand that the science isn't even as correct and confirmed as they all have been led to believe that it is. Then let them think about why. Because if you start trying to tell them why first, they're going to just say, oh, you're crazy. Blah, blah, blah. And they won't look at the science. I think I went head first last time doing that. Trying to, why? Figure out why. Because at some point in your research, you start to realize that this shit was already known, just not in our textbooks.
With a single overhead anode or cathode, actually, it doesn't really matter. And those were done again with dark mode. And then we've also created several crater chains.
Chains. My volume got killed.
And singular craters through layered material with the lightning bolt with the arc mode. We get a lot of the same features. The rays that tend to scatter out quite a distance from the center of the crater. We created that quite a few times too. And the raised rim, you literally can't tell the difference between that and an impact.
In the Thunderbolts project's documentary film, The Lightning-Scarred Planet Mars, it is proposed that the towering so-called shield volcano Olympus Mons is in effect a lightning blister from an enormous electrical discharge. Has Billy achieved similar features in his experiments?
We did a couple tries there with the arc mode discharge on some clay that I mixed up with water beforehand, and almost like a mud peanut butter texture to it. And those do produce, of course, it's a gaseous effect. We're heating the liquid up, turning it back into gas again, and it kind of creates like a blister. And these do resemble Olympus Mons. They take on a concentric type ridge pattern as they step up higher and higher as the center rises up. But again, that could be, as a process of heat and, steam and pressure creates what's similar to a volcano, actually. I mean, in my opinion, if you look at this whole thing overall, volcanoes are electric discharge. This is the induction mechanism here. This is what is causing the rock to turn to lava. The volcanoes all tend to be this lifted mechanism, similar to a blister or something like that. A raised feature. It can be done with or without the arc mode. We've shown that too. But the long mountain ranges, I found that so far the best reproduction that I've done on the table is with the vibration. Which if we look at this type of cataclysmic event that may have actually happened, we'd have to associate some rather large earthquakes with some of these events anyway. And what I found is that most earthquakes take place today between, less than 1 hertz up to about 20 hertz in frequency. And I played around with that a little bit on the table with a vibrator, just an offset counterweight. And I determined the frequency by calculating the RPM. And at about 25 to 30 hertz, we begin to do the exact same process as we see all over. We get raised dendritic features, raised mountain ranges with the feather back, formations. And so that's another road I want to travel down here shortly, is to integrate this earthquake feature into our electric discharge. Because, we know that electricity carries these type frequencies with them. A lot of work that Ben Davidson's done is, all but prove that electric discharge is what creates earthquake. So we'd have to assume sooner or later that they are integrated together.
Given the proven ability of electrical discharges and electric fields to produce familiar geological features, then much traditional geology must be reassessed. One intriguing example is the production of sand dunes by ionic wind. This opens the door to a new interpretation of mysterious sand dunes found on Mars, on the Saturnian moon Titan, and most stunningly, even on the comet 67P.
Those are quite common, actually. And if you watch this happen on a sheet of acrylic or any type of a dielectric sheet, yeah, I mean, it unfolds right before your eyes, literally. And you can see that it's an ionic wind that's created by the discharge that's doing this on the table. And to see it perform almost the same way we do in nature makes you really want a second, opinion on what actually causes the wind to blow, because the features are identical, whether it be, what we consider to be weather-driven wind forces by heat and pressure. We can recreate the same duning effects with nothing but electric discharge. It is incredible. And to find these type features on the 67P recently, that really speaks volumes when there's no atmosphere there.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
Here's a good one. The Grand Canyon in the lab.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Earth geology is primarily a tale of incremental changes over eons of time. Processes occurring over millions of years are thought to have created our planet's most wondrous geological features. However, within the electric universe community, scientists and independent investigators have explored the evidence that high-energy electromagnetic events have dramatically reshaped the Earth and many other planets. The indelible mark of such an event may be found at the Grand Canyon. Standard geology tells us that the Colorado River began forming the Grand Canyon 20 million years ago. As tectonic forces raised the surrounding terrain, the river continued carving the canyon for millions of years. Proponents of the electric universe have proposed that the canyon is in fact a giant lightning scar, or a quote Lichtenberg figure at an enormous scale. Yet within the electric universe community, theoretical disagreements do exist. For nearly the past decade, professional photographer Michael Steinbacher has personally explored the geology of the American Southwest. Michael proposes his own theory for the formation of the Grand Canyon, in which electrical events still play a decisive role. Recently, Michael's theory has gained support in the research of experimentalist Billy Elberton.
I came out west 7 years ago, trying to understand the process of the geology that I saw on my way out west. It just put a hook in me. I became obsessed. And I tried to understand it. And I actually bought into what was considered the EU explanation of the Grand Canyon, that there was a mountain there first, a lightning bolt went through the mountain, excavated the canyon, a river had been flowing somewhere else, a drainage, what is today the Colorado, and it took advantage of this newly excavated canyon and decided to flow through that exit to the sea as opposed to where it had been. I assume everybody assumes it had to have been somewhere else at one point. I went looking for that, and I had the best of intentions. And I started seeing smaller canyons that didn't appear to be that process. They appeared as if the drainage had been there first, and then something grew around the drainage. And I kept seeing this pattern repeat itself over and over. And then one day it struck me, geez, I think the Grand Canyon might be the same. And I wasn't looking for it. I wasn't looking to stir up trouble. It just seemed like there was a consistency to rivers preventing accumulation of airborne material coming down from above and growing while the river washed away what was getting blown into it. And I started looking, and lo and behold, it seemed as if the river had been there first, and then something transpired to cause the canyon to grow around it. And I started studying the hydrology and where the Colorado River comes from. It comes from Wyoming by way of the Green River. It drains a massive area. And then the Colorado goes over the Rocky Mountain National Park. Everything west of the Continental Divide flows into the Colorado. And then as you go south, everything west of the Continental Divide goes into the Gunnison. All three of these meet up around Canyonlands, forming this huge drainage. It appears as if something caused the formations around the drainage to grow to varying degrees, depending upon how long they were dry. The longer something is dry, the longer it grows. So the highest points will grow the most. The lowest points will get growth towards the end of the flooding. And this area is really prone to flooding during catastrophic events. If the sun rises where it used to set, 68,000 feet of additional sea level at the equator is going to rush north and south. It's going to come up into the Colorado drainage and get trapped as if it was a bathtub, an enclosed system. There could be east-west component to the flood, but we can look at in this case, south to north component, where the rivers ran in reverse as described by legend. And the Colorado is right in the perfect spot to be affected by the floods like this every time. And then it struck me, wouldn't it be great if Billy Yelverton could do experiments dropping dust from above? And he accomplished that. And then I gave him a new challenge, and I asked him to add a water element, to put a flowing stream of water while there's dust coming from above, while there's an electromagnetic event going on. And he did that. And people were watching me watch this video for the first time, and they watched my expressions, and I was just blown away. It was like the greatest night of my life. And you could see a formation grow on both sides of a drainage that Billy had created. And it grew faster and faster. And there was a water element involved. It was damp where it was growing. And it was as if the dust was coming in from both sides. We'll be showing videos of this while I'm speaking. You'll be seeing what we're talking about. There's different versions of Billy's experiments with a moving water element, while material is electromagnetically sorted, it appears, and accumulated over the drainage. And it shows that water will remove material falling from above, preventing accumulation where the river is. And then it shows that you can get accumulation in different patterns, something similar to a mountain where it trends in one direction or another. It's like welded tuff type formations. But in the case of the Grand Canyon that Billy created or simulated in his garage, the layers are more horizontal. And Andreas Otte, my friend who goes out into the field with me every year, noticed that the Grand Canyon had sort of horizontal layers. They didn't trend in one direction or another severely like welded tuff does, or tuff, where there's an obvious trending direction. The Grand Canyon has some trending this way, that way, a little bit here and there, but it's kind of horizontal. And what Billy did seems as if it's more horizontal, as if there's material coming in towards the drainage from both directions, so that the canyon on either side would be leeward, and then on the other side of the rim of the canyon would be windward. So you'd have two leeward sides for the canyon, as if the material is being sucked in to that central area. So this is a completely different way of looking at the Grand Canyon. I'm not sure how many formations on Earth are of this ilk, but this is all because of the electromagnetic event that's transpiring over the Southwest U.S.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info.
Are you taking out? Oh, okay. Sorry.
In April of 2015, the NASA Dawn spacecraft began transmitting new close-up images of the mysterious dwarf planet Ceres. The images to date have only deepened the mystery surrounding the
I'll get
puzzling
bored
bright
and do it,
spots
or
on the
have a
planet's
conversation with
surface.
somebody.
More
So they
recent
can get,
images
you
have
know,
shown
more
that the
info
bright
out of it.
spots appear to differ in nature, and in fact, closer images have shown a multitude of bright spots at the site of the
refreshes me
original
too on a
puzzling
lot of stuff.
features. According to the latest reports, the bright spots appear to be shrinking as the spacecraft approaches. It may be possible that we're simply seeing a reflective material, yet we do note that electric arcs concentrate energy on a very small area, so that we might expect the bright spots, if they are electrical, to show more fine structure, which is to say, more even smaller bright points, as the resolution improves over coming weeks. However, in addition to this ongoing mystery, questions remain about Ceres that planetary scientists seem unready to ask. The surface of Ceres is massively cratered, with a variety of types of craters, including so-called bullseye craters, and craters with central peaks, weird hexagonal craters, such as those seen on Mars, Mercury, and the Saturnian moon Mimas. The cause of craters and rocky bodies is a puzzle that planetary scientists have long ago considered resolved. However, Dawn's exploration of Ceres is a startling reminder of just how inadequately the modern theory of planetary cratering explains what we actually see. In the thinking of planetary scientists, impacts from intruding bodies have caused most of the craters on our solar system's heavily cratered planets and moons. From this perspective, one is left with the impression that impacting objects are as ubiquitous as they are devastating. But why should this assumption remain unchallenged? Some bodies in the solar system are so heavily cratered that a special, quote, late heavy bombardment had to be included in the speculative history of the solar system. Astronomers are not sure where the, quote, bombarding objects came from. In addition, most planets and moons show mysterious hemispheric differences in cratering. Most striking is the planet Mars, where the heavily impacted southern hemisphere stands in stark contrast to a northern hemisphere almost entirely free of craters, an impossibility under the usual theoretical assumptions about planetary origins.
I don't even know what day it is.
Let us now consider the electric universe theory of cratering on planets and moons, which states that massive electrical discharge events occurred in a relatively recent epoch of planetary instability. The detailed features of countless craters on planets and moons do not match attempts to recreate them in laboratory experiments with either explosions or projectile impacts. The massive cratering that covers Ceres from pole to pole defies the notion of cratering by impact. As one observer recently remarked to the Thunderbolts project, far too many of the craters are, quote, 90 degrees axial to the center of the body, as if every single so-called object impact was vectored exactly towards the nucleus, leaving no side-swiping impacts. Let's see the math that speaks to such a probability. This image displays the evidence of a globalized dynamic process. The geofeatures are not a history of individual crater impacts. We also note that Ceres lacks the necessary gravity to influence the paths of incoming objects at speeds sufficient to cause such circular cratering. Many of astronomers' ideas about cratering became solidified through the scientific investigation into the moon. However, not included in the scientific debate was the evidence for crater formation through high-energy electrical discharges. Let us look back to the mid-1960s, when amateur astronomer Brian J. Ford explored the possibility that lunar craters may have been the result of plasma discharges. In 1965, Ford wrote, "It is clear that craters produced by an electrical discharge show central peaks in the ratio of approximately 1 to 3 in the small craters, or nearer 50-50 where the largest craters are concerned." Ford's experiment, which involved electric discharge machining and a plasma oven, produced patterns remarkably similar to those seen on the moon. Ford also addressed the long-standing puzzle of why smaller craters appear preferentially on the rims of larger craters. He wrote, "There are no examples of a large crater overrunning one of smaller diameter, although smaller craters may often interfere structurally with those of larger diameters. It is impossible for any random bombardment to prove so selective. Electric arcs always strike the surface from directly above." Let us again consider a side-by-side comparison of the surface of Ceres with an image of anode cratering in an electrical discharge machining process. What we actually see on Ceres is directionality of the craters, and a startling absence of, quote, side-swiping impacts. A clean circular appearance of craters, central craters within craters, and craters with central peaks, and the preferential appearance of smaller craters on the rims of larger craters, all consistent with the electric discharge theory of crater formation. They are not consistent with the theory of random impacts. Over the past 2 decades within the electric universe community, independent researchers have explored a broad field of observational data, bearing directly on an electrical interpretation of planetary surface features. Let's consider just one recurring anomalous crater form seen on many rocky bodies. In numerous instances, we see hexagonal craters on Mars, Mercury, and on Saturn's moon, Mimas. We also see geometrically weird, square-shaped craters, such as those seen on the asteroid Eros, on Mars, and with Earth's own meteor crater. An hexagonal form is an acknowledged trademark of an electric discharge process. These same hexagonal forms are seen on Ceres, pointing us to the same electrical forces that have received too little attention in planetary science. The Dawn mission is a remarkable opportunity for scientists to gain a new understanding of our solar system's history. But science can only progress when new horizons are explored and old ideas abandoned as the evidence demands. And the evidence overwhelmingly tells us that the recent history of our solar system was far more dramatic than we have ever been led to believe. For continuous updates on NASA's Dawn mission to Ceres, stay tuned to Space News from the Electric Universe.
This one ought to.
Today, individuals who wish to
good one
learn
for
about
you guys in the
unconventional
chat.
or unpopular theories
already know
face
about
an
this shit.
enormous obstacle. Before determining the theory's validity, one must first gain an accurate understanding of what the theory actually proposes. For individuals seeking to learn about the electric universe, this task is remarkably difficult due to rampant misrepresentations of the theory, both by uninformed or sensational would-be proponents and critics of the theory alike. A surprisingly prevalent tactic against the electric universe is the characterization of its proponents as, quote, conspiracy theorists. Let us lay aside for the moment the question of the prevalence of actual, quote, conspiracies, both throughout history and in the world today. Let us explore instead, why is this accusation made specifically against proponents of the electric universe?
I want to talk today about why it is that people who believe that there is some problem with scientific theory are frequently labeled online as conspiracy theorists. What this talk is not about are people who actually talk about conspiracies. I'm specifically referring to the situation where one person is talking about science and the other person is calling that first a conspiracy theorist. This happens enough online that it demands some sort of an explanation. I would argue that this practice is enormously destructive to society's ability to talk about lesser known innovative ideas in science. If every time that people want to talk about an idea in science which diverges from the textbook theory, there is this societal reaction to isolate and label that activity as something it is not even intended to be, I think there needs to be a very strong reaction to this subtly destructive behavior. Michael, as you very well know, plasma cosmology is a topic that has been published in IEEE's Transactions on Plasma Science for many years now.
Because I've watched them all dozens of times, and I know which ones to go sifting through.
The theorists have traditionally sought out inferences for astronomical observations which pertain to classical physics principles, electricity, magnetism, plasmas, double layers, and so on. And the methodology itself is really quite scientific insofar as observations within plasma laboratories like tokamaks of filamentary electrical structures have inspired theorists to suggest that cosmic plasma behaves in similar ways. It's a perfect example, really, of what is meant by empirical science. So why is it that when people refer to the electric universe, or more appropriately plasma cosmology online, these people are commonly labeled as conspiracy theorists? The fact of the matter is that there isn't a trace of conspiracy within the Thunderbolts Group's publications. These theorists are talking about plasma science, astrophysics, and cosmology, and their thesis is that academic institutions should be modeling the cosmic plasma to better match our observations of laboratory plasmas. There should be no confusion that there are mistakes in the textbooks right now, and history is just littered with spectacular examples of mistaken expertise. And Michael, they all have something important in common. Try to see if you can pick up on what I'm referring to as I run through 4 significant examples. Number 1, when radio waves were first observed coming from space by radio engineers, the astronomical community assumed it was either a mistake or a hoax. Second, when the maser, the laser's microwave precursor, was invented, the world's most prestigious quantum theorists claimed that the prototype, which was already created, was impossible due to the Heisenberg uncertainty principle. Third, it wasn't that long ago that the scientific community regarded meteorites in the same way that modern scientists regard UFO abductions and psychic phenomena, quaint superstitions only believed by peasant folk. And fourth, rocket-powered spacecraft were ridiculed virtually all the way up until 1944 when they started raining down on London during World War II. The common aspect that people tend to miss with these stories is not the simple fact that the entire scientific community was wrong. I think the most people generally understand that this has happened. The key aspect to realize is that the scientific community does not today strive to teach these stories as lessons which students of science and the public can learn from on the nature of scientific consensus. And so there evolves a predictable public perception that these kinds of fundamental mistakes are rare in our modern times. I want to quote Bill Beatty. He says, "Intellectual suppression has a long history involving eccentric but revolutionary science. Throughout the history of science, famous researchers who eventually created entire new fields of science initially found it nearly impossible to publish their research. Some didn't succeed for years, even decades. The scientific community ignored them, but eventually they were heard. Eventually they conquered the suppression, but only after a major fight. The journal editors rejected their papers because the new research results were in conflict with common knowledge. It was too eccentric. Yet the eccentric ideas were right, and common knowledge was not." Skipping ahead, note well that nobody conspired to silence these revolutionary researchers. Editors and fellow scientists simply assumed that the eccentric papers were misguided. So that is the vital context for the question that I want to pose. If we don't need conspiracies to explain why experts and textbooks have, even in modern times, been wrong, then why do people commonly conflate those who disagree with textbook scientific theory with conspiracy theorists? Here is my unexpected answer to this tricky question.
I say it's a conditioned response.
The story more or less starts with Edward Bernays, the relative of Sigmund Freud, who showed American corporations for the first time how they could make people want things they didn't need by linking mass-produced goods to their unconscious desires. Quoting Pat Jackson, Bernays' colleague and public relations advisor, "What Eddie got from Freud was indeed this idea that there is a lot more going on in human decision-making, not only among individuals, but even more importantly among groups, than this idea that information drives behavior. So Eddie began to formulate this idea that you had to look at things that will play to people's irrational emotions." So where am I going with this? The point is that here in the United States, we are already accustomed and actively encouraged to behave irrationally all the time. It's just an aspect of how businesses sell things. So given this history, which clearly has nothing at all to do with a conspiracy, here's what people need to ask themselves. Does this subconscious aspect of the mind simply shut up when the subject switches to science? Or alternatively, can we think of this ideal of thinking like a scientist in part as a process of keeping these natural subconscious tendencies in check? Fast forward more than half a century to 2002, when Daniel Kahneman was awarded the Nobel for taking Bernays' ideas to the next level. For many years, the practice of marketing, whether for a product or an idea, was considered a sort of fluffy black magic by CEOs and others because it lacked an actual model for what was happening in the mind in regards to human decision-making. That all changed with Kahneman's contributions to decision science, whose work has come to affect all of the social sciences. My own suggestion will be to propose that Kahneman's work can naturally explain this conspiracy theorist labeling. And the implications are enormous, if I'm right, for the way we talk about science online, because it ultimately points the way to how we might design future social networks that aim to make online discourse more scientific. Kahneman's claim is that when a person encounters complexity, they will either consciously or implicitly realize they lack both the time and inclination to research this claim. If he's right, then that realization arrives as a feeling, which makes it faster than any rational thought, and therefore our initial reaction. That feeling then primes whatever rational thought that follows. The subconscious is a natural reaction to everything that happens to us based upon the patterns we've formerly experienced. The key is to realize that you don't intentionally think it, it happens to you. This process, more formally known as associative coherence, appears to the rational thinker as believable narratives. As probably most adults would acknowledge, these seemingly fully formed ideas just pop into our heads. The thing about associative coherence that is not widely understood by the public is that it benefits from a lack of detail. As details are added in, what happens more often than not is that the believable narrative turns out to be wrong. So what I see a lot of online is that people have formed a system of beliefs about science, which they subconsciously use as a filter to limit the effort of rational thought. And this is a natural response to information overload. These largely subconscious decisions to refuse to learn about something can create significant ignorance of that particular thing. And this can happen even if the person is extraordinarily intelligent in other aspects or activities. Much of the news media, by the way, actively encourages and reinforces this filtering behavior. So here's the important bit. This empty cognitive space becomes a playground for associative coherence. People who have not actively sought to teach themselves about certain things in science must fall back onto these far simpler pattern-based processes for evaluating claims about those things. My own personal observations online confirm for me that Kahneman is right, that this behavior is extremely common, even amongst academic researchers. So what I'm saying is that when a person does not actively seek to develop a nuanced understanding of academic research, things like how it works, the limits of scientific methodology and domains, critiques by whistleblowers, critiques of peer review, and historical examples of failed expertise. The people who refuse to actively learn about these things are more prone to simplistic associations of those who disagree with textbook theory to conspiracy theorists. I see it all the time.
Right.
People who label others that are actually talking about science as conspiracy theorists will completely ignore the scientific arguments being made and project their own lack of understanding upon the very person that is trying to educate them about some innovative scientific idea.
Story of my life.
As Kahneman's model continues to disseminate throughout our culture, I believe that it is just inevitable that we will build communication systems which help people to see their own tendencies towards associative coherence by exposing it in the others they are talking to. We cannot see it in ourselves, but we can see it in others. And in that indirect way, we can make online scientific conversations more scientific.
And now we're going to talk about something that's a little more directly related to what I would call suppression of information by government. And you'll see why I call it that, because what the hell else are you going to call it at this point when it's come to this? Look.
Never before in human history has a greater abundance of information been available at one's fingertips. We turn to the internet as a source of news and factual data, and also as a means of exploring opinions and viewpoints not represented in traditional media. But is one's journey through the World Wide Web as free and open as it might seem? From advertisements that websites generate based on one's web history, or the suggested videos that YouTube generates based on one's viewing habits, and even Facebook's bizarre psychological experiment, which manipulated user news feeds to evoke emotional responses. The manipulation of one's internet activity has evolved into nothing less than a science. It should then come as no surprise that this manipulation can include efforts to restrict one's access to certain ideas and information. Many disturbing examples demonstrate that scientific debate and inquiry on the internet is not always free nor open. For instance, in 2013, the website popularscience.com chose to shut off its comment section, claiming in their official statement, "A politically motivated, decades-long war on expertise has eroded the popular consensus on a wide variety of scientifically validated topics. Everything, from evolution to the origins of climate change, is mistakenly up for grabs again. Scientific certainty is just another thing for two people to debate on television." A similar attitude is conveyed in the long-standing war that self-styled skeptics have waged for control of Wikipedia, particularly entries that deal with scientific controversies. The website skeptic.com declares that Wikipedia is a, quote, "shining opportunity for the skeptical movement." Wikipedia is among the most important public sources for almost any scientific, pseudoscientific, or paranormal topic. A Wikipedia article is almost always the #1 Google hit for that subject. Self-styled skeptics may be pleased by the recently announced Google plan to begin manipulating search engine results to reward websites based on their apparent factual soundness. The stated purpose of the plan is to reduce in Google searches the visibility of sites that promote, quote, "misinformation." Why was this plan constructed? And what effect will it have on the public's use of the Google search engine as a means of inquiry?
What happened is that in late February or early March of 2015, Google published a paper called Knowledge-Based Trust with the subtitle Estimating the Trustworthiness of Web Sources. And this is a paper that was describing a feature that's not yet implemented in Google search. Here I'm going to quote a New Scientist article on basically the article is titled "Google Wants to Rank Websites Based on Facts, Not Links." And they describe it as follows. Google's search engine currently uses the number of incoming links to a web page as a proxy for quality, determining where it appears in search results. So pages that many other sites link to are ranked higher. This system has brought us the search engine as we know it today, but the downside is that websites full of misinformation can rise up the rankings if enough people link to them. A Google research team is adapting that model to measure the trustworthiness of a page rather than its reputation across the web. Instead of counting incoming links, the system, which is not yet live, counts the number of incorrect facts within a page. A source that has few false facts is considered to be trustworthy, says the team. The score they compute for each page is its knowledge-based trust score. Okay, so I have 3 reasons to be wary of this idea, and with the caveat that there are likely many more, but these are the 3 that I would personally point out. As to try to identify and isolate pseudoscience, there's also dogma and groupthink that's actually in some of our most respected academic organizations. So as a critical thinker, you're tasked with trying to figure out whether or not something is either of those 2 extremes. So the Google paper, if you take a look at it, it actually uses the debate over Obama's birthplace almost as like their sole example.
Right.
And I would argue that pretty much trivializes the complexity of what they're actually trying to do. And people in the Electric Universe community are already probably aware of the long-standing debate, very complicated debate between adherents of the Astrophysical Journal and IEEE's Transactions on Plasma Science over how to model cosmic plasmas. This controversy has been going on for more than half a century now, and it was popularized by a Nobel laureate, Hannes Alfvén, who used the occasion of his 1970 Nobel acceptance speech to lay out his case against the astrophysical community. So if Google wants to try to tackle this problem, I think it's a fantastic idea, but are they, when they design their truth engine, are they going to be using real world examples to test their design? That's a question that I pose to them. If they want to get into the scientific controversy business, then they should be studying that debate that I mentioned and how their system reacts to it as a reality check on whether or not their approach is actually going to be a good approach. My second reason to be wary, because not all scientific domains are equal. Nobel laureate Daniel Kahneman's now famous text, Thinking Fast and Slow, has an excellent chapter titled Expert Intuition, When Can We Trust It? He asks 3 important questions and provides 3 critical observations. The questions: how can we evaluate the probable validity of an intuitive judgment? When do judgments reflect true expertise? And when do they display an illusion of validity? Kahneman provides 3 heuristic answers, which are not guaranteed to be accurate, but decision theory experiments show that they generally are in practice. The research domain first requirement: the research domain must exhibit sufficient regularity to be predictable, and there must be an opportunity to learn these regularities through prolonged practice. When both of these conditions are satisfied, intuitions are likely to be skilled. However, some domains are worse than irregular, sometimes referred to as wicked environments. Professionals in these domains are likely to learn the wrong lessons from experience. And then the third heuristic that he provides is whether professionals have a chance to develop intuitive expertise depends essentially on the quality and speed of feedback, as well as on that sufficient opportunity to practice. So notice that all 3 are comments about the nature of the data itself. And by these standards, the endeavors of climate science, cosmology, and astrophysics should all be viewed with some level of skepticism by information consumers. The data, is not consistent, hence dark matter and the climate model's failure to make accurate predictions. Right now, there is this never-ending risk of learning the wrong lessons due to the fact that people will even argue over what is being observed in some of these domains. And there's this very slow process of feedback in all 3 endeavors. So my question for Google is, how will Google treat facts associated with these types of domains? That's, to me, an enormously important question. The third reason to be concerned.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Scientists using the BICEP 2 telescope recently pronounced they had discovered direct evidence of Einstein gravitational waves and cosmic inflation. The team describes having detected polarizations in the so-called cosmic microwave background, which is described as the afterglow of the theoretical Big Bang explosion. Science media have declared the discovery a victory for Big Bang cosmology. However, omitted from the science press releases are countless foundational problems for the Big Bang theory. We asked mathematician Stephen J. Crothers for his interpretation of this latest announcement.
BICEP 2 is a telescope located in Antarctica at the South Pole. This device is described as a polarimeter because it is alleged to be able to detect polarizations in the so-called cosmic microwave background, that is the CMB, due to Einstein gravitational waves generated by an inflationary epoch of some Big Bang universe. The report by the BICEP 2 collaboration that they detected polarizations in the alleged CMB is claimed to be evidence of both Einstein gravitational waves and a Big Bang inflationary epoch. However, BICEP 2 has not detected Einstein gravitational waves and has not affirmed either an inflationary epoch or a Big Bang creation event. Let's consider the salient issues other than the actual operation of the instrument and the methods of data collection utilized by the BICEP 2 collaboration. On the basis of Big Bang cosmology theory, the BICEP 2 collaboration assumes that the universe spontaneously sprang into existence from nothing, or from a point possessing infinite density, infinite pressure, and infinite hotness, called a singularity, although nothing and singularity are actually indistinguishable from one another, since a point has no volume and thereby incapable of possessing density, pressure, and hotness, let alone infinities thereof. They assume an inflationary epoch in some Big Bang expanding universe. They assume the existence of a cosmic microwave background, the alleged afterglow of some Big Bang creation event. They assume that they can separate the galactic foreground signal from the alleged CMB and the latter's multipoles. They assume the existence of Einstein gravitational waves. They allege that Big Bang cosmology predicts that primordial Einstein gravitational waves are generated during an inflationary epoch in the history of the universe. In a paper titled Bicep 2, 1, Detection of D-mode polarization at degree angular scales, Adi et al. Say that inflationary cosmology extends the standard model by postulating an early period of nearly exponential expansion, which sets the initial conditions for the subsequent hot Big Bang. A definitive test of this paradigm would be of fundamental importance. Gravitational waves generated by inflation have the potential to provide such a definitive test. Inflation predicts that the
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts
This one's better, and
Project
it says
at
some of the same stuff in it. Sorry, guys.
thunderbolts.info.
It just has more
A new
illustrations
paper
as well.
published by an MIT physicist claims to theoretically prove that so-called quantum entanglement, or two particles each seemingly occupying multiple states simultaneously, gives rise to a wormhole, which allows particles to communicate through a so-called gravitational tunnel. This theory follows from a paper published earlier this year, which suggests that when two black holes become entangled, then are pulled apart, a wormhole is created which connects the black holes. The reasoning in these papers follows from a purely mathematical approach to physics and cosmology. In this two-part presentation, physicist Wal Thornhill
covers that
examines
and
just
this
how
at the same
reliable
time,
this
so-
approach is at describing how the
cool.
universe
Thanks, Lee.
actually works.
A glaring example of the irrational is to be seen in a recent Science Daily report titled, "You Can't Get Entangled Without a Wormhole," which refers to papers by Julian Sonner, a senior postdoc in MIT's Lab for Nuclear Science and Center for Theoretical Physics, and a related paper by Kristen Jensen of the University of Victoria
Oh, come on.
and Andreas Karsch of the University of Washington. The
Put
article
it
says that
back.
essentially, entanglement involves two particles, each occupying multiple states at once, a condition referred to as superposition. For example, both particles may simultaneously spin clockwise and counterclockwise, but neither has a definite state until one is measured, causing the other particle to instantly assume a corresponding state. The resulting correlations between the particles are preserved even if they reside on opposite ends of the universe. End of quote. Now, the word entanglement is a euphemism to hide the fact that the physical connection is unknown. So all that follows isn't physics, it's mystification. The indeterminacy of states also means we're not dealing with physics, which relies on being able to determine the state of the system being observed. From a real physicist's point of view, the most telling experimental fact is that the connection between two entangled particles is instantaneous, even if they reside on opposite ends of the universe. So the article asks the question, but what enables particles to communicate instantaneously and seemingly faster than the speed of light over such distances? The simple classical physics answer is that the connection between the two particles is not via a slow transverse electromagnetic wave. Instead, it's the same kind of connection that we observe between the planets and the sun. That is, gravity. Newton's law of gravity does not include time. The force of gravity acts instantaneously. Now, the electric universe explains that gravity itself is a form of the electric force that operates upon neutral bodies by distorting the subatomic charged particles within those bodies to form tiny, weak electric dipoles. This simple model explains why gravity is such a weak force, because subatomic particles are infinitesimally small, and also why you can't easily shield from gravity, because all of the subatomic particles participate, whether it's a conductor or a non-conductor, whatever it's made from. Importantly, though, gravity on the cosmic scale allows us to see that the direct electric force between particles operates instantly. The spookiness and non-locality of quantum phenomena can be understood both physically and in meaningful language.
For all those who accept spooky at a distance and it makes you feel good, raise your hand. Well, spooky action at a distance it is. Derp.
Entanglement, then, is simply an electrical resonance between two subatomic particles, each comprised of an identical resonance system of orbiting charged subparticles. In other words, it's a repeated pattern, like an atom within an atom. The instantaneous connection maintains the resonance or entanglement between the particles regardless of their relative movement or distance apart. Because the connection is instantaneous, there is no Doppler shift detuning or anything like that. The two particles remain in communication. This model that separates the phenomenon of electromagnetic waves in a medium from the direct longitudinal connection between all matter in the universe, that is the electrical connection, opens up new insights for physicists. For example, physicists attempt to isolate their experiment from outside influences, including the observer. But in our electric universe, there is no isolated system. The observer is a part of the experiment, whether he likes it or not, and as discovered in so-called weird quantum experiments. Contrast this simple explanation with the meaningless language of the report, and I quote, "Earlier this year, physicists proposed an answer in the form of wormholes or gravitational tunnels. The group showed that by creating two entangled black holes, then pulling them apart, they formed a wormhole, essentially a shortcut through the universe, connecting the distant black holes. Now, black holes are a mathematical mistake equivalent to the school mathematics howler of dividing by zero to get infinity. Gravity is weaker than the electric force by a factor of 1,000 billion times. Now, that's as close to zero as you can get. So using gravity to explain the concentrated energy sources observed at the centers of galaxies and calling them black holes is bound to give you answers that make no physical sense. The wormholes are constructed in more than 3 dimensions, so they have nothing to do with the real space that physicists, engineers, and you and I have to deal with." But the article continues. Now an MIT physicist has found that, looking through the lens of string theory, the creation of two entangled quarks, the building blocks of matter, simultaneously give rise to a wormhole connecting the pair. That's the end of the quote. But string theory is, according to Peter Woit, not even wrong. The questions that need to be answered by this piece of whimsy are both endless and pointless. Pointless because no one knows what a quark is, nor how matter can warp space to form a hole across the universe, or even what that means, nor how that effect can be instantaneous. Space is merely a concept of location in 3 dimensions. How do you warp a concept? But the article goes on. The theoretical results bolster the relatively new and exciting idea that the laws of gravity holding together the universe may not be fundamental, but arise from something else. Quantum entanglement. That's hardly a breakthrough when you don't understand quantum entanglement. You'll notice that modern physics is in the business of complicating things beyond comprehension, inventing new particles and forces in the hope of a Nobel Prize. It is not the way classical physics was done. Classical physics, until the beginning of the 20th century, was in the business of simplifying particles and forces. There was a strong intuitive feel on the part of leading scientists then that gravity is simply an electrical force of some description, like the forces between atoms that form our Earth and everything on it. That's the conclusion of the electric universe based on all the new evidence since then. The article says, of course, there appears to be a major barrier to reconciling quantum mechanics and general relativity. For years, physicists have tried to come up with a theory of quantum gravity to marry the two fields. You'll notice that the standard picture of a black hole or a gravitational object in space is represented as a funnel in space-time, usually with an object like, in the Earth's case, the moon perched on the edge of the funnel. The idea being that the moon, instead of traversing a straight line in space, follows the curve of the funnel. However, the very image itself gives a false picture because we just assume that this gravitational well or funnel has gravity pulling from underneath to draw the object down into the funnel. But this is using gravity to explain gravity. It's a circular argument, and the image is quite misleading. An object perched on the surface of this funnel, if gravity were not pulling it down, would remain fixed on that funnel. It would have no force tending to move it downwards or sideways or upwards. It would remain exactly where it is. But it's plain to see that general relativity never explained gravity. It merely described its effect in a geometry that has no reality. And quantum mechanics is a recipe book with no understanding of the ingredients or how they interact. As a result, the rest of the article is appalling nonsense headlined, "Tunneling to the Fifth Dimension." It's only necessary to highlight the meaningless language to show the ideas expressed are imaginary. For example, two entangled black holes forgets that the mathematics of black hole theory allows only a single black hole in an empty universe. The Newtonian principle of superposition of gravitating objects doesn't apply to general relativity. There can never be a second black hole to get entangled. The theorists invoke a wormhole, a tunnel through space-time, produced by pulling two black holes apart. Hyphenating the words space and time to produce a fourth dimension is physically meaningless. Mathematicians use the word dimension to mean a degree of freedom in their equations. There are only three physical dimensions in space, which are measured by length and direction. Time has no length or direction. You can't point in the direction of time. Time has no arrow. Joining space and time has no physical significance. So you cannot produce physical wormholes in space. It is pure science fiction. One of the authors, Sonner, applied this thinking to quarks, the theoretical subatomic building blocks of matter. And I quote, "To see what emerges from two entangled quarks, he first generated quarks using the Schwinger effect, a concept in quantum theory that enables one to create particles out of nothing." End of quote. Here we see mathematicians resorting to dismissal of a principle of physics that you cannot perform a creation miracle. It's not scientific. The author Douglas Adams in The Hitchhiker's Guide to the Galaxy parodied this sleight of hand mercilessly when Zaphod Beeblebrock used an infinite improbability drive to rescue Ford Prefect and Arthur Dent in deep space. Particle physicists have been using the infinite improbability principle since the inception of quantum theory. As is well known, Einstein hated the idea. He's reported to have said, "God doesn't throw dice." He was right. As soon as you disconnect cause from effect, you are not doing science. Another quote from the article, Sonner mapped the entangled quarks onto a four-dimensional space, considered a representation of space-time. In contrast, gravity is thought to exist in the next dimension as, according to Einstein's laws, it acts to bend and shape space-time, thereby existing in the fifth dimension. End of quote. There is no four-dimensional space. There is no physical fifth dimension. Gravity is not explained by general relativity. It is merely described in a limited and unreal geometric way. It is not shown how imaginary four-dimensional space can be warped. Cause and effect are disconnected. It just ain't science. It's merely mathematics. The article finally leaves all common sense and logic far behind. And I quote, "To see what geometry may emerge in the fifth dimension from entangled quarks in the fourth, Sonner employed holographic duality, a concept in string theory. While a hologram is a two-dimensional object, it contains all the information necessary to represent a three-dimensional view. Essentially, holographic duality is a way to derive a more complex dimension from the next lowest dimension." End of quote. This is total rubbish. There is no two-dimensional object. All objects are three-dimensional, so there can be no information held in two dimensions. Real objects and information can only occupy three dimensions. Coming back to the Space News report, the black hole is an alleged product of Einstein's theory of gravitation, but so is the wormhole between the two supposed black holes. It's known as an Einstein-Rosen bridge. But then the wormhole is used and related to the two black holes to define gravitation. Gravity emerges from the more fundamental phenomenon of entangled black holes, the article says. But this argument is simply a circular argument, and so it is nonsense.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
Mature galaxies defy Big Bang.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. It's said that our universe is filled with billions of galaxies, but how far away are they? Astronomers calculate galaxies' distances by measuring their redshift. The most redshifted galaxies are said to be the most ancient and remote, but recently, astronomers using the Hubble Space Telescope have observed galaxies that are too ancient, too close to the Big Bang. The mystery is that these galaxies did not have enough time for gravity to create the structures we observe.
In the conventional theory, one of the problems they have is gravity forming galaxies so soon after the Big Bang. That's because gravity is a very weak force. In the electric universe, you are organizing material by electricity and magnetism,
It's really pretty
which
scary
are
when you think about it on
vastly
that,
more powerful
that
than
aspect of
gravity,
mind.
and are able to
Chad.
form these kinds of structures in very short times. Several astronomers analyzed a new group of over 1,600 galaxies, analyzed them for shape and color. They sorted them into the Hubble sequence.
And obviously, these people have nothing to do with supporting a flat Earth. But for some reason, it's all bundled up in there when people are new to the idea. They've somehow conflated the two ideas as assisting each other or something. And it's really not, that couldn't be more farther from the truth. It literally shows a spherical nature, the magnetic fields and all the planets and everything. It doesn't have there's no flat ones.
Sequence, which is an observational category that galaxies come in elliptical shapes and in spiral shapes. These astronomers who analyze these galaxies also calculated their distance based on the common assumption that redshift is a measure of distance, which they assume is caused by the expansion of the universe. The redshift, interpreted as a measure of distance, means that the higher the redshift of a galaxy, the farther away it is. And because of light travel time, the farther away it is, the longer the light has been traveling, and therefore the galaxy would be from a younger time in the universe. It would be closer to the Big Bang. A lot of the galaxies they studied went back to 11.5 billion years ago, so they would be only a couple of billion years after the Big Bang. Another assumption is that gravity is the only force that organizes the universe. So after the Big Bang blew out kind of a fog of matter, it would take a certain amount of time for gravity to organize this matter into galaxies. According to conventional theory, they wouldn't expect gravity to be able to do this in only 2 billion years. Discovering that there's a Hubble sequence all the way back to 11.5 billion years ago creates difficulties for explaining it with gravity.
Astronomers typically classify galaxies by their shapes: ellipticals, lenticulars, spirals, and irregulars, all said to follow an evolutionary sequence. Since this classification was first named by Edwin Hubble, it's called the Hubble sequence. But how well does this convention actually describe galactic evolution?
One of the quotes from the group is this: clearly, the Hubble sequence formed very quickly in the history of the cosmos. It was not a slow process. Now we have to go back to the theory and try to figure out how and why. This isn't entirely unreasonable because it's politically and economically almost impossible to consider a fundamentally new theory. If you look back in the history of science, the fundamental conceptual changes are rare because the benefits are often generations removed from the initial questions, and the questions don't really matter for daily life. They won't change the price of eggs. So there's a lot of incentive to just tinker with a theory and try to find something that'll work reasonably well. And the more involved a theory gets, the more opportunities you have for tinkering with it. So getting new ideas considered is difficult, to say the least. But when a theory becomes so encrusted with these patches and these tinkerings, it begins to become a nuisance. So you see this today, and a lot of people are unofficially expressing dissatisfaction with the current state of astronomy and actually a lot of the sciences. The problem with patching the existing theory is that they keep coming up with new, what we call helper assumptions, fudging. This would be things like dark matter, dark energy, super compressed matter, like in black holes and neutron stars. There's no laboratory evidence to support any of these new things. They're just added on assumptions in order to save the theory, in order to make gravity work. Because you see these early condensations of matter and high energy sources, conventional gravity can't do that. So they have to get a lot more gravitational energy into these areas to produce what they see. They do that simply by pressing a lot more matter into a lot smaller space.
Math.
If they take into account the
They do it by
electric
math.
force, you can get this much energy in a small space simply by powering it with electricity. Since the space age, we've discovered that the universe is composed of plasma, which has demonstrable electrical properties, rather than mass and gas, which is all that the conventional theories will allow. So if you allow electricity and magnetism to form these bodies, it can be done very quickly, and they show the forms that can be investigated in laboratory plasma discharges.
Laboratory demonstrations and numerical simulations give scientists new insights into galactic evolution. As these insights combine with spectacular images from space, a new frontier of astronomy and astrophysics is emerging.
It's time for some new ideas. The distant galaxies are much too gigantic and majestic for us to truly comprehend. Yet laboratory experiments and simulations using simple electromagnetic forces do create galactic forms without the immense time frames astronomers have proposed based on gravity. More attention needs to go to experimental displays that are not constrained by the weak force of gravity. Let those who model plasma and electricity work with the so-called Hubble sequence diagram to produce galactic structures morphing from a spiral into an elliptical, then onto an irregular galaxy by varying the inputs. This possibility is real and achievable if we'll just change the way we see the universe with more attention to the power of electricity.
For continuous
I don't know how
updates
much more
on
clear it
space
gets
news
than
from
that.
the Electric Universe,
You're going to call them a
stay
conspiracy
tuned
theory
to
when they're the only ones who
thunderbolts.info.
can actually demonstrate in the laboratory what we're looking at with observation. And
Welcome to Space News from
Just
the
makes no
Electric
sense that it would
Universe,
be,
brought to you by the Thunderbolts
thought of with
Project
such
at thunderbolts.info.
disdain by people, you know, who
Welcome to
haven't
Space
heard
News from the Electric
haven't heard the full theory on their own. So as soon as you say some parts of something doesn't match up with what they've heard before and been repeated to them, you know, people, they actually think, when I'm talking to them, they actually think they understand how the sun works. They think they do, when it's like completely admitted by science that they don't. That's just their best going theory. But the other guys, when you argue with them, the non-scientists, no, this is how it works, they'll tell you. Like, wait a minute, the scientists don't even really say that. Back the fuck up, Cloud 9. I mean, what the fuck? Here, let's go on down to another one here, if I can just feel one that has some good. Supernova too bright for standard theory. We almost kind of basically just covered that with. I wanted to talk about some redshift or something. Might have already passed it when I was looking for something else. I'm going to do this one more time.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Science headlines around the world tell us almost daily about astronomers' observations of black holes in deep space. These headlines imply that the existence of black holes is no longer in doubt, but not every story suggests that all is well with black hole theory. Recently, astronomers using the VLA telescope made a surprising discovery. They observed 2 bright radio spots in the globular cluster M22, which they interpret as proof of 2 small black holes. However, standard theory dictates that only 1 black hole at most should be present in the cluster. The National Radio Astronomy Observatory reports of these findings. Simulations have indicated that these black holes would fall toward the center of the cluster, then begin a violent gravitational dance with each other, in which all of them, or perhaps all but a single one, would be thrown completely out of the cluster. But as is often the case in media discussions of black holes, are we really seeing the complete story?
It's felt that really all but one of these black holes are expected to be ejected from the cluster through various kinds of dynamical interaction, even though, as they point out, perhaps hundreds of these may be formed originally when the globular cluster is condensed. They also note a relative lack of black hole binaries in different kinds of globular clusters that have been observed. But
in other words, the black holes aren't even being observed.
Let's just back up a little bit and be clear about what's really being observed here. The way the paper is reported, and even the way the original journal article is written, the things being observed are labeled unequivocally black holes. But what is really being observed is a couple of bright radio spots in the sky. In this case, it was 2 relatively bright radio spots. That's it. What is inferred from that is that each of those radio spots is a binary with a black hole and another star, with the other star feeding the black hole hot gas, which is accelerated and superheated to the extent that it emits, in this case, radio, but more often than not, we're talking about X-rays, that they'll see a bright X-ray spot with an X-ray observatory, and what's inferred is that's a black hole that's emitting X-rays, but we don't see a black hole. We don't see an accretion disk, which is apparently emitting the various kinds of radiation. We don't even see a binary. What we see is an energy source, a dot, basically, against a darker background of the same energy. So in this case, the authors see these 2 radio sources in M22 and propose that there are 2 black holes of what's called stellar mass, about 10 to 20 times that of our sun. After that initial proposal in the paper, it's then taken as fact that we're looking at black holes.
Also missing from media coverage is an historical perspective on the evolution of black hole theory in response to surprising discoveries in space.
What's interesting is the way that this accretion disk model has
What's really interesting is they always show it as an electromagnetic dielectric plane with the 2 cones coming out, which would be, one would be centripetal convergence, and the other is centrifugal divergence, and what you would call your north and your south. It's just, they're showing you that circuit, that magnetic field, and they just, they never say it.
Well, on one hand, there was
right
mathematical abstraction of a black hole, which attracted mathematical physicists because of the elegant way in which the field equations, in which Einstein's field equations could be solved. And there was an increasing complexity of the boundary conditions that were allowed around the field equations to create different hypothetical versions of black holes. And you can read this in the history of black holes and how those boundary conditions were enhanced. And then at the same time, observations of highly energetic events that were being increasingly seen because the kinds of devices, the kinds of observatories and the number of observatories and the frequencies that we were allowed to see at, and radio and UV and X-rays and gamma rays, it's difficult to assign an engine to drive them. And in a cosmological framework that really uses only gravity to explain how things work, being able to take the mathematical abstraction that had been sort of evolving in parallel, that was the tool in the toolbox that came to hand. It was very clever, the construct that was created around these binaries that cannot be seen, the accretion disk that cannot be observed. But what I find worrying is the way that it's adopted now as the only explanation. It worries me that any time an X-ray source is observed, it's a black hole. so that the media and the general public are left with the feeling that we are directly observing black holes all the time. It's not the case. We're observing very high energy, very distant high energy events, like X-ray flickers in our observatories. They're not black holes. There are unexpected and variable radiation sources, sudden flashes of gamma rays or sudden flashes of X-rays that coincide with optical emissions at the same time. And it usually results in very convoluted explanations involving a binary accretion disk, gases that are being dammed up somehow and then allowed to flow and accelerate to create these flashes of energy. Whereas these kinds of intense and periodic or variable energetic events can be observed with plasma behavior quite commonly in the lab or at different scales.
For decades, scientists working with electrified plasmas in the laboratory have succeeded in reproducing both high energy emissions and extraordinary structure that we now observe in space across the entire electromagnetic spectrum.
What? It's scalable.
For a long time, the idea
what you can
of electrical
see out
currents
there
in
that's
space
huge.
was sort of poo-pooed. But now we know it's quite common. The space between the Earth and the Sun is known to have huge plasma filaments of electrical current, creating large ropes of magnetic fields. So if we're forced to accept electrical currents in our solar system, is it not possible to accept large-scale electric currents, and even more so, accept large-scale high-energy electrical events? Gravity is very, very weak. To achieve these energy densities with a gravity-driven engine, you need supermassive and super dense objects to make it all work. You can create very high-energy plasma events in the lab. Exploding double layers, arcing, etc., output gamma rays, X-rays, and so on. These are high-energy electrical events you can create in the lab and scale. You cannot create a black hole and an accretion disk in the lab, but you can sure create these electrical plasma phenomenon, and they scale it very nicely to these kinds of galactic and stellar sizes.
That's right.
So my feeling is, why go so exotic and sci-fi with black holes and event horizons and so forth? Occam's razor dictates we accept a simpler, falsifiable explanation.
For continuous updates on Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. A principle of modern cosmology is that so-called space-time is a physically real entity. In Albert Einstein's theory of general relativity, light will follow the so-called curvature of space-time. For decades, astronomers have claimed to observe the bending of light passing around massive objects,
I get it
an
completely.
effect called
If you will,
gravitational
please.
lensing. However, as is so often the case in the space sciences,
I was trying to figure out what you're getting at. How thick is this info? Oh, excuse me. I just muted it and left it playing like a jackass. Oh, no, I didn't. You're catching up. How thick is this info? Get back to that. Asked if it is an electric universe, 50% or more said free energy. Oh, yeah. I get what you mean. What they think about it or what they know about it. They think it's about free energy, which is like, you know, that's something like that could be an implication later on down the line, but it has nothing to do with, yeah. Oh, I see what you're saying. Shit, I'm lucky to get that answer out of people. And
the line between fact and interpretation is routinely blurred. Today, Thunderbolts contributor Andy Hall
Like a
discusses the
smiley face.
tenability of gravitational lensing and explores the growing body of research into its
The reason this
theoretical
video is
alternative.
important to me
Einstein's theory
is because basically, you know, they're telling you how far and close and all that shit is by determining about, you know, its redshift when in blue shift, or it's, you know, oh, well, I guess this is a different video, huh? It's gravitational lensing. Well, actually, it's got a little bit to do with that too. But it could literally just be refraction because of the more dense plasma held in electromagnetically around those circuits like the heliosphere. You know what I mean? Things like that.
General relativity is the backbone of
Or
mainstream
actually the
cosmology.
galaxies.
Anyone exploring electric universe theory must confront the issue of the general relativity model, because in spite of the fact it doesn't really describe much that we see in space, it is still widely believed by mainstream institutional science. And we are consistently told by mainstream science that general relativity is proven by direct observations. One of those observations, and the first used to confirm Einstein's theory, is an effect he predicted himself called gravitational lensing. Einstein predicted that light should bend slightly as it passes through the warped space-time of a massive body like a star. And this bending or lensing effect should be observed if one could see distant starlight passing through the gravitational influence of a closer massive body like the sun. Well, in 1919, Sir Arthur Eddington famously made this observation during a total eclipse of the sun on the African island of Principe. He observed light from distant stars bending through the gravitational influence of the sun, and on that basis declared Einstein's theory to be verified. Of course, the lensing effect has been observed many times since, as the powerful telescopes of our modern observatory see the light of distant galaxies bend around the galaxies in the foreground. It's quite common, and it's taken for granted the effect is caused by Einstein's theory of gravitation. But for a direct observation to be held as proof requires it to be a phenomenon that can be only explained by that theory, a unique solution, in other words. As I followed my own path of discovery in the electric universe, it was essential to find a classical physics explanation for lensing. Otherwise, how could I accept that general relativity can be disputed? So I discovered the work of Dr. R.C. Gupta at the Institute of Engineering and Technology in Lucknow, India, and wrote about it in the Thunderblog article, Lensing by Refraction, Not Gravity, to bring it to the attention of our readers. Dr. Gupta's paper, entitled Bending of Light Near a Star and Gravitational Red-Blue Shift, Alternative Explanation Based on Refraction of Light, asserts that the theory behind gravitational lensing is wrong, and that the lensing effect is actually caused by refraction through the atmospheres of stars and galaxies. Dr. Gupta shows that if you make certain assumptions about the density of a stellar atmosphere, mathematically, the equation Einstein derived from general relativity to calculate gravitational lensing can also be derived from the classical equations for refraction. Dr. Gupta shows mathematically they are equivalent, but the physics behind them is quite different. Refraction is classical optical physics. Refraction occurs when light waves pass through matter with different densities, and it causes the light path to bend. We see this effect every day. When we see a pole in a pool of water, the pole appears bent because the light is refracted as it passes from the water to the air. We use refraction to bend and refocus light in magnifying glasses, eyeglasses, and telescope lenses by passing light through the curved surfaces of a crystal. Anyone who takes a first-year physics course learns that refraction is an inevitable consequence when light passes from a medium of one density to a medium of another density. It is the kind of simple answer based on classical physics that electric universe theory rigorously requires. The concept of refractive lensing has also been discussed in Thunderbolts forums before. Dr. Edward Dowdy, Jr., a physicist and laser optics engineer formerly with the NASA Goddard Space Center, presented at the EU 2012 conference observations he made of solar lensing at varying altitudes above the photosphere of the sun. And he showed that the lensing effect varies as predicted by refraction through an atmospheric gradient, not as predicted by gravitation. In another observation, he points to the lack of gravitational lensing observed in the stars that rapidly orbit the Milky Way's galactic center. Big Bang theory predicts there is a massive black hole at the center of the Milky Way, at the location known as Sagittarius A. Astronomers have observed stars in fast elliptical orbits around the galactic center for over a year, some having completed entire orbits. Dr. Dowdy points out that light from these stars should lens if there is a black hole there, as predicted by general relativity. The light should distort as the stars orbit close to the immense gravitational field of the purported black hole. But they don't exhibit any optical distortion at all. This is completely at odds with the predictions of general relativity, but mainstream cosmologists blithely ignore this inconvenient truth. Dr. Gupta points to another optical effect as proof that lensing is caused by refraction and not gravity. Diffraction is a natural consequence of refractive lensing. As light refracts, its wavelengths or color spreads light. This happens when light passes through a prism. General relativity predicts no prismatic diffraction with gravitational lensing, since gravity warps space to bend all wavelengths equally. Well, there is a special case of lensing called the Einstein ring. It occurs when the focal point of distant light is directed at the observer in such a way that it creates a complete ring of light around the intervening galaxy. You can see the same effect when a full moon shines through high, thin clouds and creates a ring around the moon. This is refraction of the moonlight through the ice crystals in the clouds. This type of ring can be seen around galaxies too, when another bright galaxy shines from directly behind the other. It's called an Einstein ring. Einstein rings are always blue, and mainstream cosmology has never been able to explain why they are blue if they are caused by gravitational lensing. The blue color is an indication of diffraction due to chromatic aberration, the prism effect, which is a predicted consequence of refractive lensing. Dr. Gupta's paper also goes on to postulate that gravitational attraction is only between material bodies, bodies with mass, and that light waves have no rest mass, so cannot be affected by gravity. This agrees with EU theory and refutes another pillar of Big Bang cosmology, the phenomena of redshift. Astronomers see the light of distant galaxies as redshifted, its wavelength stretched, in other words, and attribute the effect to gravity in the expansion of the universe. Big Bang theory actually predicts three types of redshift. First, there is gravitational redshift caused by the pull of gravity on the light, which increases its wavelength as it leaves the gravitational influence of the galaxy it comes from. Then there is Doppler redshift caused by the galaxy moving away from us in an expanding universe, causing the wavelength of the light to stretch the same way the sound of a train whistle drops in tone as it races away, causing its wavelength to stretch. Finally, they also predict the light wave is stretched by the stretching of space itself because the universe is expanding. This is called cosmological redshift. The refraction theory simply says none of these convoluted explanations are true. The physics of refraction says that the wavelength of light is stretched, redshifted, because the speed of light is slowed as it passes through a denser medium. This is because the speed of light is not a constant, it's a speed limit. Light can be slowed down. Light can be slowed in the laboratory by passing it through various mediums. So according to refraction theory, the speed of light is slowed by a medium as it passes into, and hence the light waves pile up like a traffic jam, decreasing the wavelength and causing a blue shift. And when light leaves a denser medium, like a galaxy, into the near zero density of intergalactic space, it speeds up, stretching the wavelength into the red. And this explains redshift, again, with known classical physics. Refraction theory really presents two alternative explanations for phenomena commonly used as proof of general relativity, lensing and redshift. As Wall Thornhill explains in Towards a Real Cosmology in the 21st Century, the electric universe theorizes neutrinos form the ether and provide the mechanical substrate of the universe. Neutrinos have mass, albeit very small, and envelop stars and galaxies in a density gradient. In addition, we know stars and galaxies are plasma entities themselves and are enveloped in plasma atmospheres. At the time Einstein developed the theory of general relativity, the pervasiveness of plasma atmospheres around stars and galaxies was not known, nor had neutrinos been observed. It was thought there was no medium to cause refraction in the vacuum of space. Now we know about the plasma environments of stars and galaxies. We know neutrinos pervade space. It is inconceivable, in accordance with the classical physics of light and optics, that light passing through a medium does not experience refraction. Nevertheless, gravitational lensing is used by the mainstream to study the presence of dark matter and galactic clusters. Redshift is used to calculate the size of the universe and the rate of its expansion. These are all concepts based on flawed assumptions that waste everyone's time. Refraction is the actual cause of lensing, and it needs to be recognized that it refutes two of the major false assumptions behind Big Bang cosmology, redshift and gravitational lensing. It also points to the malleability of mathematics to describe anything. Just because an equation can be made to work isn't proof of anything unless the physics behind the equation is correct. I think the biggest irony of this story is the fact that Sir Eddington claimed he observed proof of gravitational lensing using telescopes that work by refraction. Apparently, he never stopped to think about that.
That's the funny part. He's sitting there discovering gravitational lensing through a glass telescope with refraction. Cute.
Space news from the electric universe. Stay tuned to thunderbolts.info.
This is a cool one just for those who haven't seen this before.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In September of 2015, for the first time ever, an image was captured of an elusive electrical phenomenon above the Earth. An astronaut aboard the International Space Station imaged a kind of electrical discharge in the upper atmosphere, known as a blue jet. It wasn't until the mid-1990s that scientists were able to verify this kind of intense electrical activity above thunderclouds, reaching towards space, though some airline pilots had claimed to witness the phenomena for decades prior. Scientists today acknowledge they don't fully understand blue jets, or another form of above-clouds lightning, called red sprites. Yet surprisingly, as far back as the 1920s, a Scottish physicist named C.J.R. Wilson predicted the existence of brief flashes of light above large thunderstorms. A fundamental question that must be asked is, do scientists today really understand lightning? Much of what we observe in nature and recent scientific research suggests that the answer is no. In 2001, a physicist named Professor Edgar Bering at the University of Houston flew a high-altitude balloon above a thunderstorm. He made the unexpected discovery that when lightning strikes occur above and below the clouds, the electrical charge was already present and did not take time to build up between lightning strikes. This contradicts the standard notion that lightning is a generator of the clear air electric field, measured at about 100 volts per meter between the Earth and a clear sky. Lightning's generation of power requires water droplets to separate charge in clouds, a process that remains mysterious and unverified. The electric universe, however, sees lightning and the cloud activity as a load that is being driven by electricity from space, and it is the electrical circuitry between the sun and the Earth that drives all lightning. Recent scientific studies have confirmed the role of the electromagnetic Earth-Sun connection in lightning. In 2014, scientists in the UK discovered a dramatic increase in lightning strikes for up to 40 days after a major solar storm. The researchers admit they don't understand the cause of the increased lightning, suggesting that the collision of protons with gas particles in the atmosphere, quote, somehow alters the electrical properties in the air. The role of electric currents from the sun in creating lightning may be even more clearly evidenced on other planets. For instance, on the planet Venus, no water clouds are present, but rather, the atmosphere is composed of what has been characterized as a, quote, fog. Yet when the Soviet Union's Venera spacecraft touched down on the planet in the early 1960s, it found constant lightning activity, from tens of kilometers down to a couple of kilometers altitude, with discharges occurring as frequently as 25 per second. In contrast, the highest recorded rate on Earth is 1.4 per second. In the electric universe, Venus is a charged body immersed in an electrical circuit. This means that Venus is the focus of a cometary-style discharge to the solar electrical environment, a fact evidenced by Venus's enormous filamentary magnetotail. A new understanding of lightning on Earth and other planets may help to enable a radical reassessment of mysterious atmospheric phenomena on many planets and moons. The recently imaged blue jet bears a resemblance to some of the so-called volcanic plumes on the Jovian moon Io, while planetary scientists believe that tidal heating creates cryovolcanoes which generate the plumes. Recent studies have shown that these models have failed to predict the locations of the plumes. Similar plumes are also seen on the Saturnian moon Enceladus. And in 2015, scientists were stunned when giant plumes were imaged jetting hundreds of kilometers above the surface of Mars. The electrical connection between a planet and the sun has enormous implications for the safety and efficacy of all future space missions. In the 1990s, the Thunderbolts project's chief science advisor, physicist Wal Thornhill, offered a prediction and warning about a space tether experiment in which a satellite was flown at the end of a long wire held radially from the Earth. Thornhill warned that by trailing a wire radially, scientists would achieve voltages that could prove destructive. The prediction appeared to be confirmed when the tether separated at the shuttle and the satellite at the end of the tether was lost. Thornhill also warns against plans to build a so-called space elevator, which would enable astronauts to travel up and down a kind of elevator cable between the Earth and space. Such an elevator is, in Thornhill's opinion, an impossible dream, since it could only act as the ultimate lightning rod. It is telling that lightning, nature's most dramatic electrical display on Earth, may be providing scientists with the most obvious clues to the electrical nature of the sun, the Earth-Sun relationship, and of the universe as a whole. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
Pluto. Funny how they canceled Pluto as a planet and called it like a dwarf planet and just, did all that shit to it. And it turns out that it's a more complex, it's a system more complex than some of the larger planets with their moons and things around it. It's just hilarious.
Welcome to Space News from the Electric Universe, really brought to you by the Thunderbolts Project at thunderbolts.info.
Classifying planets and moons improperly almost really screws with the fundamentals of everything. Because the idea of a planet to me would be having an electric circuit to something with an electric circuit to a star, showing it has a spin and rotation. It's all showing, its electric nature. And the moons would be, I would say neutral, which would be either tidally locked, not spinning, the same or whatever. So, I mean, I think it's crazy. So I think planets could be around other planets as well. I mean, they would be satellites of the other planets. And then, by that standard, definition, you'd call it a moon. But I wouldn't, because, if it's tidally locked and it's not spinning, then it would be a moon to me. That'd be a neutral trapped in between, it's the two walls of the Birkeland current, like my moon theory describes.
NASA's New Horizons mission to the dwarf planet Pluto has provided scientists on Earth with countless puzzles and mysteries. From impossible sand dunes, which were never expected on the tiny planet's frozen surface, to equally unexpected giant mountains, to a surprising absence of so-called impact craters, and selective regional cratering with highly circular craters, not to be expected on any Kuiper Belt object. The Plutonian moons have proved equally surprising, such as the moon Charon, with its puzzling troughs and trenches stretching for hundreds of miles. And now, a team working with the Chandra X-ray Observatory has reported perhaps the greatest surprise about Pluto to date.
Delete the elite. Yeah. Oh, you said something about you're not sold on gravity yet. How about this? Gravity isn't the strong force that would actually hold the planets into their orbits. Gravity is what holds the things down onto the planets, I would say. The other force is completely different, electromagnetic force that's doing that, electromagnetism. That's my idea of that. The gravity would be what would tidally lock, as it's a weaker atomic force. It can pass through the stronger other force because it's like a much smaller wave. Like you imagine the two different meshes. One mesh goes right through the other mesh unaffected. Just like you can pass radio waves through the magnetosphere as long as they're not short, fat waves. They have to be long, skinny waves. So that it would be sort of to that same idea, how normally you wouldn't, either you have one bar of energy, one wall of energy that you can't pass other like energy through, but you can pass unlike energy through it, smaller, modalities of it. So, I think that's why that's kind of hard to explain, but I think you might be able to see a better picture of what it is we're talking about as one force passes through. Well, I'm calling it a force, but only because I know that's the way you think of it. But, one modality passing through another modality of the same field. It's really the same field, just different frequency of it. So that might help a little bit, I think. Or not, I don't know.
Discovery of the emission of X-rays from Pluto. The team is also reporting that Pluto has a giant comet-like tail, which the scientists believe may be as much as 1,000 times the radius of Pluto. The scientists say of Pluto's surprising X-rays, we've just detected for the first time X-rays coming from an object in our Kuiper belt, and learned that Pluto is interacting with the solar wind in an unexpected and energetic fashion. We can expect other large Kuiper belt objects to be doing the same. Before our observations, scientists thought it was highly unlikely that we detect X-rays from Pluto. Today, physicist Eugene Begashoff begins the first in a 4-part series, offering his analysis of the most compelling scientific data from the Plutonian system.
In the recent months, we have seen more and more data being released and analysis being made in the wake of the historical Pluto flyby of the New Horizons space probe. Let us briefly review the available data in some of the publications to see if they might provide a novel outlook on this dwarf planet, and maybe even clues relevant to the electric universe agenda. First, I would like to discuss the visual part of the planet and what is happening on its surface. When you look at Pluto, probably the first thing that catches your eye is its incredible diversity. We might see quite complex and strange landforms, as well as more regular ones. Craters, mountains, rills, valleys, smooth plains,
like a
quote, pitted
atom.
uplands,
One
bladed
side is
terrain,
oblong,
snakeskin
stretch,
terrain, end quote, and even something that resembles sand or snow dunes, and other things like that. So from the first look, it doesn't appear to belong in the place where it is situated right now in our system. Rather, it looks more similar to our terrestrial planet family, or maybe Saturn's moon Titan. In previous Space News episodes about Pluto, we've already touched on that subject and discussed the possible origins of this dwarf planet as a captured object, possibly former moon of a giant planet. So the diversity of its surface seems to support this idea, which is consistent with the EU scenario of planetary chaos. Probably the most distinctive feature on the whole planet, or at least the part that we've been able to observe, is the so-called Tombaugh ratio, a bright feature sitting slightly to the right of center of the New Horizons encounter hemisphere, and on the opposite side of planet with respect to the prime meridian of Pluto. The prime meridian is counted from the spot above which the biggest moon Charon hovers, so this mentioned region cannot be seen from Charon. The brightest part of Tombaugh ratio is called the Sputnik Planum, and in a lot of ways it's very different from all the other visible regions. According to the spectroscopical data, Sputnik Planum terrain is mostly composed of nitrogen, carbon monoxide, and methane ices. We might see very bizarre cellular patterns on its surface. From the visual data,
I'm going to move on, and we're going to go to a requested topic for Delete the Elite, and we'll try to answer some of the questions. Oops, watch that one all the way again.
Thank you and welcome. And congratulations, because the Electric Universe conferences are perhaps the only real conferences to come to if you want to learn about science. So I congratulate you on having the initiative and the curiosity and the open-mindedness to come here and also to be involved in the live streaming of this conference. Annis's talk actually was a very good introduction because I wasn't going to say a great deal about this long path to understanding gravity. The early days, my story, started after I read Velikovsky's Worlds in Collision as a teenager. This was before going to university. When I got to university, I thought this was an ideal time to ask questions of lecturers and try and interest other students in the subject. I was amazed at the lack of interest on the part of most people, and also the sometimes hostility of lecturers to being asked questions that they couldn't answer. This caused me, as a science undergraduate, to look in the shelves of the library, in the sections on the myths and legends and stories of peoples from around the world. And it was there that I became convinced that Velikovsky had made a leap forward, and he posed questions which must be answered. They couldn't be ignored. The response, of course, of the astronomy community was that what Velikovsky proposed, that Venus was a comet, that Mars moved close to the Earth in historic times, was absolutely impossible. It disobeyed Newton's law. So it was in 1979, long after, I visited Velikovsky at his home, and my question to him was, and this was based on the hostility towards his idea that he could break Newton's law, what is it we don't understand about gravity? And he was kind enough to give me a slim volume where he had written, back in the 1930s, Cosmos Without Gravitation. And in that, he actually looked at the behavior of matter in trying to produce gravity. And this is quite distinct from the way it's being done right now, which is mathematical, purely mathematical. So that gave me an idea. And also I had formed the opinion that science had left the rails 100 years ago, and that to regain the path forward, the path of discovery, we had to go back to get to the future. We had to go back to the classical physics approach, the great experimenters, those who had intuition about the behavior of matter, but also to revisit Newton himself. It was only 2 years after that, in 1981, that I was reading the Scientific American, and there was a tiny advertisement by a chap called Ralph Sansbury, who was publishing the Journal of Classical Physics, which immediately caught my eye. And the first topic was electron structure. Now, according to particle physics, an electron has no structure. It's a fundamental particle. But that's a mathematical concept which has no physical reality, because if you try to reduce an electron to a point particle and give it charge, you end up running into infinities. And of course, once you do that, the theory breaks down. Scientists have a way of getting around that these days. They call it renormalization, where when your theory breaks down, you open the window, see which way the wind's blowing, plug that into your equation and keep going.
Now, you see what I just showed you there? In this?
They do that repeatedly for theories about the sun. So, what's the situation today? And this is a statement by Martin Rees, the former...
Now, this confirms the idea of the atoms being monopole, with a pole in the center actually inside that pulls in one direction further than the other. See this pear-shaped nucleus of the atom? Physicists have confirmed the existence of a new form of atom nuclei, and the fact that it's not symmetrical challenges the fundamental theories of physics to explain our universe. A lot of stuff here that demonstrates the electric nature instead of the regular Newtonian nature of these atomic structures. So let's back it up here. Because to understand this new form of atomic nuclei, you have to get to know the old ones first, right? Until recently, it was established that the nuclei of atoms could be of just one of three shapes: spherical, discus, or rugby ball, right? These shapes are formed by the distribution of electrical charge within a nucleus and are dictated by the specific combinations of protons and neutrons in a certain type of atom, whether it's hydrogen atom, zinc atom, or a complex isotope created in the lab. The common factor across all these shapes is their symmetry. This marries nicely with the theory of particle physics known as CP symmetry. CP symmetry is the combination of two symmetries that are thought to exist in the universe: C symmetry and P symmetry. C symmetry, also known as charge symmetry, states that if you flip an atomic charge to its opposite, the physics of the atom should still be the same. So if we take a hydrogen atom and an antihydrogen atom and mess with them, both should respond in identical ways, even though they have opposite charges. P symmetry, also known as parity, states that the spatial coordinates describing a system can be inverted to the point of at the origin, so that x, y, and z are replaced with negative x, y, and z. All right, and there's a little. Your left hand and your right hand exhibit P symmetry from one another. If you point your thumb up and curl your fingers, your left and right hands mirror one another. Da 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 da. CP symmetry. I'm just explaining the ideas between the two. I think you got it by now, but basically nothing says anything about this. So sorry, I just kind of like losing the major point. It just crunches the theory of it being a gravitational thing of, of its mass and all of that, and adds the electrical charge, then you can get a better understanding that once again the standard model is not supported by observation.
Astronomer Royal and Fellow of the Royal Society, well-known figure. It's one of the few things I agree with that he has said. He asked the question, what causes gravity and mass? These questions still baffle all of us. Rather than the end of science being nigh, in other words, we're almost at a theory of everything, we are still near the beginning of the cosmic quest. And I agree with that. Also, Richard Feynman has said, there is no model of the theory of gravitation today other than the mathematical form. And this, I think, when you watch shows on television about the mysteries of modern science, it's all about mathematics.
Okay? I know you want
While
to
I
get
was
to
flying
the meat
over
of it.
here from Australia, I watched a show by Morgan Freeman on the mystery of constant, because it dimensions, and this is a math.
Oh, here we go. Sorry, I jumped ahead.
If you can substitute, and of course, when I say that, it means that the speed of light depends on a medium. If there's no medium, there is no light transfer. It's not possible. And C is supposed to be a universal constant, one of these physics constants. But it depends on the medium, which means the vacuum is a medium. And Einstein did away with that medium. He discarded what they called the ether. That was the medium through which light was supposed to move. Maxwell's equations require it. Einstein discarded it.
Moves as electricity through the ether, and it's converted to light once it hits matter. It shows refraction and all of that, which they need to clarify more often.
It never said how he could do that and get away with it. It's been found that the speed of light is not a constant. It varies. So what happened? They now define the meter in terms of the speed of light, so they forced it to be a constant. So even though an equation works, it describes reality sufficiently so that you can build things and do science, so to speak.
It's described. Good words.
Unless a physicist can explain the meaning of each symbol and operator on the board in real physical terms, plain language, the equations remain merely descriptive with no real meaning. Newton was honest. He said he had no explanation for his law of gravity. However, he made the mathematician's mistake of raising it to a universal law. In that way, the math game can continue and you can invent dark matter and black holes or any other unobservable fairy at the bottom of the garden to keep the fictional story alive. And this is what's happened. So we don't understand gravity. Newton described it with his equation, force equals the gravitational constant, big G. You multiply that with the masses of two objects. The question is not answered. How does this mass know about that mass? How can this be so? And the equation says you divide by the distance between them squared. And it works. I mean, NASA uses this equation to navigate the solar system. You'll note that it's the same form as the electric force. You just substitute there for the masses the two charges. But as we saw yesterday with Jerry Pollack's talk, that force is enormous compared with the gravitational force. So this suggests that mass may be understood electrically. If you can substitute charge for mass and you come up with an electrical force, then perhaps mass can be understood electrically. So to understand gravity, we must understand why matter has mass. And as I pointed out with the Higgs boson, they've got no idea. You'll notice that Newton's equation does not refer to time. It's instantaneous. And this is glossed over. In the electric universe, however, this instantaneous connection is absolutely essential for coherence. For coherence of atoms, so that they're stable particles, for coherence of planetary systems, so that the Earth knows where the sun is right now, and in galaxies, so that you can form a spiral. If the stars on one side have no idea where the other stars are until 100,000 years later, how do you form a beautiful spiral?
Right.
And even at the subatomic level. Now this universal gravitational constant, big G, has the peculiar dimensions, and this is a mathematical term, it has nothing to do with the three dimensions of space, of length, mass, and time. But time has no length or direction in space. This is where you can get this confusion when the word dimension is used. And you get into all sorts of mystical talk. In fact, I would suggest that it was science that started the kind of New Age ideas where people talk about extra dimensions and so on. In the electric universe, there's no need for that. The universe can be as wonderful and mysterious as we observe in the three physical dimensions we have, but that goes much deeper. G actually should not be a constant because it refers to mass, and the constant for mass is the energy tied up. So G is not universal. That means that big G, which we measure on Earth, is neither universal nor a constant, and in fact it's the worst defined constant in physics. Every time it's measured, it's different, and even using the same equipment, it varies. So what I would suggest is there is more complexity in the effects attributed to gravity. I say attributed because in some cases we're looking at actual electromagnetic forces, and I'll talk about that, and it's mistaken for gravity. It has more complexity than any equation yet devised can explain. It depends on the context whether it's actually valid or not. It's not universal. We repeated the mistake of Earth centrism. In other words, we measure G on Earth and then apply it throughout the universe. What gave us the right to do that? So we have selective blindness towards conflicting evidence, and we invent dark matter and dark energy, all this stuff. And for example, these pictures that I've got here, and as Anna's said in her talk, we ignore the fossil record of impossibly huge creatures. The ultrasaur, in today's terms, would have weighed 180 tons. And the maximum force exerted by any muscle is independent of body size and is the same for the mouse as the elephant. In the antediluvian world, 350-pound flying creatures soared in skies which no longer permit flying creatures above 30 pounds or so. And the ultrasaur's neck in today's gravity would have caused a 430,000 foot-pound torque where it attached to the body. Even a steel girder of the same mass as that neck would have sagged under that weight. Also, we know observationally that spacecraft show anomalies in Earth flybys, and comets exhibit what's called non-gravitational forces. That's what makes them difficult to predict their returns. And people who have measured gravity or the change in gravity as you go down deep mine shafts and so on, actually said it looks like there's a fifth force. It's not changing the way we expect from Newton's law. And people who have measured gravity going up towers have said maybe there's a sixth force because that doesn't conform to Newton's law either. It was pointed out to me a few months ago that if you calculate using Newton's law the force of the sun on the moon and the force of the earth on the moon, when the moon is between the earth and the sun at new moon, the sun is pulling on the moon twice as strongly as the earth. And the question is, well, how do we have the moon? That's a good question. None of these questions are answered by Newton's simple equation. Of course, if big G is universal, if we use G measured on Earth's surface, the comet 67P looks like solid rock, while its density appears to be that of highly porous dust and ice. And I have repeatedly in the Space News on the Thunderbolts website pointed this out. The planet Saturn appears to have a lower density than water. It could float in water according to using big G as we measure it on Earth. And the composition of the sun is calculated to be mostly hydrogen right down to the very core. Now, what body the size of the sun would have hydrogen gas in its core? If you were to look at the Earth and if its ionosphere was lit brightly, rather like the sun, and you saw oxygen and nitrogen and so on in the atmosphere, would you say that the core of the Earth was then oxygen and nitrogen? No, you'd say more likely to have heavy elements. Michael Faraday. And this is where we get to the principles of classical physics, and that is that good physics needs to be simple. If I can't explain to you in physical terms what I'm talking about, and simply, then you have every right to go and ask somebody else. Michael Faraday, the great experimentalist, could see the possibility of an electrical nature of the force of gravity. Remember I said that two equations are the same form. And he wrote, "The long and constant persuasion that all the forces of nature are mutually dependent, having one common origin," that's the electric universe position, "or rather being different manifestations of one fundamental power," once again the electric universe idea, "has often made me think on the possibility of establishing by experiment a connection between gravity and electricity." And he went on to say, "No terms could exaggerate the value of the relation they would establish precisely." Now, if people had followed Faraday's intuition, we would be several centuries advanced, I would say, in our science. But of course, this poses the key question. The electric force is both attractive between opposite charges and repulsive between similar charges, but gravity seems to only attract. Why is that so? And here's a character who was around at the time of Einstein. Sir Oliver Lodge was a British physicist and writer best known for his contributions to the development of wireless telegraphy. He perfected a radio wave detector and the heart of the early radio telegraph receiver. He was the first person to transmit a radio signal 1 year before Marconi did, and received international recognition for his work. Lodge is also remembered for his work on the ether, which had been proposed as the wave-bearing medium filling space, and of course, which the electric universe relies upon. Other scientific work included investigations on lightning, the source of the electromotive force in the voltaic cell or battery, electrolysis, the application of electricity to the dispersal of fog and smoke. He also invented electric spark ignition for the internal combustion engine. He was a practical man. Rather like your Faraday, he was prepared to experiment and try things. He was critical of the new theories of relativity proposed by Einstein. I would suggest that if education was done properly, his arguments against Einstein would be placed against Einstein's arguments and students allowed to judge for themselves. Referring to Isaac Newton, he wrote, "What is really wanted for a truly natural philosophy is a supplement to Newtonian mechanics, expressed in terms of the medium which he suspected and sought after but could not attain, and introducing the additional facts, chiefly electrical, especially the fact of variable inertia discovered since his time." That was in Nature, Feb 17, 1921. Lodge seemed to be fully aware that Newton's mechanics needed to take into account electrical effects on the masses involved. This is a pivotal idea for gravity. Understanding gravity is essential to be able to express mass in terms of weight in kilograms. So here was a guy, another one, who was well on the way. Once again, good physics needs to be simple. Oliver wrote, "It may be that when the structure of an electron," remember at present it has no structure, "once it's understood, we shall see that an even-powered stress in the surrounding ether is necessarily involved. What I do feel instinctively is that this is the direction for discovery, and what is needed is something internal and intrinsic, and that all attempts to explain gravitation as due to the action of some external agency, whether flying particles or impinging waves or Higgs bosons," he could have said, "are doomed to failure." He's probably spinning in his grave at the waste of the LHC experiment. He showed insight and uncommon sense with his idea that the electron must have structure. All subatomic particles must have a charged subparticle structure and orbital motion to have self-energy or mass, and exhibit magnetic polarization, which is called confusingly spin by particle physicists. This is where language gets into the way of physics today as well. Now, if we're going to talk about particles and matter, we have to look at the scale of the atom to give you some idea of what we're talking about. The first step then is to give some idea of scale. As I said before, modern particle theory is no help because specialists were still arguing over what is really real in Nature last month. This picture gives an idea that the classical atom is mostly empty space, with the charged particles invisible on this scale. It is easy to see how an electron orbiting the nucleus can only shield the nuclear charge from a nearby atom for a fraction of the time it takes in its orbit. Because at some points, or most of the points in the orbit, the proton, for instance, the charge on the proton is visible to a nearby atom. And the same thing for the other atom. So it gives you the idea that if those two atoms can synchronize their orbits, they can then come together and form a molecule. So, as it says there, if the nucleus was the size of a ping pong ball, the electrons would be the size of a flea orbiting outside this stadium, which is in Melbourne Cricket Ground in Australia, at one of our famous institutions. Here's another guy. You don't hear about these people. I think Newton said that if he'd seen far, it was because he'd stood on the shoulders of giants. I would suggest that you have to be very careful in your choice of giant because he may be facing the wrong way. These are the people who should be in our science education curricula. Fritz London was a philosopher of science, a visionary logician and dedicated theoretician. In 1930, Fritz London explained the weak attractive dipole electric bonding force between atoms, known as the van der Waals dispersion force, or it was named after him also as the London force, which causes gas molecules to condense and form liquids and solids. In other words, planets and you and I and everything in the visible universe. The London force originates in oscillating electric dipoles caused by slight distortion of otherwise electrically neutral atoms. So here we're talking about the kind of stuff that the Earth and the planets and the sun that are made up of. Tiny electric dipoles arise because the charges within the atom are separated, as shown in the last slide, by effectively a huge distance. The electric dipoles resonate, as I said, they sort of tune into each other and orbit in such a way that they combine. It's always attractive, just like gravity. So there's a clue. So, in fact, Fritz London said that it seems that gravity may be this kind of interaction between neutral matter. So it seems that the clue about the real nature of gravity has been available to chemists who are not interested in gravity and unavailable to astrophysicists who are not concerned with physical chemistry or electricity. Obviously, gravity has the distinction of being much, much weaker than the force between atoms, the London force. But that should be a clue. We are bonded to the Earth by a similar but far weaker version of the London force between atoms. And here we get into the idea of repeated patterns in the electric universe. So like gravity, the London force is always attractive and operates between electrically neutral atoms and molecules. Very much like gravity. So we talk about matter and mass. So the second step on the path to discovery about what gravity really is to look at the particles that make up matter. Newton's law multiplies the masses of two objects together, so the first requirement is to define what is meant by mass. The electron is defined as a fundamental indivisible particle, but it must be a composite of smaller orbiting charged particles, shown here in blue, to store energy. The energy is stored by the motion of those charged particles with respect to one another and also with respect to all other particles in the universe.
Right?
The same goes for all subatomic particles.
Oh, this is the good part, bro.
Including the neutrino. The neutrino also is included. And there was a report that I got yesterday that they have now shown that the neutrino has mass. Now, the very idea that it didn't have mass meant that it couldn't have been a real particle anyway, because there was no such thing as a particle with no mass. The problem then was that, according to the standard particle, or standard model of
it can't have no charge.
Subatomic particles, the neutrino doesn't interact with the Higgs field, as it's called. That meant that there was something seriously wrong with the standard model. So what has happened? They've said, this gives us the opportunity to modify the standard model. In other words, please send more money. The electron is defined, as I said, as a fundamental indivisible particle. And it goes for all subatomic particles.
I could speed him up, but
and this simple repeated atomic model
I like it.
Is at
hearing him at
far smaller scale. You remember the ping pong ball in the middle of that ground and the flea on the outside? That means within those tiny objects, there's also spinning charged smaller objects.
Tell me if you guys disagree.
Who is to say where we stand in the cosmic scale of things?
Give me a 1 for leave it at this faster rate of speed, or a 2
Ralph
to slow it
Sansbury,
back down.
who was the fellow I mentioned earlier, who published this idea of electron structure, showed that you could actually derive the magnetic force from this structure. In other words, it's a version of the electric force, and gravity from this structure. It's another weak form of the electric force. So here we are, we're doing what classical physics was designed to do, simplify. Now they hand out Nobel Prizes for inventing more forces and more particles, and we know less and less the more they do that. Ralph Sainsbury, though, said if you calculate the speed of these orbiting little subparticles inside the electron, it's phenomenally faster than the speed of light. He calculated that if those tiny little subparticles were to be released from the electron,
as many times as you
they
like.
could travel from here to the far side of the Andromeda Galaxy in 1 second. This comes back to Newton's law, which doesn't involve time. In other words, it says it's instantaneous. Well, that kind of speed is instantaneous on our scale, on a galactic scale. Tom Van Flandern did his own astronomical calculations to point out that the Earth orbits the Sun, and it knows where the Sun is right now. And it's fairly easy to determine that. And by using a more stringent test, he calculated that the speed of gravity exceeded
thinking of lots of stuff,
20 billion times the speed of light.
He goes kind of slow.
So the difference between that and Ralph Sainsbury's was about the order of 1,000 times. Ralph Sainsbury's is probably more accurate.
I mean,
so the electric force between matter particles must operate instantly on our scale of things for the electron to be stable. But something comes out of this is that once you have the speed of information exchange almost infinite, then time is universal. Time has nothing to do with Einstein's clocks. Clocks are physical things. They're made up of atoms and so on, and their environment can change the way they tick. So to use the clock as a surrogate for the concept of time was completely inadmissible. So Einstein's special theory of relativity, I'm afraid, is discounted immediately.
Wow. This guy's so intelligent. I don't know
Newton
how
was
people
right. Gravity is effectively
lesser minds
instantaneous.
could even try and
And
say
Einstein strayed from the path to discovery by postulating the speed of light as the maximum speed for information transfer. When he did that, he disconnected everything. He made an unworkable universe. To have a workable universe, all of the components of the universe must know what all the other components are doing in real time. The difference between this idea and Einstein's is rather like you drop a pebble into a pond and you pick up the sound wave, which is a compressional direct wave. It's much faster than the ripple itself, which takes time. Light is a ripple. It takes time to pass through the ether, the medium, to the receiver. That's enough of that.
Check on the chickens. I'll be right back.
With a real meaning for mass, we can attempt to give real meaning to energy as represented by the equation that everyone has seen but no one understands. Energy is charged matter in motion relative to the charged matter in the rest of the universe. That's the first physical definition I think you'll ever see, because if you look up encyclopedias and textbooks, they give examples and how one changes from one form to another. They don't actually explain at a fundamental level what it is. That's the one. Electromagnetic energy is stored in the resonant orbital structure of all subatomic particles. It's matter in motion. And the mass of a particle is a measure of how much energy is absorbed internally in its deformation rather than its acceleration. It's rather like having a balloon full of water, and you poke it, it resists moving and deforms instead. Well, these particles do the same. And this is why, what was his name again? The chap earlier who I mentioned, he said that we had to look at the electrical, or the idea that when you put electrical energy into a particle, like in a particle accelerator, the mass of that particle seems to change. It's that concept that you really had to focus on. So what causes gravity? The gravitational mass equals the inertial mass. That's lifting and pushing. So much the same mechanism is responsible for gravity. Now, atomic electrostatic dipoles, as I've talked about with the London force and so on, are formed by most atoms inside the Earth with the inner pole positive and the outer pole negative. The reason is that gravity is pulling on the nucleus. You can't shield gravity. That's the point. So the fact that the electron's down there doesn't matter so much, except that it holds the nucleus back from moving in the gravitational field. The nucleus is about 1,800 times heavier than the electron. So if it moves in the direction that gravity is pulling it, then the atom is distorted, as I've shown there, which means that the bottom end of that atom is more positive than the end nearest the surface, which is more negative, simply because the electron spends more time out at the top of the curve and a short amount of time at the bottom. So the electric field produced within the atom distorts the subatomic particles. So the particles within the atom, the nucleus, and the electron are all distorted similarly by a very tiny amount. And this is the distinction between the gravitational force and the electric force, the amount of distortion is infinitesimal. 10 to the minus 38, 10 to the minus 39 times the gravitational force. So, it is the sum of all of the aligned subatomic dipoles that produces the profoundly weak force of gravity. And the fact that they're held by the molecular forces, which is far stronger, means that the atom can't move, the nucleus just sits there and everything's in balance, but there is this weak electric dipole force which is transferred through the body. And gravity cannot be shielded electrically because this dipole force, it's like a whole string of magnets. And if you have a string of magnets on a slippery surface and jostle them around, they'll all connect one to the other, a chain of them. This is exactly the similar process here. Now, here we go. Gravity has two poles like a bar magnet.
Look at that.
This answers the question about why is gravity always attractive? It's because we stand on the surface of the Earth. And this is the third step on the path to discovery. Gravitationally induced atomic dipoles set up an internal gravitational field that is weakly repulsive. You've got all of the positive ends of these dipoles facing one another inside the Earth.
Yeah.
So on stars and planets, the attractive force between atoms is strong enough to hold these tiny dipoles in place. They can't fall. And so the internal pressure inside these large bodies, like planets and so on, is relieved. There is a kind of anti-gravity effect inside, and this is probably why measurements taken down deep mine shafts don't conform to Newton's law.
See what he was showing you?
All stars and planets in the universe
This was actually just confirmed
repel each other
recently.
with an inverse square law force, because this is like a charged particle. It may have significance for understanding charged particles themselves. It suggests even lower levels of structure.
Or substantiated. Maybe
Now this is interesting. I mean, all stars and planets in the universe repel each other. Newton's attractive force has a limited sphere of influence. This may explain many anomalies.
All stars
In
and
fact,
planets
as I mentioned, the mines and towers and fifth and sixth force, the complex structure and odd features of an inner core found inside the Earth by seismologists may have an explanation based on such a model. This is very recent. They found this odd structure to the inner core of the Earth. We're part of the Earth. It's like the molecular force at a very low level. The fact that we're attracted to the Earth is the same process, but at a different scale. We're bonded to the Earth by the dipoles induced in us. The effect's like that of a magnet on an unmagnetized steel ball. We therefore assumed that gravity is always attractive. And also it's a mistake to assume that G measured on Earth is a universal constant. It depends on the polarization of the Earth itself. And that can be varied by adding or subtracting charge from the surface.
And no, that doesn't mean if you just stand on your head, you'll start floating up out into the atmosphere.
The mass of a body varies with its surface charge. So when the thunderbolts of the gods were hurtling around and the planets were on orbits which meant that they came close to one another enough to exchange charge strongly, the masses were changing. So gravity repels. This is an odd idea, but it's not new. In fact, Newton considered it as a possibility because there was a theory which seemed to work. The pushing theory of gravity was originally proposed by Newton's colleague Nicolas Fatio de Douillet in 1690 and later by Georges Louis Lesage in 1748, a long time ago. They said that an omnidirectional flux of small particles permeates space and tends to push objects together. And because they mutually shield each other, it gives the effect that looks like gravity, and mathematically it works. It was known later as the Fatio-Lesage theory and was considered seriously by many scholars, including Newton, but was discarded for very good reasons. If you have particles impacting a body, you're releasing energy, and the energy to keep the Earth in orbit around the sun would have been enough to vaporize it. However, more recently, let's catch up here, Halton Arp, also known as the modern Galileo, discovered intrinsic redshift of quasars, and Anna's talked about that. And he came up with, once you get rid of this redshift equals speed of recession, which gives you the distance, once he got rid of that, he found out that the universe was fairly static, but then he had a problem. If it's static, how can that be so? If gravity is an attracting force, everything should be falling in towards one another. But he didn't observe that. So he actually, as he said here in this paper, he had an observational requirement to consider what he called Lesage gravity, this pushing gravity. He said, for many years, I never questioned the obvious fact that the masses attracted each other. The attraction was so blatant that it required no thought. And this, unfortunately, is the situation in astronomy right now. It requires no thought. But then observations of galaxies and quasars forced me to accept the fact that extragalactic redshifts were primarily intrinsic and not the result of recessional velocity in an expanding universe. So he went on, it is interesting how the crumbling of one fundamental assumption can have reverberations throughout the whole underpinning of science. I have the greatest respect for that man. He was prepared to go wherever the observational requirements led him. The sign of a real scientist. This is the Hubble Ultra Deep Field of 2014, an exposure time of 600 hours. It's merely the visible part of what's pushing in on us. ARP showed that these faint redshifted objects are not distant objects necessarily. So even though this is a big field, it doesn't mean that they're far away. This is just looking with very long exposure at things, the redshifted objects in there are relatively close. They're mixed up with all of the bright nearby stuff. In other words, there is no Big Bang. I mean, the Big Bang was just a religious rewrite. So, astronomy has a massive problem. With repulsive gravity, collisions tend to be avoided. But the problem is for astronomy is that with attractive gravity, all you have is attraction, collisions, and explosions. That's why a Big Bang was necessary in the beginning. You'll notice in this picture too, there are no lightning bolts. That's a grave mistake. Is there a method to stabilize the chaotic nature of a many-bodied gravitational system? And this was alluded to also by Annis. What happens to orbits if we vary the mass of a planet electrically, remembering the dinosaurs, and a sudden change? Well, as we've seen, and with the Birkeland currents and so on, we can transfer electric currents through plasma. And of course, the solar system is bathed in the solar plasma. And here the electric universe model meshes with the plasma universe and all of the peer-reviewed literature on plasma cosmology. Now, I've presented this in more detail, and it's available on YouTube, so I won't go into detail here, but the idea is to show that the radius of the orbit of a planet of mass, say M1, changes with the radius and the mass are proportional for a constant orbital energy. That means that if the mass of a planet via, say, an electrical discharge, thunderbolt of the gods, was to double, its orbit, the radius of its orbit would double, it would move out. And this is important because you can then establish order out of chaos. Now, in the case of Venus, they've already detected these stringy things, in other words, Birkeland currents, flowing between Venus and the Earth during conjunction there. In other words, that tail you see behind Venus has been detected by a spacecraft, I can't remember which one it was, many decades ago. I think this was back in the 1980s when it was reported. Now, in the electric universe, each planet is a small cathode in the solar discharge, and the electrons are actually transferred from Venus towards the Earth. It was a SOHO spacecraft, by the way. So the Birkeland currents transfer electrons from the inner planet to the outer one. The result is to increase the mass of the outer planet. Remember, the outer pole of those little gravitational dipoles is negative. If you add more charge, negative charge to that body, it increases the strength of that force. In other words, the mass of the body appears to increase, its gravitational field increases. But in this case, because of what I'd done in that earlier slide of high school physics, the outer planet will move away. Get our planet of mass, say M1, changes. So the Earth still tickles Mars and Venus still tickles the Earth, but in prior times, during close approaches, those effects would have been far more electrons from the inner planet to the outer one.
Sorry, I was just showing you that
The
graph.
result is to increase the mass of the outer planet. Remember, the outer pole of those little gravitational dipoles is negative. If you add more charge, negative charge to that body, it increases the strength of that force. In other words, the mass of the body appears to increase, its gravitational field increases. But in this case, because of what I'd done in that earlier slide of high school physics, the outer planet will move away, get out of harm's way. Seems like a pretty good idea. So the tendency is for the orbits to change in such a way that this exchange of charge is minimized. Even now, when Mars is behind the Earth, they get what they call a blue clearing in the ionosphere of Mars, and those huge dust storms, all electrical effects. So the Earth still tickles Mars and Venus still tickles the Earth, but in prior times, during close approaches, those effects would have been far more powerful and marked. So stability is achieved rapidly, which was a requirement, of course, for mankind to survive. The important thing to recognize is that the electric universe model doesn't discard gravity. It does what Faraday wanted, to explain gravity in electrical terms. And so inertial mass equivalence is simply explained by this because it's all electrical. When you push an object, it's electrical repulsion, and gravity operates by electrical distortion of particles in the same way. So it's simply because the effect of acceleration upon an atom is to produce the same offset of the heavy nucleus within the atom as does gravity upon an atom fixed in a gravitational field. So when you're falling, actually all of the nuclei in your body move to the center of the atom. You are weightless, massless, so to speak. This little video I enjoy because this raises the question about gyroscopes. The gyroscope spins the atoms in the periphery at many times the force of gravity. In fact, they measure I remember those centrifuges where they put the astronauts for training in higher gravity. All of the nuclei in the atoms of the astronaut's body will shift towards the periphery, and the same in a gyroscope. Now this guy, while he was Professor of Electrical Engineering at Imperial College in London, Professor Laithwaite was invited to give a Royal Institution lecture. He chose to demonstrate his observations on gyroscopic force, coming to a series of false conclusions on gyroscopic motion. The false conclusions this is taken from the actual report about this. These Royal Institution lectures used to be broadcast after the event. His weren't. And the reason was he came up with false conclusions. That's usually weasel words for he gave or performed an experiment which we can't explain. Now there are mathematical equations which appear to explain it, but it uses mass and acceleration and gravity and so on in those equations. And since they're not understood or defined properly, you've got to ask whether the mathematics really works. And the scientists were so uncomfortable with this demonstration that they prevented it being sent because it was false conclusions. These can actually be seen on the web at gyroscopes.org. But here's an opportunity to analyze gyroscopic motion from a new physical standpoint, and doing so may give clues to defeat gravity using materials science as well as physics. The offset of the atomic nuclei in a spinning gyro may be many times stronger than that induced by Earth's gravity, and of the opposite polarity, because here the outer part of the gyro is more positive. It's the positive end of the gravitational dipole. The experiment suggests the gyro becomes more strongly influenced by cosmic attraction than by the Earth. Watch this. Have we got sound?
I'll balance that, first of all, like a seesaw. So there is a balance point. When I take this out here, of course, then the balance point is upset. It should tip down. We know that given the opportunity, it's going to do this if it can, but now we've balanced it, and we've balanced it about its center of mass. So if this gyro transfers its mass center to the pivot, it should stay balanced. Question is, will it? Let those who say I cannot make a body appear lighter than it is, come and pull holes in that one.
Now, what I'd suggest here is that using the electric universe model is an opportunity for mathematicians to apply the electric universe model to try and explain that, because this gyro appears as a positive charge, if you like, in the presence of the negative charge of the rest of the universe and the negative charge of the Earth, and it seems to be more strongly influenced by the rest of the universe. Maybe this is why you can use gyroscopes for inertial guidance. They tie themselves to the rest of the universe. And also with these experiments which show an apparent loss of weight, they may be better understood using the electric universe approach. So, electrogravity. The path since Faraday to the discovery of the electrical nature of gravity has been lost in the 20th century by a return to mathematical mysticism, assisted by computer-generated virtual reality. The path is regained, as Peter Modell, who I think may be here, in the audience, he writes in his book, Making Sense, by describing carefully our experience of processes that deliver meaning, we can arrive at an understanding of what is involved. The intuition of the experimentalist Faraday should have carried more weight than later mathematical speculation, because he had the experience of electromagnetic processes that delivered sufficient meaning for the invention of the electric motor. Electric currents in plasma naturally form repeated rotating patterns of matter from galaxies to stars and rotating weather systems on Earth. Science needs to be simple. Resonant orbital systems of charged particles at different levels of scale within the atom may account for the nuclear force, magnetism, and gravity. That is, one force to rule them all. The electric universe suggests a repeated pattern of electric forces organizing matter at vastly different scales. On the galactic scale, it's the long-range electromagnetic force due to Birkeland currents that dominates. Plasma cosmology empirically duplicates the galactic rotation curve in detail, and radio astronomy has confirmed, very recently, the spiral arm electric currents. It's the electromagnetic forces and the concentration of electromagnetic energy in the galactic core that gives rise to an apparent gravitational mass equivalent to billions of stars. There are no gravitational black holes. As you saw, it's repulsive inside an object. At the stellar and planetary scale, molecular forces form stars and planets and induce a weak gravitational field with the sphere of influence limited by nearby bodies and the repulsive force of the matter in the rest of the universe. By making earthly G a universal constant, we compute invalid masses for all other bodies. Being born in the same electrical discharge event inside molecular clouds, stars and planets will have much the same initial composition and structure, Sun included. Stars do not have a thermonuclear core because they too have Markland convected. I won't go into detail here. It draws the matter in over a vast volume, and all of the heavy elements end in the core. So their radiant energy is due to reactions at the surface in the glowing ionosphere, driven by electric current from the galactic circuit. So this is an extension of Ralph Jurgen's model. The output of stars is not solely due to electrical input. There's something else going on. There are obviously nuclear reactions. So the complex beauty of the non-expanding electric universe is the result of electrical matter resonances and a balance between electrical attraction and repulsion at very different scales. Having a real physical model of the fundamentals, mass, energy, and gravity is the path forward. Looking back, it shows mathematics is a discipline, both ancillary and subordinate to natural philosophy, as physics was known before the 20th century. We are not within a grasp of a theory of everything when the real meaning of the symbols on the board are a mystery. We are not a few % contamination in a dark, unknown universe. Obviously, the architects of the electric universe were far more than mere mathematicians. The electric universe shows more clearly where the real mysteries of physics lie, in the ultimate nature and origin of charged matter itself and the electric force. As Etienne Klein and Marc Lachiez-Ray wrote in their book, The Quest for Unity, the telltale sign of a unification in depth is a more complete understanding of is a more complete understanding of elementary objects and a wider reach to other fields and objects of physics. Welcome to the real adventure. Thank you.
Welcome to the Electricity of Life, brought to you by the Thunderbolts Project at thunderbolts.info. As bees drink sugary nectar and collect pollen for its nutrients and fat, these interactions between pollinator and plant include evolutionary adaptations to electrical science. A high school student from the future would surely mention at least 2 electrical interactions when describing how bees interact with flowers. As a bee flies, it sheds electrons, accumulating a positive charge or electron receiving state. A voltage gradient in the air of about 100 volts for every meter up causes the petals of many flowers to accumulate a negative charge in relation to the air around them. In a manner familiar to any human who has felt static electricity on their hair, the tiny hairs on a bee's body bend slightly towards the flower. These body hairs on bees are connected to neurons especially sensitive to this interaction. When bees land, this static effect from their hairs also attracts pollen like a Swiffer pad. The bee will comb her body to store this pollen more securely on regions of the back legs called the corbicula, or pollen basket. The flower will still have a lower charge of electrons after this visit, for about 100 seconds, for example. This decreased charge may serve as another indicator that bees use to determine which flowers have just been visited. On a different note, these tiny creatures see our shared world painted with a slightly different range of colors than we do. The vibration we perceive as red is simply too slow and wide of a waveform for their eyes to perceive. Meanwhile, they can see much faster and tighter wavelengths of vibration than most humans, which we call ultraviolet. Consider this when you see flowers that appear to our eyes to look rather simple. They may have additional features that our eyes simply do not see. Some flowers are more predominantly red because evolutionary relationships have led them to become more adapted to attracting hummingbirds or butterflies, for instance. Bees are likely just one of many insects which use electrically sensitive hairs for different purposes. We simply may not allocate money and time towards the scientific study of such things. Thanks for watching, and next time you see bees in your garden or among wildflowers, consider how these creatures see the world and how they feel the electricity of life. Welcome to the Electricity of Life, brought to you by the Thunderbolts Project at thunderbolts.info. Beings like ourselves, birthed in an oxygen-rich atmosphere, may casually understand the requirements of life in terms of the creatures we can see. Air is breathed or extracted from water in the case of fish. Water is drunk or retained for weeks and months by hardy life forms. The oxygenated environment around us informs our schemas. It is wise to remember that life is not ultimately defined by water and air. It is defined by the molecular electronics in an organism's biology. There are a great many microscopic life forms here on Earth that can, or regularly do, thrive on substances that baffle human beliefs. 370 miles off the shore of Newfoundland, Canada, the shipwreck of the Titanic was found. It lay almost 2.5 miles deep, or 12,500 feet below the saline water's weight. Growing on the hull of this historic vessel was a fairly historic biological discovery. Giant mats of microorganisms were moving along the surface of the ship, reducing it to rust. Within their protective film, pulses of electrical communication allow highly diverse microscopic creatures to move as a coordinated superorganism. Among the colony are life forms from all three domains of currently known organic life, including ancient archaeobacteria. Using chemical electrical signals, the organisms can communicate some of their growth needs to each other in an impressive show of cohabitation. In our human terms, we might say that some of the tiny life forms are not at all eating the metal, but practically breathing it. This idea owes its strangeness merely to our familiarity with the experience of breathing in air as a necessity for every moment of our life, and our unfamiliarity with the molecular electronics that it actually involves. Our body, during its generation of vital energy, uses the oxygen we breathe as an electron receptor at the end of a process of splitting and recombining molecules. Some microbes use iron or sulfur for the same purpose. Here we can see one plugging in to a microscopic surface of basalt. In fact, there are actually species which, in the wild, naturally use uranium. They are highly resilient at proofreading and repairing their DNA from frequent damage by radiation. They are an apt reminder of the diverse electronics life can have on this planet or others. And when a large colony of different microscopic creatures is carrying out sophisticated alchemy upon one of our industrial, seemingly impervious objects. It reminds us of how much of ecology we do not see. Diatoms are microscopic jewels of the sea, photosynthesizing organisms which absorb silicon dioxide and combine it with water molecules to fashion shells of glass. There are at least 100,000 different species of diatom. Each one can have wildly creative shells, grown from combining these raw molecules of reality to form designs with intricate features measured in nanometers. Imagine we've prepared a microscope slide with some pond water, with a few small visible specks. Looking through the lens, those specks of matter are revealed to be tiny islands in their own right, made of rocks and indeterminate plant pieces, surrounded by unicellular life. Seeing such tiny specks of familiar debris at this layer of magnification gives us a sense of scale, and with that, a more accurate understanding of the sheer amount of life that is thriving all around us, inhabiting and often interacting with the matter we see. In every inch of dirt and every ounce of wild water, there is life in all its chemistry. Built from and manipulating the electricity of the physical world.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. On August 1st, 2016, NASA's SOHO satellite spotted a...
Sorry, I wasn't going to play that one. It auto-played on me. This is the one I had in mind for next. I'm not sure.
Okay, so when I concocted this title, I kind of realized that what makes the world go round, well, what's the world? What I really meant is the Earth. And that's something that we don't often think about, the driving force that makes the Earth rotate. And in fact, all of this came from the book that David mentioned, The Fourth Phase of Water. And most of you, I think some of you have heard the presentations on the fourth phase of water. We all know three phases of water. We know solid, liquid, and vapor. Excuse me, the book presented evidence that there's actually a fourth phase of water, and there are a few properties of that phase that actually gave rise to what I want to talk about today. Let me just begin by mentioning some of those properties. The first one is that when water, and you can see the water, I think there's a, let's see. So this is water that you see here, and next to the water is some kind of hydrophilic surface. And what we found is that when water meets the hydrophilic surface, it builds this huge zone. This is not one or two molecular layers, but up to millions of molecular layers of water that actually changes its properties amazingly. And we call this because the properties are so different, we call it the fourth phase of water. And one of the features that it has is that it's got negative charge. And the region beyond that has positive charge. We call it the fourth phase, and sometimes we call it the exclusion zone, because we found that this zone excludes practically everything from it, just like ice. It moves out into the region of ordinary bulk water. So because this region is negatively charged and this region is positively charged, you can actually put an electrode in here, an electrode in here, and extract current from it. So that's one of the interesting features of this. Another interesting feature is where the energy comes from to build this zone of water and to separate the charge. It comes from light. This was rather a surprise to us, but we found that if you expose the water to light, what happens is this exclusion zone, EZ, exclusion zone, fourth phase of water builds, and the charges separate. So we found it really interesting that light, that sunlight, for example, is the energy that drives the buildup of this phase of water. Now, when you think about it, this has led to a lot of thinking about the consequences of this. And one of the consequences that I'm going to be talking about is the rotation of the Earth. Now, I know it's impossible to think of any linkage between what I showed you a moment ago and the Earth's rotation, but I bet that a lot of people here don't really think about what makes the Earth turn. Maybe you do, I'm not sure. Most of my colleagues don't think of it. Oh, you know, it just turns, it spins, right? It started spinning from day one and it just keeps spinning. But when you think about it, you know, most things that spin run down. There are energy losses and it just doesn't keep going forever. And when we think of the Earth, you know, something may have set it spinning 5 billion years ago or something. You can imagine something spinning for maybe a few times or a few years or even a few hundred years, but 1,000 years, 1,000,000 years, 1 billion years, can it really keep going on that initial energy? Is inertia enough to keep it going? So we started thinking about that, or I started thinking about that. And so what I want to get to toward the end of this talk, and I'll give you a punchline, is that I'm going to suggest to you that the wind blowing over the Earth is actually what's responsible, at least hypothetically, a speculation, for keeping the Earth rotating. And then, of course, the question arises, well, okay, so I'm suggesting that the wind is responsible, but what gives rise to the wind? That's another topic that I bet not too many people have thought about. And I'm going to be suggesting to you that the wind actually comes from charge gradients, lateral gradients of charge, particularly positive charge in the atmosphere. So that's where I'm going. And the way I'm going to do it, I'm going to answer a series of questions, and the list is here. First of all, when we think of charges, charges can exert force, repulsions and attractions. And I think most of us, maybe with the exception of the people here in this audience, don't really think of charges as having really powerful forces. We think, you know, we touch something, we get a shock, and okay, but we don't think of really strong forces. So the first question is, well, okay, well, how strong are charge forces? If you got a plus and a plus near one another, is it weak? Is it strong? Next question. Where on Earth do charges, where on the Earth do charges hang out? Okay, and I want to talk about the Earth itself and the atmosphere and the charges that we find there. And the next question, which you could have surmised, is, are there really gradients of charge that we can identify? And then can charge gradients really drive the prevailing winds? And if so, can the prevailing winds spin the Earth? Okay, so first question, how powerful are charge forces? Well, one of the phenomena that got me started is something shown by our previous speaker, Don Scott, in one of his books, and that is, if you put a proton next to an electron, let's say at a distance d between them, there are actually two forces that you can think of. The first one is the obvious one, which is the attraction, the electrostatic force. But also, since the two have mass, there's a gravitational force. And the question is, okay, which one is stronger and by how much? And I'm sure most of you will of course, guess that the electrostatic force is larger than the gravitational force, but by how much? See, so that's a question. And the answer turns out to be 10 to the 38th. It's not trivial. It's a huge amount. But I think most of us don't really understand what 10 to the 38th really means. We can understand 10 times or 100 times or 1,000,000 times, but 10 to the 38th. The 10 to the 38th is something like the schematic shown here. If you take a proton on the upper left and consider the diameter of the proton, okay, and then consider another distance. If you look at next to the last panel there, you see the solar system. And if you take the distance from the sun to the edge of the solar system, take the ratio of that distance to the diameter of a proton, that's only a mere 10 to the 19th. We need 10 to the 38th. So you know, we're talking about the ratio of the size of a proton to the distance between us and some distant galaxy. That's 10 to the 38th. It gives you some idea about how strong the forces are, the electrostatic forces compared to gravitational forces. Okay, here's another example. You take two copper balls sitting on top of one another, and you start removing electrons from each one of them. That, of course, leaves the two copper balls positively charged. And so the question is, well, how many electrons do you need to remove so that the top one levitates? Okay, and I don't know, maybe you know the answer to that. It turns out the answer is 1 in 10 to the 7th. In other words, only 1 in 10 million approximately electrons need to be removed so that this ball, because of repulsion, starts levitating, a really small force. Another example, you take a light bulb, take one of the old-fashioned 120 watt light bulbs, and you know the current goes through the filament, right? And if you could, suppose you could capture electrons and capture, let's say, 1 second's worth of electrons running through that filament. And suppose you could take that and compress it into, just like a sort of a nucleus of positive charges, you compress it into a dot. And you put one of those dots down at the bottom, resting on the ground, and the other one 1 meter higher. And so the question is, in order to prevent the levitation, and to keep it where it is, how much weight would you have to put on that? Anybody want to take a guess?
The entire planet.
Okay, thank you. Okay, the answer is 50,000 fully loaded garbage trucks. I would have shown jumbo jets, actually there are 5,000 fully loaded 747s, but my son, the artist, couldn't draw them. Okay, and here's finally, not to belabor the point, but it's an important point. Consider this. Suppose you're lying down and somebody is lying or suspended, let's say 1 meter above you, okay? And you remove 1% of her, she's got a lot of electrons and protons, you remove 1% of her electrons and 1% of the electrons of the person below. They're 1 meter apart. And of course, both of them become positively charged, so instead of coming together, which they might like, they're actually coming apart. And the same question, how much weight would you need to put on top of the upper person in order to prevent the levitation? I guess? Lots. Okay, how much is lots? Right, the Earth. The weight of the Earth. And this is not my calculation. You'll see it in Feynman's lectures. He calculated it. I guess he knows how to calculate. So in other words, the point of these somewhat repetitious slides is that charge forces can be astonishing. And if we don't take into account the force exerted by those charges, we're missing something, and probably we're missing something really important. Okay, so one question is, well, okay, so charge forces can be astonishing, but to do that, you need to have separated charges. And the question is, can substances really bear net charge? Okay, and the answer I'm going to say is yes, although chemists will generally say that no, they can't bear net charge because everything tends toward neutrality. But here's an experiment from last week. Here's an electrolyzer, and some of you may know this electrolyzer. It produces so-called health-promoting water. If you drink, it separates the water into negatively charged and positively charged. But they don't tell you it's negatively or positively charged. It's high pH or low pH. And if you were to drink the low pH water, you'd spit it out because it's awful, kills bacteria. But if you drink the high pH water, pH 10.5, 11.5, something like that, it tastes delicious. And there's a lot of evidence that it actually is good for your health. And you'll find in Japan, for example, this kind of water is if you have any kind of gastrointestinal problem, you go into a clinic, and I'm told by my colleague in Japan that the first thing they do is they put you on this alkaline water, and the government pays for it. So it's got something. Anyway, this has nothing to do with the health benefits of this water. But you can take the water and you can, as you see on the left side, you can fill a couple of beakers with it. And what we did is we took a simple voltmeter and we put one probe in the high pH and one probe in the low pH, and voila, half a volt between those. And the half a volt is sustained easily for an hour. That's as far as we went. So yes, you can have sustained charge in vessels of something. This is water. Here's another example. This one's kind of cool if you've seen it. This is well, you start with some beaker of water sitting on the top, and so here's so you start with the water, and then what happens is that the water divides into two columns, and the water drips into both. It passes through this ring, and it passes through this ring. By the way, this is called the Kelvin water dropper experiment done by Lord Kelvin. Okay, and the drips go through these, and these collect in this container, and these collect in this container. And what happens is that, well, they drop into there, and after a while, the charge seems to build up in some way, and then you get a zap, you get a discharge between those two electrodes. It's audible, you can see it, it's really astonishing. And if you look, I mean, and even before the zap, if you stop the flow, these two containers will sustain charge. So one's got negative and one's got positive. And these charges can be amazing if you look at the drops falling into the beaker after a lot of water has got not enough to discharge, but quite a bit. And it looks like this. So at the bottom is the cup. And you can see these traces. These traces are actually falling droplets of water. They should fall into the cup, but the cup has so much charge, and the falling droplet is the same charge, that they get repelled. You can see these traces going upward. So it means that the charge forces can easily defy gravity. So we're talking about really strong forces. Now the point is, substances can bear charge, and charge forces can be huge. So I've answered the first question, how powerful are charge forces? And the answer is much more than most of us think, extreme. Next question is, okay, where on the earth do charges hang out? And it's known, it's well known that there's an electric field. I remember when I was told that there's, I come from a different field. I don't know what most of you people have known since childhood. And And a Russian colleague of mine who was working in my laboratory one day just happened to ask me if I knew anything about the Earth's electric field. And I said, what are you talking about? You mean magnetic field? He didn't know electric field. And he said, you don't know about it? And it was kind of amazing. He said he grew up in Russia, of contemporary age, and he said every middle school student knew about the electric field of the Earth and the negative charge on the face of the Earth. And I guess in this country we don't learn that, or at least we didn't learn that. But anyway, it's well known. It's in the textbooks, especially the textbooks from 50 to 100 years ago. The electric field is about 100 volts per meter at the surface of the Earth. And there must be, therefore, some negative charge on the Earth and positive charge somewhere up there. So essentially, the point is that the Earth somehow bears negative charge. And again, back to the health issue, some of you may know that it's now advocated by people in alternative health or any kind of health to just walk barefoot on the beach. You know, if you walk barefoot on the beach, you're basically soaking up the electric charge, negative electric charge from the Earth, and you need that charge. The body needs negative electric charge to thrive. That's a different issue. I don't want to go into it. So it's called earthing or grounding, depending on where you come from. And in Japan and some of the other Asian countries, mud baths are pretty common, and mud baths are said to have healing properties. And I think the reason for this has to do with connecting to the negative Earth. Okay, so question is, now where does this negative charge come from? The standard interpretation, again, if you read Feynman's lectures, volume 2, chapter 9, lightning. This is commonly thought to give rise to the negative charge on the Earth. We don't get that much lightning, at least in Seattle, maybe here in Phoenix, there's more, but around the Earth, there are huge numbers of discharges. And so it's possible that the lightning comes, strikes the Earth, brings negative charge, and the Earth can't rid itself of that negative charge rapidly enough, and therefore it accumulates a net negative charge. Well, that's one idea. Another idea is that it may come from the Earth's water, and this, as you can see, came from the work that we had done to produce the book that I mentioned. See, if you have EZ water down, the Earth is, of course, filled with water, and if much of that is the fourth phase or EZ water, it bears negative charge. See, so that could be another source of this negative charge. And interestingly, the sun builds this EZ and negative charge. So we have some sort of relationship with the sun. Essentially, we have the sun beating on the Earth, and we have negative charge that builds. And if the Earth is highly conductive, as many investigators think, then these charges will all around and fill the subsurface of the Earth with net negative charge. So, okay, there's a negative charge, and you might say, well, where do the corresponding positive charges lodge? They're initially together with the water, but many of these protons evaporate into the air. So we have the negative and the positive ones, along with negatives, which actually form clouds, the positive ones are rising up into the air. And as they rise up into the air, you have a situation that looks like this. The Earth is negative, and then you have positive charges that begin rising up, as you see here. And close to the Earth, there's a high concentration of positive charges because those charges are attracted to the negativity of the Earth. But as you get higher up, the protons or hydronium ions tend to repel one another, and they rise vertically and begin to spread out. You have positive charges in the atmosphere and negative charges on the Earth. And if you think about that, plus and minus, you have a situation like this, and basic electrostatics tells you that the positive charges are clinging to the negative charges, and so the atmosphere clings to the Earth. And the question that arises, well, if the atmosphere clings to the Earth, it exerts pressure on the Earth. Does this explain atmospheric pressure? The prevailing pressure mechanism is fraught with several paradoxes. We think of pressure arising from the weight of the air. So the weight of the air is pressing down on us. And if you're on top of Mount Everest, there's less air and it's pressing less on you. But if you think about that, we have a gas up there, and the question is, well, we define a gas as you have molecules and they don't stick together. They actually bounce around and hardly interact with one another. And so if they don't interact except very rarely, then can we easily imagine how they press on the Earth? Or why when you're higher up you have less pressure? It's possible, but it kind of, when you think about it, those isolated air molecules not clinging to the Earth the way I suggested to you, but just sort of hanging out there, it leads to the spectacle of, there's a lot of winds up there, and why doesn't the atmosphere just blow away? Don't know if you ever thought about that. Okay, here's another paradox about the atmosphere and the way we think about the atmosphere, and we're ignoring the positive charges that I told you about. Well, the atmosphere is a mixture of gases. It's not just nitrogen and oxygen, and a whole bunch of other gases. So among them, argon is about 1%. It's actually quite a lot of argon that we have in the air, and CO2, of course, causing, apparently, maybe, depending on your belief system, a lot of problems. But argon is the densest of all. And so if argon is the densest of all, you think after all these years that you might have a situation like this. If density really matters, we're fraught with a serious problem. Okay, so we got positive charges in the atmosphere and negative charges on the Earth. And so it's possible, I think, that atmospheric pressure may arise from the positive charges attracting to the negative Earth and pressing down. Quite simple. So, okay, where do those charges hang out? In the Earth and in the atmosphere. Next question. Are there substantial charge gradients, differences of charge that we can imagine? And the answer I would suggest to you is yes, there are both vertical gradients and lateral gradients, the lateral ones being the ones I'm going to be focused on in a moment. But the first is, I mentioned to you that the protons diminish with increasing altitude, and that's shown on the two panels there. Now, suppose you put a test charge, the red one, down near the surface of the Earth. There are a lot of positive charges there, and you'll detect a high electric field. And if you put the test charge higher up, there are fewer positive charges there, and the electric field will diminish. So the field strength diminishes with increasing altitude, and that's well known, well reported. This is nothing controversial. The field strength also increases with sunshine. This is the interesting part that maybe some people are unaware, but there's enough evidence for this. So if the positive charges are caused by evaporation from the Earth's water, then nighttime there's not much evaporation, right? The charges should be fairly low in altitude. And during the daytime, when you have ample sunshine creating evaporation, those positive charges should rise way up, right? So there should be a big difference between daytime and nighttime. And so therefore, the electric field, which depends on all that charge, should vary with the time of day. So if you have, for example, in the middle of the day, you ought to see a lot of electric field when you're measuring up, well up above the Earth. And at nighttime, it wanes. So it waxes and wanes. And the evidence for that is right here. So this is a plot. This is a bit complicated, but on the abscissa, you have time. And if you look right in the middle at 12 o'clock, that's noontime GMT. That would be Greenwich, okay, in England. And the electric field that was measured up in the air. look at the oscillation. So first look at the middle one, Africa and Europe, and you can see that the peak occurs roughly 2-3 p.m. around Europe, just when the sun is kind of has been around for a while, high in the sky, maximum evaporation, all those positive charges high. So you can see that the electric field there is very high. Now look to the right, and you can see the US. That occurs 6 or so hours later during our afternoon. So you can see that it doesn't matter where you are, during the nighttime, the electric field is low, and during the daytime, it's high. And look at the differences between them. Look at the Americas, the blue one. You can see that during the daytime, the electric field is 10 times higher than it is at night. This is a huge difference that I think many people are unaware of. So there's a great big difference between day and night. And you can see that there's a gradient. When night meets day, there's a gradient. And also on the other side, the upper right of the figure, there's another gradient. There's a morning gradient and there's an evening gradient. Big, huge lateral gradient of positive charge. So, do substantial charge gradients exist? Both vertically and horizontally. Okay, now, can those charge gradients drive the prevailing wind? So think about it. Seattle on the left, we're snoozing and snoring, and we haven't really gotten there yet. And New York is beginning to be bathed in sunshine, and if it's bathed in sunshine, those positive charges are rising up into the atmosphere. But at nighttime, there are very few of those. So there's a lateral gradient. Those charges repel one another. They want to get away from one another. Where do they go? Well, they're going to go to the left in this. And if the charges are moving, the charges are at least dragging the air with them, because these charges are either protons or more likely hydronium ions. And they're either dragging the air, or they may be attached to the air, bound, for example, to electronegative oxygens or nitrogens. So the air is going to move also. And if the air moves, basically we have wind. So I believe that charge gradients can create wind, especially the large gradients with powerful forces that we're talking about. So there's a morning boundary and the evening boundary, and I think those give rise to something interesting and characteristic. Here's the morning boundary. Okay, again, New York has received its sunshine, and Seattle with the Space Needle is still dark, and we have this charge gradient. The charges is morning, the charges are beginning to rise up, and there's going to be a wind that goes across that gradient toward Seattle. Okay, now this is also shown on the next slide. Now, sorry, this one's a little complicated too, so let me explain. So this is the surface of the Earth spread out. So we have nighttime in the center, and we have morning on the right side and evening on the left side. Now, start on the right side and morning, and remember that's just what I was talking about. The wind is blowing from the east toward the west, and it's not a strong wind because the charges on the right side are just beginning to rise up. There are not so many, and it causes a wind. You might call it a morning wind, and the wind blows from east to west, and that's known as the trade wind. Trade wind blows gently. It's what got Columbus to the New World. Now look at the other side. Look at this is the left side is the evening. Okay, and by the evening, mid-afternoon, late afternoon, the charges are way up high, and the gradient is in the opposite direction. It blows from the late afternoon toward the evening, so it blows from west to east. And anybody who's flown knows that there's a wind that flows continuously up high. It's called the jet stream that flows from west to east, and it's pretty strong, 100, 200 miles per hour. So if you fly to New York, it's quicker than if you fly from New York to Seattle or Los Angeles. So I think we can understand that this high wind is going to be stronger. This high westerly wind is going to be stronger than the low easterly wind because there are many, many more charges by late afternoon, by mid-afternoon to late afternoon. So I think those two gradients, the morning gradient and the evening gradient, could perhaps adequately explain why we have trade winds and jet stream. So the question was, can charge gradients drive the prevailing wind? And I've shown you some evidence, suggestions that maybe that could be the case. Okay, now, can the prevailing wind spin the Earth? Well, you don't, if you think about it, you really don't need a whole lot to, you have a wind that's blowing at 100 or 200 miles an hour. Actually, you know, the Earth is spinning itself, right? The Earth is spinning at what is it, roughly, I think, 1,200 miles per hour compared to the reference frame of the cosmos. And the wind is going, the jet stream is going 100 or 200 miles per hour faster. So it's like the jet stream is blowing, and it could be blowing the Earth, and the Earth can't quite keep up. So it's a little bit slower, and that's why we have a jet stream relative to the Earth that's 100 or 200 miles per hour faster. So I think it's possible that we don't need these tall peaks. This is obviously just illustrative, but all you need is a gradient and something rubbing on the Earth or rubbing on some protrusions. So the advantage of this kind of wind mechanism is that, so the rotation of the Earth now no longer depends on the inertia. As I said, maybe you think differently, but it's difficult for me to imagine that inertia could keep us going for 5 billion years. It's a lot of time. And also, the sun's energy is the ultimate driver, because remember, the sun's energy is what splits the charge in the water, which gives rise to the positive charge. And so it all comes back to the energy from the sun. And so the conclusion from this is that the reason the Earth keeps spinning is it gets energy from the sun to make it spin. It just doesn't do it. It's known that the rotation speed of the Earth is not constant. It fluctuates even by the day. If the Earth turned by inertia, there shouldn't be fluctuations. There are fluctuations, and so this can explain it. So the question is, can the prevailing wind spin the Earth? And I think the answer is possibly, perhaps that could be. Finally, the last few slides, this is a sort of extra, and so I'm suggesting to you that there's charge flow around the Earth, right? Charge flow, wind. And I want to touch on magnetic fields, because charge flow, current, magnetic fields, they're kind of tied together. And with those charges constantly, like the jet stream, constantly flowing around the Earth, basically, oops, sorry. Basically, we have a current that's flowing around the Earth. So think of a current now flowing around the Earth from west to east. And think about what we know from basic electrostatics and dynamics. If we have a current flow going this way, we have a magnetic field using the right-hand rule as shown here. Now think about applying this rule to the Earth. So the horizontal arrows, that's the wind, that's the jet stream that blows constantly around the Earth. It's a current. The current is flowing around the Earth. And if you have a current flowing that way, then those thicker lines show the magnetic field. So it's possible that you can actually get magnetic field occurring just from those charge gradients, creating current that flows around the Earth. So it's possible. I mean, we like to think that the Earth's magnetic field comes somewhere from the core of the Earth, but you know, nobody's ever been there to make that measurement. And it's kind of odd that you got a magnet sitting there, but the angle of the magnet keeps changing, which it does. Sometimes it even flips. That's not so. I mean, we're really not sure that the magnetic field arises from the core of the Earth. And I'm suggesting to you that it's possible that the Earth's magnetic field arises externally and not internally. So I draw some conclusions, and I don't really mean that they're conclusions. I mean they're speculations. I've shown you very little evidence. I've shown you just a few ideas that have stemmed largely from the book that I produced and the ideas that went into it, and a bit of evidence, but mostly just logical sequences. And the first one is not is well known, and we all should know it, that charges can exert enormous forces. Sometimes we attribute phenomena to gravitational forces. For example, the settling in a beaker of water with some particles, we think of gravitation, but that beaker of water contains enormous numbers of charges. The charge forces outweigh the gravitational forces enormously. Remember, 10 to the 38th. The Earth bears negative charge. Again, there's a lot of evidence for that. Evidence starting more than 100 years ago and continuing. It's just that it's not really well known. The atmospheric scientists know that the atmosphere is full of positive charge. Oddly, it doesn't seem to me, I've never seen anybody make the suggestion that plus attracts minus, that atmosphere attracts Earth. It seems almost a no-brainer. One has to calculate how much force, but it seems like a really simple and easy interpretation of atmospheric pressure, that the atmosphere clings to the Earth because plus and minus attract. It's the sun's energy that builds that atmospheric positivity through evaporation. At night, there's not much evaporation, not much atmospheric positivity. And because of the regions between sunshine and darkness, you have lateral charge gradients. And remember how strong the force of those charges it can be. And so that inevitably drives winds, and winds create friction. And the question is whether that friction is sufficient to create the Earth and keep it spinning and giving us day and night. And it's possible that those charges may actually create the Earth's magnetic field. So I guess I would like to conclude with the fact that the universe, or at least the Earth around us, is indeed electric, as I know many of the people here would like to think. And also the point is that, alternative theories can sometimes make sense. And I end with one example of an alternative theory. This is an alternative theory for global warming and the rise of the sea. Suggest an alternative mechanism, and thank you for listening. Thank you.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. A recent scientific paper shatters long-held beliefs about our solar system's history and affirms one of the most radical tenets of the electric universe paradigm. For many decades, scientists have believed that meteorites, as well as comets and asteroids, are the so-called leftovers from the solar system's formation. Meteorites have long been thought to have formed in a primordial dust cloud billions of years ago. But a recent graduate of Florida State University named Jonathan Olton, together with his colleagues, analyzed pieces of a meteorite called Gujiba and has found that its geological origins are much too complex for standard theory to explain. The team's conclusion is that the meteorite formed from the molten debris of a planetary collision in the asteroid belt. A Phys.org report on these findings states, based on chemical traces preserved in Gujiba, the target planet might have been even larger than the asteroid 4 Vesta, one of the largest bodies in the asteroid belt with a diameter of about 326 miles, or 525 kilometers. One of the lead investigators says of the discovery, "People used to say that meteorites like Gujiba were the building blocks of the solar system. Now we know it's the construction debris of the planets." The Phys.org report states that the findings, quote, shattered previous theories about when and how this meteorite had formed. However, the electric universe theory, as developed by physicist Wal Thornhill, has always been that meteorites, as well as comets and asteroids, were excavated from planets and moons, although not from mechanical collisions, which are the only mechanism available in standard planetary science. Rather, these bodies were removed electrically by interplanetary thunderbolts in a relatively recent period of chaos in the inner solar system. Indeed, many landmark discoveries in recent years have affirmed the electric interpretation of comet, asteroid, and meteorite origins. For decades, scientists have puzzled over the origins of glassy beads found in stony meteorites, called chondrules. The theory of meteorite origins in a primordial dust cloud did not allow for the extreme heating and sudden cooling required for the chondrules' formation. In 2013, a scientific study suggested a surprising conclusion, that lightning within a theoretical protoplanetary disk could explain the mystery. A Space.com report on the study stated, rocks melted in the early solar system after electrical currents spiked through the cloud of dust circling around the young sun. Unfortunately, like this latest finding on the planetary origins of meteorites, many surprising comet, asteroid, and meteorite discoveries have yet to force a reassessment of our solar system's history. Rather, special conditions and ad hoc adjustments are invoked to preserve, quote, consensus theory. A glaring example of this was seen in the aftermath of NASA's Stardust mission to the comet Wild 2 in 2004. Mission scientists had never dreamt that the tiny fragments of comet dust brought back to Earth had not accreted in the deep freeze of interstellar space. The name of the mission itself was based on the assumption of comet formation in a primordial interstellar cloud. Nevertheless, it had to be admitted that the complex crystalline structures were formed under astonishingly high temperatures. Mineral inclusions range from anorthite, which is made up of calcium, sodium, aluminum, and silicon, to diopside, made of calcium, magnesium, and silicon. Formations of such minerals require temperatures in the range of thousands of degrees. NASA curator Michael Zelensky said, "That's a big surprise. People thought comets would just be cold stuff that formed out where things are very cold. It was kind of a shock to not just find one, but several of these, which implies they are pretty common in the comet." Investigators were forced to conclude that the enigmatic particles formed at a superheated region either close to our sun or close to an alien star. Stardust principal investigator Donald Brownlee said, "In the coldest part of the solar system, we found samples that formed at extremely high temperatures. When these minerals formed, they were either red-hot or white-hot grains, and yet they were collected in a comet, the Siberia of the solar system." Some scientists speculated that perhaps something occurred in or very near the sun in its formative phase, flinging immense quantities of material out to the periphery of the sun's domain, far, far beyond the orbit of Pluto, all the way to the theoretical Oort cloud. Then the investigators reminded themselves that this would produce a mixing of material, contradicting the zoning that is evident in the asteroid belt. Michael Zelensky asked, "If this mixing is occurring, as suggested by these results, then how do you preserve any kind of zoning in the solar system? It raises more mysteries." A 2007 report states that parts of Wilt 2 formed in an area close to the sun. The SpaceDaily.com website writes, the X-ray and isotopic analyses point to gas acquisition in a hot, high-ion flux nebular environment close to the young sun. A few have suggested that a, quote, transient heating event such as shocks or indeed lightning in the outer regions of the protoplanetary disk may have created the anomalous minerals in the Wilt 2 dust samples. NASA's Dawn mission to the asteroid Vesta also recently gave a jolt to the story of our solar system's origins. Scientists had theorized that the asteroid is a, quote, planet embryo that came into existence at the same time as the solar system. This theory states that the asteroid suffered an enormous, quote, double meteorite impact that dug tens of kilometers deep and would have ejected material under the asteroid's surface. Since olivine is a main component of planetary mantles, the investigators expected to find it in abundance near the so-called impact craters. But no olivine was detected. As the website Science Daily reports, these findings, quote, challenge a fundamental component in planet formation models, namely the composition of the original cloud of matter that aggregated together, heated, melted, and then crystallized to form planets. Sadly, no consideration has been given to the possibility that the asteroid is not primordial, nor have theorists asked if the pervasive cratering might have occurred through any process other than impacts across eons of solar system history. In fact, cratering by impact seems profoundly unlikely. As in the case of the large crater on the Martian moon Phobos, an impact of sufficient energy to create the largest Vesta crater would have surely shattered the body. Today, the startling truth is that no coherent and reliable story of our solar system's birth and evolution remains, and the theory of comets, asteroids, and meteorites is entirely in flux. Yet new pathways of discovery are waiting to be found in our electric universe. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Earth's geology is primarily a study of incremental processes over eons of time. Volcanoes, earthquakes, weathering, and erosion are the forces that geologists theorize of having shaped our planet's landforms and surfaces. But the Electric Universe is opening new theoretical pathways for understanding our Earth and all planets and moons. In the Electric Universe theory, as proposed by the chief principles of the Thunderbolts Project, in a relatively recent period of chaos in the inner solar system, interplanetary electrical discharges shape the surfaces of the planets, including the Earth. What evidence do we see of these events on our planet? In this episode, Thunderbolt's colleague Andrew Hall begins the first of a three-part presentation on the revolutionary concepts of electric universe geology.
One of the most compelling aspects of electric universe cosmology is that it is visually apparent. A person can compare the image of a Peratt column to a petroglyph and reasonably conclude our ancestors viewed a different sky than we do. Or look at the image of planetary nebula and recognize the hourglass shape of plasma currents contracting to form a star. In fact, through electric universe eyes, one can see the patterns in nature from galactic to nuclear are coherent, fractal, and electric. The planets and moons of our own solar system provide some of the most accessible and compelling visual evidence of all. Hexagonal craters, rim craters, rills, and volcanoes, often concentrated near the poles or in one hemisphere, attest to an electrical formation. One can imagine the vortex of discharging plasma at Carver. Earth also shows electric scarring. In an electric universe, it has to be the case, but it's not intuitively apparent. Unlike the Moon or Mercury, Earth doesn't display a carpet of hexagonal craters. There are some craters we know that are ancient and eroded, but their formation remains controversial. There does exist proof of electrical scarring on Earth, however, and it's in abundance. You can say it's staring us in the face, and I'm going to show you how to recognize it. The evidence is in the mountains. Basin and range, mountain arcs, and mountain cordilleras are all proof of electrical discharge. To understand the evidence, however, requires looking beyond the simple concept of a lightning bolt from space. The reason is the Earth's atmosphere. When electrical discharge occurs in an atmosphere, it creates sonic hydrodynamic effects. We experience the effect when we hear thunder, the sonic boom of a lightning bolt. It's the sonic and hydrodynamic effects in a dense, viscous atmosphere that leave their mark on the landscape at the grandest scale. In a previous Thunderblog article titled Surface Conductive Faults, I presented the concept of a surface conductive double layer providing a path for arc flash. The surface conductive path is the cloud layer, where we can see that ions collect to produce thunderstorms. Imagine now a lightning bolt of immense proportions, sheets of lightning, in fact, arcing through the atmosphere. The focus of our discussion today is the hydrodynamic effects of the resulting arc blast. Arc blast is the consequence of arc flash in a surface conductive current discharge. We'll now look at the recipe for a mountain. This image from Los Alamos Laboratories shows a shock wave created by a supersonic projectile passing over water. The colors display density, highest in the red, lowest in the blue. Purple is the baseline density of the atmosphere. This image provides a very good analogy for the way a mountain is built. The result of an arc's passing is embossed on the land by shock waves that act almost precisely as those made by this projectile. The difference being the shock wave is plowing land, not water, and it has the hypersonic velocity, heat, and power of an arcing current, much more energy than a simple projectile. The bow shock is an anvil of many tons per square inch at a temperature many times that of the sun, 30 to 40,000 degrees Fahrenheit, carrying charged electric fields. In a dense, viscous environment, fluid mechanics, shock effects, and electromagnetism align in phase and frequency with the arc that creates them, meaning the resulting shock wave carries not only extreme pressure and density, but also heat, electric current, and magnetic fields. Looking at the picture, in region 1, the bow shock plows the land, melting and vaporizing the rocket impacts. Region 2 is a reflection of the shock wave as it rebounds from the surface and blasts into the atmosphere. It creates a low pressure zone in its wake, drawing an exploding cloud of vaporized debris into a Richmeyer-Meshkov instability, more commonly known as a mushroom cloud. The cloud is not shown in the projectile over water because that simulation did not involve the explosive effects of expanding gases heated instantaneously by an arc flash. In region 3, a low pressure updraft forms, like the rooster tail behind a speedboat. The rooster tail pulls a bladed melt from the crater, and this is what forms the core of a mountain. In region 4, shock reflections form triangular waveforms that trail behind the projectile. Note the reflected wave bounces from the surface. So the base of the triangular waveform forms on the surface that reflects it. This is worth remembering. The multiple shock reflections in region 4 are standing waves. Standing waves don't travel. The waveform stays in place with the energy coursing through it. Reflected waves multiply like reflections in a hall of mirrors, repeating harmonic triangular waves to the nth degree until the energy of the shock dissipates. We'll talk more about the reflected shock waves in a moment. Now, Let's go back to region 2, where the initial shock reflection develops the mushroom cloud. The mushroom cloud rises behind the shock wave with a supersonic vacuum at its core. You have likely seen video of a nuclear test explosion. The mushroom cloud forms in the wake of rebounding shock and develops a powerful updraft in the stem of the mushroom. That is.
Okay, I'm back.
The electric universe shows more clearly where the real mysteries of physics lie, in the ultimate nature and origin of charged matter itself and the electric force.
There's no form of matter or energy in the universe that cannot be experienced and experimented with here.
Do I believe that I live in an ordered world? Do I believe I live in a created world? Do I believe that I live in a meaningful world?
Welcome to the real adventure.
Elegant simplicity. In the sciences, that's the holy grail. As mysteries arise, seek out the root causes, the gems in the rubble pile, and then even the rubble will begin to make sense. Is it gravity that drives the universe forward? Within the space sciences, that's long been a foundational assumption, not to be questioned. But is it true? Or is there a deeper level at which gravity itself is an effect, not a first cause? Day by day, this question rises to the surface, even taking center stage on occasion. Today's most inspired scientific discussion places a spotlight on the electric force acting at all scales in the natural world. The subjects range from the subatomic domain and bioelectricity up to galactic and intergalactic space, even including profound events close to Earth in ancient times, some affecting human consciousness the world over and provoking new interest today in experimental verification. With the introduction to the electric universe comes a wave of realization and inspiration. The signature of electrical events is now more clear than ever, and the result is a scientific revolution now well underway. Come to our conference in June and meet today's pioneers of the electric universe paradigm, June 17th to 19th in Phoenix, Arizona.
Understanding.
Welcome.
This is an example of the same sign from 4000 BC in prehistoric Egypt, the exact same image, just a little bit different coloration.
Oh, sorry, I just jumped way ahead.
Good morning, everybody. It's great to be back meeting you amongst old friends. I recognize so many of you from last year. Appreciate your attendance. I'd like to talk about some what we consider incontrovertible evidence that the skies are radically different nowadays than they were in prehistoric times. Okay, the top scholar of Mesoamerica had this to say: the peoples of ancient Mesoamerica keenly observed the sky and used the calendar to predict solar and lunar eclipses, the cycles of the planet Venus, the apparent movements of constellations, and other celestial events. To them, these occurrences were not the mechanical movements of innate celestial bodies, but constituted the activities of the gods, the actual recapitulation of mythical events from the time of creation. You could take that statement and apply it exactly to the traditions of ancient Egypt, ancient Mesopotamia, ancient India, Greece, the rest of the world. That is what myth is all about, describing the behavior of the gods in the sky as creation unfolded. So in the Maya account of creation, here's what it says. They fixed their eyes on the dawn, looking steadfastly for the coming forth of the sun. They occupied themselves in looking for the great star, which appears first before the birth of the sun. The face of this green morning star always appears at the coming forth of the sun. So the takeaway lines here are that the morning star appeared at creation and that it was green in color. Those astronomers among us will know that Venus does not currently present a green color. The Maya had a hieroglyphic script, and so in their earliest writing systems, this was their glyph that denoted the great star. So this is the great star they're talking about, the morning star. And I would draw your attention to the glyph on the right, which looks like a little star or cross in the middle on like a fourfold form. But look at the four little circles in the four corners. Kind of keep that in mind as we go forward. These are two more variations upon the same glyph that are in hundreds and hundreds of Mayan hieroglyphic codices. So they're both the same sign. It's just the one on the left shows a star in the middle of the four dots, and the one on the right, it looks more like a cross. So the question is, or I guess it's pretty obvious that that sign is not recognizable in today's sky. So consequently, the top scholars in Mesoamerican studies say this is an abstract image. What does it show? Well, according to them, it shows the four different phases of the planet Venus, all of which are invisible, needless to say. So here's the top scholar in a recent book. Says the fact that there are four circles in a cross-shaped frame naturally suggests the four phases of Venus associated with the four different directions. So clearly the assumption is that this is an abstract drawing that some astronomer dreamed up a long time ago.
25% faster.
As it turns out, that image is present at least 500 BC. So they are essentially telling us that the Mayans were practicing super sophisticated astronomy in 500 BC already.
Which isn't ever talked about.
Unfortunately, most of those guys have no knowledge of comparative art or comparative mythology. So they kind of overlook the fact that the exact same sign is found all around the world. So here's the exact same image from an old Babylonian cylinder seal from roughly 2000 BC. So that right there just shoots their theory out of the water, but that's an abstract sign. Here's a very similar image from the pre-Vedic civilization in ancient India. This is roughly 3000 BC. So you can see that this image is prehistoric in nature. Okay, back to ancient Mesoamerica. This is another very common sign for the great star. And again, it will be found in various different cultures down there, whether you're talking the Mayas, the Aztecs. I guess I should maybe point out which sign I'm even talking about there. But I'm talking about, whoops.
It's on the left.
Sorry about that. Kind of jumped on us. This stellar form here to the left, you will see is a fourfold star. And so that is the image that they're talking about, the ancient Mayans, when they're talking about the great star. And this particular image can actually be found on a colossal face down in Olmec times, which is 1000 BC in Mesoamerica. And these massive faces were found, not unlike the Easter Island statues. They're about 10 tons in size. I mean, they're just a massive piece of rock. And on the side of the rock, it will have that exact sign, already at 1000 BC. This is a much more recent example of the same sign from the Pueblo region here in the American Southwest. And an astronomer offered the following discussion of this sign. He says, this is a common form of the southwestern four-pointed great star symbol and the sun in the center. So think about that for a second. It's not totally obvious, but if you focus your eyes, you'll see that there's a red object there in the middle of the fourfold star. And this astronomer is calling that the sun. That's his explanation. The only problem with that explanation is the sun, of course, can never appear inside a star in today's sky. So that might be your first hint that that's not going to go very far. And again, they've overlooked the fact that that exact same image is going to be found all around the world. So here's another clearer example of the same sign from the American Southwest. This is from a prehistoric petroglyph here in North America, showing the same sign. Again, I would kind of direct your attention to the dark orb in the middle and what looks like a little ring around it. Now, if we go to ancient Babylon again, we see virtually the exact same image. The fourfold star, the circular orb in the middle, only this time it's set within a crescent. And those of you that are familiar with Dave's argument on the polar configuration, you have planets in a polar configuration set within a crescent. This is an example of the same sign from 4000 BC in prehistoric Egypt, the exact same image, just a little bit different coloration. Okay, this is an object called the quincross, and it's ubiquitous in Mesoamerica. You can find it everywhere. It's one of the top symbols. And you can see if you look carefully, it's just kind of cut off the points. So it's the exact same sign as we've been looking at with the so-called sun in the middle and the four-pointed star. Again, scholars recognize that in the Mayan language, this quincross always designates the turquoise color or green. Everyone accepts that. The Arapaho used to live up in Canada, went down to Mexico, or went down to Minnesota, and over to they currently are in Wyoming. But they, on virtually all their teepees, they would always have that fourfold star, and they would always call it the morning star, the exact same symbol. And so here's a scholar on that particular object. The morning star appears in the shape of a Maltese cross, a diamond, and a traditional cross. So again, we're going to find that all around the globe. The question is, why would anyone describe or represent the morning star with those shapes that aren't present in today's sky? A different scholar, also talking about the Arapaho, like the morning star, this cross-like form, it is painted green. And she's talking about the teepees now, that the morning star sign is traditionally painted green. Different scholar talking about the designs found in Arapaho weaving and dress forms. And he says, in all contexts, the cross refers to the morning star. The cross is associated with dawn, youth, and the beginnings of motion, and the convergence of roads. So think about that for a second as you look out into the sky tonight and look at the morning star. Would the idea of youth or the convergence of roads ever occur to anyone? And yet we're going to find that those are very widespread ideas and themes associated with the morning star. So back to the original Maya sign we were looking at. If these signs are looked at as actually representing a form in the sky rather than an abstract image, according to top scholars, you can readily see how you might see four roads in the fourfold star, especially on the form on the right, where you have a cross actually represented. Now we move to a familiar image from ancient Babylon. Again, the cylinder seal. You couldn't get a better illustration of four roads if you wanted. Again, it's set within the crescent, exactly like the fourfold star that we've been talking about. This is an image Dave and I have been talking about for 30 years. The image leaves little doubt there's something up there, something different than anything we see today. So actually in that groundbreaking book that we all have come to love and know, The Saturn Myth, here's what Dave said, 1980. For every dominant mythical theme, there are corresponding signs, though the truth is yet to be acknowledged by most authorities. That should probably read by all authorities. The signs of the four roads are the sun cross and the enclosed sun cross. Back to a different Mayan account of creation. This describes the original appearance of Quetzalcoatl in the sky, and as everybody knows, or most people accept, Quetzalcoatl was identified with the morning star. Basically, the story is he set himself on fire, not unlike the Greek Hercules on a great funeral pyre. And when the ashes were extinguished, then arose his heart, the Quetzal bird itself. They saw it, and so they knew that he had entered the sky. The old ones used to say that he was transformed into the dawn star, the morning star. The takeaway here is that the Quetzal star is the most beautiful star in all of Mesoamerica, and it's famous for its wildly green turquoise plumage. And it was so prized that it was prized more than gold by the ancient Mayans, the feathers especially. And the word for that bird came to be used instead of precious. So it was like the most precious substance they had, and they traded it amongst all the tribes. We turn to ancient Egypt, where we find the creation account in the pyramid texts. And here's what it says about the morning star there. O morning star, Horus of the netherworld, divine falcon. And then the next term, the W3D bird, whom the sky bore. The word W3D means to make green or to rejuvenate. And so the scholar Ronald Clark, in translating this passage, Faulkner in this particular reading, he left the word untranslated, but Clark translates it literally as the green bird whom the sky bore. So you have this exact correspondence between the oldest Maya account of creation, where Quetzalcoatl, the morning star, appears as this brilliant green bird. Now you go back to 2500 BC, and on the pyramid walls, you have a description of Horus as the morning star ascending to heaven as a brilliantly colored green star or green bird. Back to a different now, later Mayan account of creation. At this particular mountain, when it dawned, dawn is the Mayan word for creation, or the first time. When it dawned, they were kneeling, they were occupied, shouting when the great star came out. The great star, of course, is their term for the morning star. This, for those biblical experts out there, this kind of reminds us of the old passage from Job that reads, when the morning stars sang together and all the sons of God shouted for joy. And as biblical scholars have shown, those two lines from that biblical passage, those are in opposition. So it means they're describing the same thing. So the morning stars are the sons of God. The morning stars there are shouting for joy. Turning to an Egyptian account of creation now, one of my favorite accounts, totally overlooked. I've never seen it discussed by any other scholar. Describes again Horus the morning star, when thou risest in the horizon of heaven, a shout of joy to thee from the mouth of all peoples. Beautiful one, becoming young at thy time, in or as the disk within the hand of thy mother Hathor. Thou risest in the horizon of heaven, thou sheddest upon the two lands green light, turquoise light, the boy mighty. This is the translation from Budge's Egyptian Book of the Dead, sorry. And the takeaway words there are the word for becoming young, which is RNP, one of the most important recurring words in the Egyptian language for the time of creation. And the second word is the MFK3T word down there, and that is the word for turquoise. So the morning star Horus shines a brilliant turquoise, but he appears as a youth, the boy, HWN. As we see, that's one of the standard Egyptian terms for a youth. So here are the top two terms again. Basically what's being described is when Horus, as the morning star, is shining a brilliant green in the creation of skies, he's being described as being 1, super beautiful, 2, young, 3, rejuvenated. So the leading Egyptian word for be young, rejuvenated is RNP. The second word, HWN, describes Horus as a youth, but it also carries the connotation that he was rejuvenated. The third word is the Mayan word that in the first slide was translated the green morning star. So the word Raxa was translated by that scholar as the green morning star, but it also means the rejuvenated one. Again, a one-to-one correspondence between the most ancient traditions of Mesoamerica and the ancient traditions of Egypt. So let's take a closer look at that Egyptian word HWN. This is the sign in question that is the hieroglyph describing that word. And it shows a fourfold flower. So this is taken from a leading Egyptian dictionary. So at the bottom you see that their rendering of the definition of that word is flower from the phonetic value WN. And so far as I know, no Egyptologist has ever questioned the fact that this sign describes a flower. There's never at any point, so far as I know, a discussion that it actually describes a star. So we've got the same problem we had when we started in Mesoamerica. Is this a flower or is this a star originally? It's clearly described as both.
All right, I got you.
Direct your attention. This is some of the earliest rock art from ancient Ireland. And in the middle, see if I can do this without screwing the screen up.
Oh, yeah.
It's not wanting to let me pop up. But anyway, you can see that fourfold flower in the middle. Curiously, the old flower is set in what looks like a bunch of celestial objects on the face of that rock. So the assumption that we would draw is it's not a flower at all. It's a star that happens to look like a fourfold flower. Again, Dave and I have discussed these particular petroglyphs ad nauseum for 30 years. This just happens to be one of my favorite petroglyphic sites, not only because it's so old, but it's still well preserved. And so you can see the ladder to heaven there, and you can see the enclosed sun, you can see crescents, but you get this sprouting flower-like form. And most rock art experts will call those sunbursts, or they certainly will acknowledge that those are stellar forms. There's no question that these aren't a bunch of sunflowers that are being painted. This is a super old cylinder seal from Mesopotamia, basically showing a very similar fourfold flower. And interestingly, if you look at well, first off, you see the fourfold flower in the middle. There's 4 other flowers around it. But look at the one in the middle. You'll see that it has those 4 little dots around it again, kind of like the Mayan image that we started with. This is another very early Mesopotamian cylinder seal, probably about 3000 BC. Same image, basically. Now here's
5,000 years ago.
Virtually the same image, again set within that crescent, just like the fourfold flower, just like the fourfold star, just like the cross. This is more like 2000 BC. It's a little bit later, but you can see that it preserves the same sort of idea.
Yep.
It looks like a 4-petaled flower, but clearly it's a star. back to Egypt. This is a very early design of that sign we were talking about, the HWN or WN sign. And you'll see that it not only looks like a fourfold flower again, that's why the Egyptian experts say that it represents a flower, but look at those 4 dots. Again, these 4 dots just kind of appear everywhere. Not always, because they didn't always remember to include it, but it appears all around the globe, enough that you can bet your life that those 4 dots were originally present. And so many, as I look out over the crowd earlier, I saw that so many of you are wearing the plasma discharge shirt from the EU conference. And if you will remember the little squatter man image on the back of the shirt made famous by Tony Peratt, it always has those 2 little circles, or often I should say, kind of like this image. It doesn't always include the 2 dots, but it includes it enough that you know that it was originally there. So those 2 dots are structurally analogous to these 4 dots. They're probably describing a diachroton instability in this plasma discharge. And it's just a crying shame Tony's not here to tell us the exact physics behind this. But I can tell you that when I think we met with him in roughly 2000, 2001, Dave and I had a week-long meeting here in Phoenix with Tony, where we tried to write up his initial article that was just an absolute groundbreaking article on the presence of plasma discharge phenomena in ancient rock art. And as you know, or many of you know, Tony traveled all around the world with my buddy Rens van der Sloot, taking pictures of all these petroglyphs. And he published this absolute masterpiece of an article in a very obscure place, roughly 30 pages with hundreds and hundreds of images, showing beyond any shadow of a doubt that some of these ancient rock art images actually represent plasma discharge phenomena in the sky. And so when I was discussing in Phoenix here with Tony, about 30 years ago, I had written an article on this quincunx structure, which we're going to get to in a second, but it's essentially this structure. It's a 4-fold structure with these 4 dots. And Tony said, that's one of the most common signs that I get in my laboratory, which complete shock to me. I'd never heard something like that before. But he also said this would be fully expected if you had planets in a conjunction like Dave and I have hypothesized about. So just to keep in your mind or your mind's eye, that we've moved now from the Egyptian image back to the Mayan image, just to keep it so that we see that it's not only a 4-fold star, but a cross-like form with the 4 dots. Back to the Egyptian form. But the thing to take away is that in the Egyptian hieroglyphic script, that 4-fold flower is often substituted by just a plain cross. So clearly the Egyptians recognized that this 4-fold flower like form was also a cross. Back to the Mayan civilization. One of my favorite scholars just wrote an entire article on this subject, but she said the quatrefoil, a 4-lobed flower-shaped symbol, is ubiquitous in Mesoamerican iconography and traces its roots back to the pre-classic period, roughly 1000 BC. So this is the earliest image of that I know of. This is from the Olmec times again, kind of like that colossal head image we were talking about earlier, but it's the one in the middle, and it, it's set a little bit askew, so you have to kind of turn your head to see the exact same 4-fold star that we've been talking about. And lo and behold, that particular image is the leading image in the Mayan language for the word sun. And it's, the word in question is kin, or a variation upon that word in the different Mayan languages. So, all the top Mayan scholars will readily admit that the Mayans represented the sun as a flower-like form. Here I would call your attention to the fact, though, that flower-like form is set right in the middle of a cross-like structure, or the 4 directions we were talking about earlier. We were asking, how is it possible that the morning star could possibly be associated with 4 directions? It's pretty obvious from this image why that might be the case. So in one of the sacred books of the Maya that was luckily preserved, one of the few books, here's what it reads. 4-fold was the plate of the flower, and the sun god was set in the center. If you didn't know better, they're describing that same symbol that we showed earlier from Southwest America, where the astronomer said the sun is set in the middle of the fourfold star. Incongruously, I might add. So here's the standard Mayan glyph for flower, and you can see the resemblance to the previous example where they employed the glyph for flower to write the word for sun. But you can see that this is a quincunx structure again, where you have something in the middle and then 4 objects emanating outwards. Again, top scholar in the world as far as I'm concerned. For the Aztecs, the quincunx represented turquoise. In surveying the various surviving elements of indigenous thought in Mesoamerica, the quincunx stands out as one of the most important aspects of the Mayan mindset. It's everywhere. It's at the center of all their thinking, all their religious rituals. Throughout the development of Mesoamerican civilization, the pervasive tendency to dramatize creation by constructing on Earth a reduced version of the cosmos, or a copycat version, usually in the form of their state capital, gave Mayan cities the sacred form of the quincunx. So it always has something in the middle, 4 roads emanating out from the center. This is a book that's just came out in the last 6 months. It's a fantastic book. It's called Maya Sacred Geography. And
time out. Pause for request.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info.
You betcha.
A radical tenet of the electric universe theory, as proposed by the chief principles of the Thunderbolts Project, is that conditions in the inner solar system and planet Earth were vastly different within human memory. Ancient man lived in awe, reverence, and sometimes terror of the planetary gods. If planets and moons, including Earth, move on different courses today than in the relatively recent past, one thing is certain. The gravitational force on Earth has not remained constant since the Earth's formation, supposedly 4.5 billion years ago. If Earth's gravity has not remained fixed over countless eons of time, a clear test of this hypothesis could come in the comparison of life forms in our world today versus those of prehistoric eras. Scientists tell us that for about 165 million years on planet Earth, fantastic and often giant creatures called dinosaurs ruled our world. Of course, the largest of the dinosaurs dwarf any animal that walks the Earth today. Yet consensus scientific theory tells us that Earth's gravity was not weaker during the Mesozoic era. In today's episode, we ask author Ted Holden to explore the controversial question: do dinosaurs pose a gravity problem?
Engineers in the late 19th century had understood well enough that they had a big problem with understanding how a sauropod dinosaur could walk on land, right? I mean, they never managed to put numbers on it. I'm the first person that managed to put real numbers on that. But they knew there was a problem. They were assuming that the sauropod dinosaurs must have lived in water, right? But more recently, it's turned out they had no adaptation whatsoever for living in water. They would have needed snowshoe feet. The feet they actually had would just sink right into the muddy river bottoms, right? I mean, they'd be immobilized almost immediately. The idea of a large dinosaur using his neck as a snorkel wouldn't work. That they finally figured that out. They've got tracks showing dinosaurs, walking easily enough on land, right? I mean, in fact, they have more in the way of footprints than they do of bones in the case of large dinosaurs. They have some, and they keep finding bigger ones. They keep finding bigger bones. They keep finding bigger footprints. So they've got footprints which indicate a creature which would be 200 feet long, which you would call breviparapus. And there's a couple of other things like that. That's the one word that I can remember easily. You've got titanosaurs. Now it's like, they used to think that a brontosaur was a really big dinosaur when I was a child, right? I mean, they had a brontosaur skeleton in the Smithsonian Museum, but they keep finding bigger ones. The ultrasaur is not even the largest of the titanosaurs, but Christopher McGowan, the curator of paleontology at the Royal Museum in Ontario, has a book out about dinosaurs, and just from purely volumetric calculations that calculated a weight of 180 tons to the ultrasar. The question becomes like, what is it that's allowing these kinds of creatures in our world? The first thing that occurred to me was that, we don't really know very much about dinosaurs, how exactly they live as far as muscle or anything like that, but we know quite a lot at this point about the weightlifting sports, right? And they hadn't made any sort of a science out of the weightlifting sports, in late 1800s, early 1900s, whereas they have now, right? We know what the limits of size for a human athlete would be, right? So, any kind of a size limit you could compute for the human athlete is also going to serve as an upper bound for any sort of a herbivore the same size. The only other kind of argument you could try to make would be that the dinosaur must have had better muscle than we have. But that doesn't work either. Muscle tissue is all pretty much the same under a microscope. For vertebrate animals, mice, dogs, cats, humans, elephants, it's all pretty much the same. How strong something is just a question of how much muscle mass
you and I can
do
have
you
a
have
little
and
chat.
how well
I
is
bet
it
the numbers
trained.
would go up because people
So
love
at that
drama.
point, you could start to ask yourself, how do you compute like a size
Thought I
limit for
verbally
the
abused
strongest
you
people
live
we
on
have
air
in the
for a
world?
little
And you
while
get into
there.
the scaling
Border
systems
out
they
of
use
chaos.
for Olympic or powerlifting events, which says that you scale by a general average of cross-section, which is this 2/3 power body weight. Where does that come from, and why would you want to do that? You're talking about square cube phenomena at that point. And we've all seen this, okay? It's like, there's always the littlest kid in your classroom who could do the most pull-ups or any kind of a ratio exercise, where strength is proportional to cross-section of bones and muscles, and weight is proportional to volume, which is the cubed figure.
Poor guy.
We know that strength basically varies according to cross-section of bones and muscles. If you know a person's weight and you want a general average of body cross-section, then weight is going to be it's proportional to volume. It's some number times volume. You might have a weightlifting event, say the bench press, for instance, and you've got 6 or 7 or 8 different weight divisions. You'd like to know who had really done the best lift overall. What you do is you divide through by 2/3 power of the athlete's weight in each case. And the numbers all line up. They almost become the same number. One will stand out just a little bit, right? And that's going to be the guy that did the best lift. Whereas if you say, okay, now we're going to go from the realm of real things into thought experiments, and we're going to conduct a thought experiment of scaling the same athlete to different sizes, well, that sort of isometric scaling becomes perfect, right? Because you're talking about the same guy, just making them different sizes. You would like to know at what size does the square cube thing make one of these top human powerlifters dysfunctional. What you do is you say, okay, we're just going to exactly use this 2/3 power weight scaling factor. On the left side of the equation, I'm going to say, okay, Bill Kazmaier plus the bar is like 350 pounds plus the 1,000 for the bar, right? 1,350 divided by the 2/3 power of 350 equals, on the right side of the equation, just the guy lifting himself up off the floor, right? Just X divided by the 2/3 power of X and solve, right? You get a number like somewhere between 18,000 and about 21,000 pounds, right? That's the theoretical maximum size limit for the world for one of the strongest athletes that we know anything about. That's the theoretical limit. And the thing that's funny is the biggest elephants that we know anything about are typically 14, 15, 16,000 pounds. Now, I don't think anybody claims to have any kind of a stuffed elephant any bigger than the one that you see at the Smithsonian. And those people told me that elephant was 8 tons, right? It was 16,000 pounds. Kind of interesting that you've got this theoretical number, which I've produced, and it matches up very nicely with the real world number. You would expect the real world limit to be a bit lower than the theoretical absolute maximum, because you're never going to get an elephant that's all muscle. So this is the first little thing that we deduced. It says that there's a theoretical size limit of about 20,000 pounds in our present world. And then you get into another question, which is that other calculation that you see in that paper. Like how much attenuation would you need for something like an ultrasar to walk around? Well, the observation you make is that walking around cannot have been any more of an effort for the ultrasar in his world than it is for that elephant in the Smithsonian and his. You see what I'm saying? So if you just equate the two levels of effort, weight divided by 2/3 power mass, we know that the ultrasar would weigh about 180 tons in our world, and the elephant weighs about 8. The ratio of about 22.5 to 1. You can just
so that's how you figure out what the gravity was or it needed to be.
Substitute one of those ideas into the other, and it's like the constant of proportionality falls out, right? You get a ratio of about 2.8 to 1. That says you would need to have at the very least, a 2.8 to 1 reduction in gravity for the ultrastar to stand up as easily as an absolute maximum lift effort by one of these top human lifters. That's the basic idea as far as strength goes, but there's more to it than that. You've got other kinds of things you're trying to account for. Every kind of a measure of efficiency, aside from just strength, varies with some kind of a squared figure, right? It's like a bird's ability to fly. It depends on surface area of wings, which is a squared figure. Your ability to breathe is proportional to surface area of lungs, which is another squared figure. Even your ability to digest food is proportional to surface area of your digestive system, which is why some authors have noted that they don't see how anything could possibly become bigger than an elephant in today's world, simply because the elephant has to spend the whole day eating to support his size. You've got a question of birds, which says that the largest birds which can fly in our world are 30, 35 pounds, something like that. That's the biggest thing that flies in our world right now. When you get to 10, 20, 30,000 years ago, they had like an Argentinian teratorn, which was basically a golden eagle with a 25-foot wingspan, a couple hundred pounds, that flew. And then you've got these flying creatures, which are like the Texas pterosaurs, the Big Bend pterosaurs. And those things could have gone like 500 to 1,000 pounds. And they flew right. Now, when Juan Langston first started working with Texas pterosaur bones, he didn't really have much in the way of wing bones. The bones he did have indicated a wingspan of 60 feet. But more recently, they've actually found more in the way of wing bones for those things, both in Israel and in Mexico. And what they've actually found indicate, wingspan of 60 feet. You've got like huge, huge things flying in ancient times that couldn't begin to fly in our present world. The oldest version of this paper of mine spoke about the pteranodon and the fact that scholars who had studied what was involved in flying had examined the pteranodon and decided that the size limit of a pteranodon had to be the biggest thing that ever possibly flew. So any bigger than that, even just gliding, even trying to hold his wings straight and a turn would snap his wing bones. One other kind of a thing which you would want to try to account for, which is the question of sauropod dinosaurs and their necks, right? And I believe that that's the biggest problem of all. You've got two basic kinds of large dinosaurs. You've got what they call brachiosaurids, and then which held their necks upwards according to the bones. And then you've got the diplodocids, right, which apparently held their necks outwards. Now, the largest thing that we have bones for, as far as length goes, which the size we saw was a diplodocid. The question is, if you've got a neck which is 50 feet long and weighs 40,000 pounds or something like that, how are you going to hold that neck? If you hold it upwards, then you've got an extreme problem getting blood to your brain, right? And it's like a giraffe's vascular system and blood pressure would blow our vascular system apart. They have a very, very tight skin, which acts like a flight suit, for a jet fighter pilot. Just getting blood up as high as you need to get it for giraffe is a big problem, right? If you had to get blood up, like 40 feet above your shoulders, you would have a creature which was constantly walking around in constant danger of some sort of a major circulatory system disaster, right? That's no way to dominate the Earth for tens of millions of years.
So the gravity must have been lighter.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
She just states bluntly that a key to the imagery, that 4 roads radiated out to the 4 directions. Back to the Maya slide.
Sorry, we're going to jump straight ahead to another video. Sapphire Project update.
Wow, does a year pass by quickly? We last time I stood up here, we were showing you pre-models, computer-aided design models of Sapphire, where we thought we were going to go, and tonight I'm going to show you where we've come and how we got there. So I'm not sure how fast I'll go through the presentation. I think I have 600 slides? No.
Not that many, but there's lots of colorful ones. We're going to get into some of the hardcore engineering that goes into designing a machine of this nature, and some of the questions that the team had to address for us to get where we are. So Sapphire, stellar atmospheric function in regulation experiment. It's a test of the electric sun model. And this model, let me see here, are we going? Okay. This is the overview. Here we go. The electric sun model. I was asked back in 2011, I'm just going to give you a really quick overview for some of you that are new, by the EU and by individuals to examine this model. And what I did is I compared it to the contemporary model. And I discovered that there's a lot of disparities with the contemporary model, and came to the conclusion that, at least at this time here, it's not testable. But during this, I used a statistical evaluation tool called designs of experiments, which you can apply to filter through hypotheses or different models to determine whether they can be tested or not. So that's really the first couple of years. And I came to the conclusion that I think that the electric universe model is based on the principle of charged plasma affecting matter of a different electrical potential. And I came to that conclusion finally after Scott Mainwaring had given me a book written by Crooks, where he had a cathode at one end of a small jar and an anode at the other end, and had rubies in the center. And when he lit it up, the rubies started to fluoresce and radiate, is what he called it, what we call plasma discharge. But the rubies themselves were not part of the circuit, they were just in the plasma. What it indicates is that there's certain elements that we know now do not want to climb or fall to the electrical potential of its environment. And when that happens, that's when you end up with a plasma discharge. And it was based on that that I came to the conclusion that we may be able to test this. So phase one was a proof of concept, and it was really just to see if we could shake it out and see if it worked. Can we go in and we can recreate these things, and can we introduce some instrumentation to do some measurements? Because the data and instrumentation to measure what's going on in plasmas is extremely weak. There's not much information about it, and we're going to get into that. And we did test it, and we discovered that it would work. We adjust pressure, voltage,
So I'm going to introduce a little more helium right now.
current,
A little bit more.
and time.
And then we'll take another second.
Time is also a key element.
If you want to shut it
When the
off,
proper combination of these factors is arrived at, the plasma spontaneously ignites.
Oh, here we go. 0.4. It's going down. Shut it off.
A blow discharge forms in the chamber.
So we just leave it here. It'll start climbing by itself. Look at the emissions coming off. Look how bright it becomes.
We adjust the various parameters to obtain a variety of plasma regimes.
Look at the surface. See close?
What we are observing has no clear precedent. We are seeing things we did not expect.
Look at the pressure changes. Nice. Look at the spin. Look at the spin. Yeah, look at the spin.
And that was just the initial. Afterwards, we were able to control the plasma, and these are some of the plasma phenomena that we observed and we were starting to measure. And these double layers, we ended up finding that we had 2, 3, 4, 20. These aren't disks, these are spherical discharges. Plasma has a unique characteristic where it's translucent as you look through the center of it, and it looks like it's a disk, but in fact it's not. What you're looking at actually are spheres. And then we end up looking at things that had certain types of perturbations, but what we thought and looked at the geometry here was quite remarkable with the hexagonal type formation, and this is all moving. This is not static.
Spheres inside of spheres inside of spheres. That's what you're looking at.
As some of you know, we saw a dark or an extremely intense ion cloud build up around the core, and this is very common for what we see happen in Sapphire. And when it did, it would blow off into the chamber, and when that happened, it would often release power surges of over 10 million watts. Now, what we did is we limited the power to 1,800 watts. And we don't understand this. These are things that we are going to now investigate in phase 2. And this is what you're going to be introduced to tonight.
I bet you think you're seeing the sun
kind of
right
a
there.
panoramic shot of the lab. What you're looking at in the center there is the chamber, which can, it's about 3 cubic meters.
Literally.
It's about 7 feet long, and it's about 4 feet in diameter.
Not this.
And we're going to go and explore the engineering that went behind this.
Stupid.
But what's behind this? This is SAFCON. Everybody in the team, we had to come up with a name. We said, well, let's call it control room, and nobody liked that. So we said, okay, well, let's really, they came up with the name SAFCON. So this is SAFCON. And this is kind of, again, a panoramic view here. It's not complete in this picture of where the main control for gas, vacuum, data acquisition, and in real time, we get to monitor what's going on with all the systems in the chamber.
It's not a Kirby vacuum.
Now, there are two things that we're going to talk about tonight. One of them is systems, which is the chamber itself to maintain its stability, so that it's a stable experimental environment. And the other is the data that we get back from the instruments like the Langmuir probe, optical spectroscopy, mass spectroscopy, and other things. So you're not looking at the sun. This is the result of the first discharge from Sapphire Phase 2. And this is what happened. And so we believe now that it is scalable. Well, we know it's scalable. So
for all of you out there who haven't seen this before, that's the first ever working theoretical model of the sun.
Sapphire environment.
And it's not a nuclear fusion ball of burning fuel in the inside. It's electrically, externally fueled.
We know that the plasma itself is extremely intense. We know that it's extremely hot. And one of the things that happen in a plasma discharge, one of the characteristics of a plasma is what we call radiation emissions. And radiation emissions is the thing that you feel when you walk outside and you feel the hot Phoenix sun after you've been in the shade. And those emissions in Sapphire, they travel at the speed of light and they impinge on the surface of the chamber. Now, I didn't think that this would be a big deal when we first started out because it's such a big chamber. It weighs almost 2,000 pounds. It's stainless steel. And I found out that that actually was not the case. This is just a small graph to show you the different types of radiation, complete spectrum. You go right from what they call non-thermal, thermal, optical, broken bands, gamma rays, X-ray, and ultraviolet. The stuff that we feel predominantly are within kind of the infrared to ultraviolet range when we walk out in the sun. But Sapphire is going to experience many of these because it's an ionizing plasma. And this is what happens to the chamber. So when this radiation hits the surface of the chamber, some of it's reflected back, but in our case, because we have a certain type of finish, a lot of this energy is absorbed into that material. And there's transmitted radiation that comes off the outside. So if you think about your engine, it's got gas burning on the inside, and you feel the heat migrating through the engine. It gets extremely hot. And so you have this thermal conductance within the material itself. In engineering, we had to take a look at what we call potential failure modes. The melting of O-rings, is it going to get too hot? Thermal stresses on viewports, thermal expansion of materials causing stress, thermal effect on cameras, electrical discharge, erosion of materials, deposition of materials. When you have a plasma, an ionizing plasma, we watch things get vaporized. And when we say vaporized, these are like happening in seconds. So you can have something that's metal and it it's no longer there. So you got to be careful about how much energy is in this chamber, and you got to have good control over it. So potential failure modes. What temperatures are we dealing with? How long will it take to reach these temperatures? How do we limit thermal heating in the chamber? What are the thermal limitations of the gaskets? How do we limit the thermal heating of the viewports? What are the effects of thermal expansion? Potential failure modes. And it goes on. And the list becomes endless because once you have this radiation in here, it's like putting a very hot, let's say, tungsten light bulb inside a shoebox. And that heat and that energy's got nowhere to go, and it'll cause a fire. Molecular solubility. We're using hydrogen. Well, what about the polymer hoses that we're using? Well, they're designed to handle the hydrogen. Well, what happens if the polymer hose starts to heat up? Well, it opens up the molecular structure of the polymer hose. The hydrogen starts to migrate through, and maybe you get hydrogen embrittlement, and then you break a hose. Doesn't sound like a big deal, but if you've got pressurized hydrogen moving into the chamber, you've got a very hot anode, it might cause some consternation amongst the team. Lowell said, I said, can we expect an explosion? And he said, well, if we do, it won't be very big. Now, you have to understand with Lowell what his background is, because he used to work at Los Alamos and Lawrence Livermore Labs and nuclear weapons. So I asked him, I said, are we talking about 1 megaton?
I didn't notice before.
Or 70 megatons, we're just gonna become like cosmic dust. So we have what we call a system. It's called open issues and project tracking. And that means that every single person on the team has a responsibility to, if you think it's a problem unless we know that it isn't. It's broken unless we know that it's fixed. It's not going to work unless we know that it does. It's kind of you might consider a negative approach. But in the automotive industry, we would do the same thing with the braking system on your car. As an engineer, we would say, would you be happy if your brakes worked most of the time? Or because I got accused of being a perfectionist one time, and that's the way I answered them back. And I said, well, if I'm designing a braking system, do you want them to work most of the time, 90% of the time, 99% of the time? And what I discovered is that people want the brakes to work even if the pads are gone. So we look at where a system is going to fail. And if we can eliminate the failure modes, then we have a reasonable confidence that it's going to work. So there are thousands of issues, and each person on the team is assigned their champion. We identify what the task or the issue is. The team discusses amongst ourselves. We come up with a recommendation. The person can pursue it, and then come back maybe a day or two later, a week or a month, and say, okay, this is what I found, and maybe they are stuck on it. But the approach is that if any member on the team has an issue, the whole team has an issue. Because if they're stuck, we're all stuck. So we track through every single issue that we can think of. And that brings us to computational fluid dynamics. And it's a big word, and it's science and engineering that is used from designs of kettles to rockets, fighter aircraft, and it covers a wide range of things in thermodynamics. And it includes radiation emissions, that's light emissions. It means fluids as well as gases. So gases fall under the same kinds of laws and principles in our calculations as what liquids do. So CFD is it's a software solid modeler. It uses proven applied mathematical
you see
equations,
all garbage. You
algorithms
never
to
see
evaluate the
anybody
effects of
screaming,
various interacting and
real
non-interacting
shit like
factors
this. It
affecting
actually
fluids, gases, and materials. So think
things
about when they design the radiator of your car.
usually
They
it's
know
like,
that as the radiator heats up, it's
bunch
going
of
to
mystery
expand.
type shit,
And if you didn't let it expand, it's going to break.
We still don't know.
So you want to understand the materials and the effects of the
you decide.
heat on these kinds of materials.
You know?
The same thing happens in sapphire.
Like, nah.
And you can do all these calculations at once with some of the most advanced solid modelers. So as I said before, at the beginning, I didn't think that thermal radiation was going to be too much of an effect because the thing weighs about 2,000 pounds. It's a lot of steel there. And I thought, okay, we can fire it up, and it's not going to be like a small bell jar. We can run it for maybe, a number of hours. But what I discovered in my initial calculations is that even at 30 kilowatts, because you need more power, it's a bigger chamber, we would get maybe half an hour out of the chamber before things started to melt. And if we allow the chamber and the energy to go beyond that, maybe up to 80 kilowatts, or even 165 kilowatts, which it has the capability of doing because it's a big chamber, we might get half an hour before it heats up to 500 degrees Celsius. And when you see something that's red hot, that would be in the range of around 500-600 degrees Celsius. And that's where things start to melt. And that's a big problem. You can't run an experiment. So what you're looking at here is calculations called total heat flux. And you're going to kind of get a basic 101 engineering thing on this. And what I discovered something that you might find very useful on the heating of the cores of planets and moons. But this here is showing you the anode in the center of the chamber, and as time goes on, how radiation emissions impinge on the surfaces of the materials and the chamber itself.
Keep your ears peeled for my chickens when I open the door.
Now the core plasma, remember, the core plasma we figure is around 3,000 degrees, but the radiation is leaving at the speed of light, and it's traveling through the atmosphere in the chamber because it's in a vacuum even faster than it travels through our atmosphere on Earth. So there's nothing to slow it down. There's nothing to stop it. So the static results, that was Dr. Lowell Morgan's calculations. So he came up and he said, well, it looks like it's going to heat up to about 521 degrees Celsius. And I was coming up with numbers of around 535 degrees Celsius. Then I contacted some friends that were doing some work with NASA and some aerospace down in Carolinas, and they were saying maybe 550 degrees Celsius. So we have a problem. So what this is some of the calculations. This is just really a return graph. I'm going to show you some other more graphical representations of the results that the calculations came up with. But it meant we have a big problem. And it meant that I'd have to make a telephone call to Scott and said if we ran the chamber, we could run it for about 10 minutes before you see kind of a melting thing on the floor. And that's the end of sapphire. What this is here, you have static results, which means this is going to be the maximum temperature the chamber will come to and it'll stabilize. The next, as you see right here, it's kind of migrating along. You see the graph drops down, it comes back up. That's giving us the time domain and how long it will take the chamber to heat. And we came up with approximately the same number, about 30 minutes. So then I thought, okay, well, I don't want to call Scott yet and say, it's over. So I thought, well, maybe we can cool it. So we'll wrap some water around it, okay, some hoses or whatever we need to do so we can cool the chamber. But as you can see here, the analysis is showing us that, well, where the hoses are, it's nice and cool, but right where the center of the chamber is, which is where the most of the heat is, it's going to be too complicated for us to get anything effective in there. And what you're looking at from the green to the red is what we call a thermal gradient. And it's too steep. Just don't do that to materials without causing a lot of stress and problems. So I'm thinking, well, how do we cool engines? What if we blew some air on it? So I started to do some analysis, and I thought, well, what if we put a fan on it and we suck the air down through a shroud along the surface? We got some sort of laminar flow, and laminar flow falls under computational fluid dynamics. And this is the kind of math that they use to do wing design on aircraft. You know, how much laminar flow, how well will the air actually stick to the surface to lift the aircraft up, and air is a very effective way to get rid of heat. You use it in your radiators in your car. So it looked promising. And I thought, okay, what we could also work out here is the flow of air over the surfaces. So we can effectively predict how the winds or the air is going to flow over these surfaces to be more effective in cooling it, more effective, more efficient. And this is some of the thermal distribution, and it's a lot more even. So we're not getting 500 degrees. Now, if I can get a fan to pull air over the surface, we can bring the chamber into stability at around 100 degrees Celsius. Now, that's something that we can work with. It's still going to boil water, but the worst case scenario is about 100 degrees Celsius. It's not going to melt gaskets. Yes, you could fry eggs on it, but it's workable. So then I thought, well, I need a fan. And that big blue thing is the fan that we came up with. I told Scott that, yes, we have a solution, but what I didn't tell him at the time is just how big a fan we needed. And so he thought, okay, this is good, so we're going to keep moving ahead. And the fan actually will suck about 14,000 cubic feet per minute at a pressure of about 2 inches of not 2 atmosphere, but 2 inches of water, which basically would suck the air to this room, all the air out of this room here, I would say approximately 30 seconds. So keep your hands and feet in at all times. You know, I mean, that's me standing there. I don't know what I'm doing. I'm looking at something, I guess. So then we looked at the outside and that looked good. So let's take a look at the inside, because that's where the real nasty environment is. And what we can model now very accurately is what these conditions are. And the conditions is showing you with the little arrows, it's showing you, those arrows are showing you the effects of buoyancy. So as hot air heats, it rises. And so effectively those arrows are showing you that it's going to rise, and it's giving you velocity. Well, how fast is the gas rising? And so this is gas. This is not radiation emissions. The radiation emissions are passing through the gas at the speed of light, but then there's the gas in the chamber, and how fast is it moving? Okay, do we have any kind of convection motion happening in here? And it's actually quite stable if you look at it. The velocity is actually not that high. Is this moving? Yes. So what we're looking at here, I took a cross section and we're just kind of moving down through the chamber to the core, which is where the anode is. And it looks like a heck of a fire that's in there, and it is. Wow. But the velocity is very, very low. We're talking 0.0005 meters per second. So it means the gas is not moving very quickly, which is good for us, because it means that, you know, gravity is going to have a limited effect on the plasma discharge, if that makes any sense. Okay, the gas is very stable inside.
Our gravity.
And this is just actually looking down into the core. So this here is the effect of what's called total heat flux. It's how you can heat up a body using electricity. So I'm just going to digress here from Sapphire just to talk about a possibility that the EU might want to consider, because in the course of doing this analysis, it occurred to me that we use this tool all the time. And it means that the center of the anode might be around, let's say, 2,500 degrees Celsius. But the surface temperature of the anode was almost 1 order of magnitude cooler. And I thought, no, what is going on? Like, you know, you're going to heat it up, it should be just kind of a uniform heat. But in the analysis, what it showed is that the radiation emissions leaving the surface of the anode are leaving it at the speed of light. But it takes a lot more time for the heat to migrate from the core through that very dense material that we call the anode. So if you think about it, you don't need gravity to heat the core of a planet or a moon. And this is a very effective mechanism to do this. And it does answer for why you can have hot cores in planets or moons that really, by now, in my opinion, if they're as old as they say they are.
I mean, these are definitive answers now that are, you know, and have been reproduced in the laboratory. I can't believe it's not seeing its way to the textbooks yet.
Should be frozen rocks, and they're not. And even with bodies,
because the shit that they have no evidence for is in textbooks. Well, they have evidence for this. It's time to rewrite the textbooks. I mean, that's a lot of rewriting the textbooks. I mean, to be honest, huh? I mean, because that's back, you know, starting from scratch. Big Bang, scratch it out. Relativity, scratch it out. Stop looking for dark energy and dark matter. We don't need to find it. We already have the answer for why these things happen. Oh my goodness.
Even smaller than our own moon might have hot cores.
That's when people get into conspiracy theories right there, because they're like, why? Why the fuck would this obvious information with simple instruments that can be demonstrated in laboratories and prove that the standard model of what we're told about our solar system and universe is incorrect? Why are we being told the other shit? full speed too. I mean, hardcore.
Connectivity. Just a consideration for the EU, but it's something that appears to me that might have some legs. So it's just another kind of a three-dimensional view of the core. It's fun doing this work because it's really pretty. This is stuff you can put on t-shirts, you know. So this again, what we're looking at is the radiation and the effects of the radiation on components like the cathodes, because we have large cathodes, and you'll see them tonight. They're 3 feet in diameter. They're very thick copper. And what we have to identify now is whether or not they're going to melt or they're going to expand, and what kind of changes can we see occur in the chamber without it going into a failure mode. And this is really what it's showing you. The green means that it's cool. The red means it's hot. And the little arrows show you the direction that the air is moving or the gas is moving in the chamber. This here is the results. So the maximum temperature that we got from the radiation is about 600 degrees Celsius for the copper, and that's well within copper's ability to handle. It's going to get hot, but it's not going to melt. But when things heat up, they expand. And if you're holding something too rigid and it's wanting to expand, well, that's when you start to break things. So we can take the information that we've got and the results that we got from the computational fluid dynamics and read that directly into what's called finite element analysis. And that really deals with the structure, the strength of materials that's used in building buildings and cars and virtually every kind of thing that you can think of that undergoes any kind of stress. So if you take your hand on your desk tonight and you just put your fingers on the edge and you push your hand down, you're going to get what's called displacement. If you feel your muscle stretching, this is what we would call stress. So things can displace like the aircraft, like the wings on an aircraft, but the stresses are within its limits so they don't break off. And this is basically what FEA does. And you can apply thermal forces. And what this is showing us is the effects of the radiation emissions on the sapphire viewports. Okay, now if I was paying for this, these are sapphire viewports. Now if anyone knows anything about vacuum chambers, these really are not cheap viewports, okay? And you don't want to be blowing them out of your chamber because you're subjecting them to extremely high stresses. And what this is saying in effect, as long as we've got air moving over top of the surface, we can keep it cooled down to a point where we can effectively use them without blowing the viewports out of the chamber. But what about the cathode? Well, you come up with some ideas. You want a nice flat disk. The team, we all agreed that a nice flat disk would be the most effective way to do this. But you got to hold that disk up somehow. And this was the first concept. And this here, what you're looking at is kind of a pie-shaped section out of that round.
Just talking about how they built it. I'm going to jump ahead too.
So we designed an isolation chamber where we can pull the anode back, close the gate valve, save the chamber, and
take a look at real world
is the inside of sapphire.
There it is.
We have the cathodes, the anode, instrumentation ports, and we're going to be looking at some other things. And just take you for a tour. So systems. We're going to allow us to introduce nitrogen into the exhaust so that it's not dangerous. You see? So part of that is part of the mass spectrometer is measuring what the hydrogen content is in the.
And we're going to jump ahead to the last demonstration.
Hey, Joe. You got a light, Joe, man. Oh, look at it go. Nice. Nice. Hey, flip, come in, ourselves. You got that? And the other cathode maybe as well. Wow. Well, you know what is happening here? Take the voltage down.
Yes. Yeah, the right frequency.
Okay, so that was the first day. And what I had forgot was a little thing that Don Scott and a couple of us had talked about. Instead of limiting the current on the first discharge, I was limiting the voltage. So I was thinking, okay, well, we just want to get enough voltage to get it ignited, but I should have actually limited the current. Now, what's missing out of this film here, well, actually, what I should say is what you actually saw at the very end was what we call a plasma flow discharge. And it resembles something like the Death Star out of Star Wars. Okay. And what it does is an extremely intense ion discharge to wherever it's going and it's focused. Well, what you don't know, what you didn't hear, was actually the power supply was maxing out at 200 kilowatts and the amount of energy was impinging on a I thought the chamber at the time, but it was a screw this big. And what happened was you didn't see it in the video, but I started to see all this stuff flying off, okay? And it was actually vaporizing the screw, okay? I thought it was drilling a hole in the side of the chamber. So Ben was kind enough to remove some of the colloquialisms I was using prior to him saying shut it off, because there was about 30 seconds in there that Joe, because we didn't actually have, you know, the main control actually hooked up inside SAFCON at the time. It was Joe sitting out and standing out by the power supply listening us to yell and please turn it up or down. And we're all screaming inside because we're freaking out, because we thought we're just going to smoke a new hole in Sapphire. We haven't even got it started yet. So, so day 2, we learned a few things. We're going to see if we can control the current this time and not let it eat as much power as it would like. And so what you're going to see next is day 2.
Yeah, 600. 600? Okay. You guys are at 100, eh? Bring it up. Chamber pressure? Put it on. Should go any second now.
I'm a little nervous now. Let's see.
How many amps? Spray down about 3 if you would. It's almost there. Yeah, I discharged the stamp, but it's fine.
So we have these anodes we can throw out.
Bing.
And that was day 2.
If you look at the bottom, there's the sunspots.
So we thought that was pretty cool too. We thought, okay, we've got some good news, and now we can go to the conference. And then, and tell everyone it actually works, which is great.
Incredible.
And so, capabilities. Should we stop the talk now? Should we talk about capabilities? I'm going to fly through these quickly because I'm getting that, okay, I've been up here long enough, and I might be boring you guys. Are y'all good? Okay, okay. Well, because now that we've got Sapphire fired up, the real work, hard work, science work, elucidating cause and effect starts. That's when the design of experiment starts, and we can start to ask some of the questions that we have been longing to get some answers to for a very long time. So the capabilities, so it has the ability to form a variety of spherical plasma discharges. And what I will say now, I can't get into some of the details, but we do have full control over all aspects of the plasma discharge, according to Paschen's law. If you look into that, we can control everything now as a variable for us. It's never been done before, ever. It can move instruments freely through the plasma atmosphere. It can do synchronous and simultaneous measurements. And we're down to picoseconds, by the way. So we can synchronize all the measurements that we're taking into picoseconds. That should be really important for us, because as we move forward, there's certain events that happen very quickly, and we can capture those events. And we can synchronize all the rest of the instruments and do graphical overlay, and we can see the history or what was occurring in the chamber before it actually led up to that event. This is very important for us to do the kind of diagnostics that we need to. High resolution video, materials testing, material deposition, erosion test, linear probe analysis, optical spectroscopy, mass spectroscopy, near ultraviolet light measurements, infrared measurements, polarimetry, design of experiments methodology, and questions that we have. Why do ions and electrons not recombine in a double layer? Why does ionized hydrogen not go back to a stable hydrogen atom when it's in a double layer? What is the mechanism? What's the process? Why is it staying like this? Why are double layers in sapphire quasi-stable? So why do we form these spheres and they're quite stable? We don't know. We don't know why they form. We have some ideas, but we don't know the mechanisms and processes. We can recreate them because we understand what leads up to them, but we don't understand the physics. Why do we get huge energy surges over 10 megawatts? Maybe it has to do with the paper that Lowell, my name's on the paper too. I edited some of the things, but Lowell really is the master of that paper on ion electron trapping in these double layers. And this may be an answer to why the sun's photosphere is so intense. Maybe why that's why there appears to be fusion occurring in the sun's photosphere. Are we getting transformation of elements? Good question. Are we getting more energy out than in? We get asked that question all the time. We think now we may be able to answer some of these things. What does the voltage gradient look like before Sapphire fires? We can confirm right now that there is a voltage gradient in Sapphire in phase 2 before it actually ignites. But we can now go and measure that gradient. We may even be able to measure the voltage gradient before it actually does an intense stream plasma discharge to a particular point. This is the thing that leads up to lightning bolts. What's actually the environment around there, that lightning bolt, before you actually see a lightning bolt or plasma discharge? So is the voltage gradient, as an example, is it uniform throughout the chamber? We can measure these things now. X-rays, neutrons, gamma rays, and much more. And that's really it for this presentation. So we'll leave you with this. What I'm going to do right now is invite some of the, really the people that have been involved in Sapphire, people that you don't really hear about, up to the stage, introduce you to them. And then I guess we're going to do a question and answer with just the core team. So thank you. It's been a privilege.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at... Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Today we delve into the core of one of the great controversies in solar physics. In the 1960s, scientists first discovered that the number of solar neutrinos detected on Earth did not fit the predictions of the standard model of the sun. In this model, the sun is powered at its core by a thermonuclear reaction, and the production of neutrinos occurs in the sun's interior. In more recent years, scientists have adjusted some of their ideas about neutrinos, and news headlines have pronounced that the mystery has been resolved. But should the neutrino problem really be laid to rest? To explore this question, we asked Wal Thornhill for an overview of neutrino production in the electric sun model.
It's been said that the electric universe model predicts that there will be no neutrinos from the sun. Well, that's obviously incorrect, because the electric universe model was produced long after it was known that the sun produces neutrinos. The problem for the standard model of how the sun works is that the number of neutrinos detected was always about a third of that calculated. And this, in effect, was disproving the idea that the sun's energy was generated in the way originally suggested by Eddington back in the 1920s. The point is that the standard model of the sun is almost 100 years old. It was born in the horse and buggy and gaslight era, if you like. And at that time, the problem was that it was not understood how the sun could have kept shining for the geological ages that were being discovered, because the age of the Earth was being progressively pushed out from hundreds of thousands to millions and then to billions of years. And the question was, it seemed obvious that the sun must have shone for most of that time. And then the question arose, how do you power the shining sun? So when nuclear energy was discovered, it was immediately grasped, because it offered one possible way of producing the energy for the time span required, billions of years, since it consumes so little fuel in any given moment. The problem then was to explain the sun in terms of a nuclear reactor. And of course, the scientists came up with a very ingenious scheme which required that the sun be composed entirely of hydrogen, which defies all common sense when you think about it, because heavy elements will sink to the center of an object, and the hydrogen would sit as an atmosphere. Anyway, disregarding that, it was assumed, therefore, that all stars were born shortly after the universe was created, and that at that time, most matter was in the form of hydrogen and some helium. Now, the problem with the nuclear reaction theory is that it is an extremely unstable and very complicated process. Producing nuclear fusion by squeezing and heating matter in the center of a star is the most inefficient method conceivable, as witnessed the half-century or more long attempts to produce fusion power in laboratories on Earth. It is a highly improbable process, even under the calculated extreme conditions at the center of the sun. The unlikely process omits to mention that quantum tunneling is also needed to make it work. And if nuclear fusion is happening as theorized, it can only produce the first few light elements in the periodic table. So the question is, where do the heavy elements seen in the sun's spectrum come from? Well, the answer is that it's a kind of impurity from supernova explosions. But there are far too few supernova explosions to have produced the heavy elements observed. And what's more, a supernova is in the business of exploding and dispersing matter into the vastness of interstellar space. It's much better to have a theory that solves this fundamental problem in place, inside or on stars. Nature doesn't do anything the hard way, so why would she not use the same technique that particle physicists use to create heavy elements on Earth? That is, particle accelerators. But particle accelerators require electrical power, and astrophysics is the only science that doesn't use it. Astronomy remains, with Eddington, in the gaslight era. The detection of neutrinos has been only about 1/3 of the calculated number, and the discrepancy is well outside both the uncertainty of the calculations and the experimental deviations. The problem was so intractable for the standard model and astrophysicists that particle physicists were called upon to determine if there was something we didn't know about the neutrino. So the particle physicists proposed that if neutrinos had mass, which at that time had been undetected, they might oscillate between the three known forms, the electron, muon, and tau neutrinos. The low count of electron neutrinos might then be accounted for if they had changed flavor, as it's called, on their journey from the sun's core to the Earth. This is because the neutrinos can pass through the matter of the sun without being interfered with. In 2001, it was announced in Physics World that the solar neutrino puzzle is solved, and I quote, "The first results from the Sudbury Neutrino Observatory in Canada have finally solved a problem that has puzzled astrophysicists for 30 years. Why do experiments detect less than half the number of solar neutrinos predicted by models of the sun? The results confirm that electron neutrinos produced by nuclear reactions inside the sun oscillate or change flavor on their journey to Earth. Neutrino oscillations are only possible if the three flavors of neutrino, electron, muon, and tau neutrino, have mass. The Sudbury result, therefore, has important implications for both cosmology and particle physics." So what are neutrinos? Well, neutrinos are elementary particles of matter with no electric charge and very little mass. They only interact weakly with matter, which makes them very difficult to detect. Indeed, the Sudbury experiment detects a mere 10 or so neutrinos per day. Electron neutrinos are produced in the sun's core when boron-8 nuclei undergo beta decay, and the sun is not thought to produce muon or tau neutrinos. Previous experiments have detected less than half of the predicted solar neutrino flux, but these experiments were only sensitive to electron neutrinos. Now the combined Sudbury and Super Kamiokande results make it clear that this shortfall arises because electron neutrinos have changed into muon or tau neutrinos. This result agrees perfectly with theoretical predictions and indicates that we really do understand the nuclear processes that are the source of the sun's energy, said Lincoln Wolfenstein, a particle theorist at Carnegie Mellon University in the US. By comparing the figures, physicists from Sudbury and Super Kamiokande calculated that true solar neutrino flux is 5.44 million neutrinos per square centimetre per second, which is in excellent agreement with the standard solar model of energy production in the sun. But this headline underscores a cultural problem in reporting science that leads to bald statements of fact when the conclusion is in fact conjectural. The detection of neutrino oscillations cannot confirm the standard solar model. It merely offers a possible solution to one of a number of serious observational problems with the standard model. There can be no confirmation of oscillation of neutrino flavors between the Sun and Earth without simultaneous neutrino measurements being made near the Sun, and that poses formidable experimental problems. On the other hand, the electric universe proposes an electrical model for stars based on the pioneering work of the engineer Ralph Jurgens. So the question is, what if the neutrino discovery is correct? And it seems to be so. It says nothing about the correctness of the standard solar model, but it does have important implications for cosmology and particle physics. If neutrinos do have mass, it will confirm the electric universe model. The electric sun model expects far more complex heavy element synthesis to take place in the natural particle accelerators in the photospheric lightning discharges. That is, the light of the sun is electrical and is of such a power that can actually generate nuclear fusion reactions. But the nuclear fusion reactions are not restricted to those that were planned or worked upon back in the 1920s. In this case, the various neutrino flavors are all generated on the sun and do not need to oscillate on their way to the Earth to make up an imagined deficit. What is more, fluctuations in neutrino counts are expected in this model to be correlated with electrical input to the sun, that is, with sunspot numbers and solar wind activity, and this has been observed. The standard solar model does not expect any correlation since there is a lag estimated in the hundreds of thousands or millions of years between the nuclear reaction in the core and its final expression at the surface of the sun.
On the question of the very nature of the sun, a critical issue rarely discussed in popular media is the recent discovery of anomalously weak solar convection, between 1 and 5% of what the standard model requires.
It has to be acknowledged that recent research has shown that the so-called convection beneath the photosphere, which is supposed to drive all of the magnetic phenomena that we see, including sunspots, just isn't there. It's only a fraction of what is required by theory. So the sunspots themselves are not explained in the standard solar model. To sum up, the electrical model of the sun requires that neutrinos of all flavors are produced by heavy elements nucleosynthesis in the photosphere of the sun, right where we see it. It is far simpler than the nuclear fusion model, whose major assumptions cannot be confirmed either by visual inspection or certain rogue data. All of the obvious electric discharge phenomena seen on and above the photosphere have analogues that can be seen on Earth and/or reproduced in electrical engineering laboratories. It is far simpler to assume that the energy received from the sun is coming from where we see it at the surface or photosphere, rather than a minuscule and unlikely hydrogen bomb 93 million miles distant, shrouded in opaque gas. Then the very fact that sunspots are dark makes perfect sense. It is cooler everywhere beneath the photosphere. Mysteriously generated magnetic fields are not required to explain every strange solar phenomenon and to defy the laws of physics in the process by breaking and reconnecting hypothetical field lines. The surprisingly even magnetic field of the sun from the equator to the poles is to be expected if the sun is the focus of a cosmic electric discharge, as Jurgens first suggested 30 years ago.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. The recent Electric Universe conference in Albuquerque, New Mexico, featured investigators from wide-ranging disciplines who have come to a common conclusion. The key to understanding so-called climate change is the electromagnetic connection between the Earth and the Sun. One of the most powerful of these voices is Piers Corbin, who has achieved international acclaim for the accuracy of his long-range forecasts. Although we hear daily of a scientific consensus to the contrary, what does Piers make of mankind's alleged role in affecting the climate on Earth?
I'm not choosing anything. What we find are the physical facts, namely, Firstly, that carbon dioxide does not drive climate. And there is no evidence for this in real data. What actually is happening is that temperature changes in the oceans in the long run drive carbon dioxide levels, so they tend to move together. So there's no actual evidence for the CO2 theory. There are claims that it ought to work for various reasons, but obviously those reasons are not valid because it does not work. And the second aspect of why it doesn't work is that man's contribution to carbon dioxide in the atmosphere is only 4% of the total amount in the air of CO2, which is 4% of 0.04%, which is a tiny amount. Now, if man is going to dominate the CO2 effect, then all the rest of the CO2 has to stay constant. So you've got to have a conspiracy of nature to stay still while man rules. Now, CO2 in the past has gone up thousands of times bigger than man's contribution. So this idea that volcanoes, termites that emit 10 times more CO2 than man, or cows or grass or whatever are going to all hold still while man does his thing is completely absurd. So, you know, there's no evidence for it. And the idea itself that CO2 controls climate, and man's CO2 in particular controls CO2, which controls climate, is actually delusional nonsense.
Although mankind's industrial activities may be having little to no effect on climate, the reality of dramatic shifts in climate and weather is apparent.
Well, of course, climate is always changing, and it always has changed for millions of years, and there's nothing new. The only thing that's new now is that man is claiming he's doing it, which of course man has claimed many things in history that he's done, which he hasn't. Like man, he claimed he was the center of the universe, but we don't believe that anymore. And it won't be long, I hope, before man realizes he's not actually controlling climate either. Anyway, that apart, what is causing these big changes we're seeing now? There's been very big extreme events, extreme tornadoes, not necessarily more tornadoes, but extreme tornadoes, very extreme hailstorms, very big swings in temperature, and generally colder situations. And in particular in North America, we've had the polar vortex, as it's called, that is the colder parts to the north of America mostly, tilting further south and giving an extremely cold winter and spring. Now, these things are driven by solar activity. Basically, the position of the jet stream, that is the fast air, upper air, which moves around the planet in mid-latitudes, that is moving all the time, and solar activity affects its course. And when you've got periods of low solar activity like now, two things happen. One is the jet stream gets longer, and so on average it's further south. And the other is that it swings more wildly north to south. And that means we get much bigger extremes and temperature contrasts. We predicted that this was going to be the case from about 5 years ago. We said we were moving towards this, and this, we being Weather Action, long range forecasters. And it is being borne out. The jet stream is showing wild swings. There are more contrasts. There are more extremes. And we do have very specific predictions being borne out, as they were during the last mini ice ages. Namely, there's been very big hail events, an increased number of very extreme storms, and a general cooling of the northern hemisphere.
If the actual evidence for anthropogenic global warming is so questionable, why does institutional science seem so convinced of its reality?
Well, understand that the people who will receive very large funding from governments who promote man-made climate change for tax purposes, these people are very anxious to prove their point. Now, they may or may not believe everything they say, but of course, When the CO2 theory started to go wrong, the people in the University of East Anglia emailed each other and said, well, we must have the wrong data. So they went about selecting other data. Now, of course, there's data and data. You can always find data which helps your case rather than just data randomly chosen, which doesn't help your case. And that's what they have been doing. And of course, this I would describe as fraud. That is concerning surface temperatures, because there's a lot of choices open on surface temperatures. And there's a lot of problems with surface temperatures because of urban heating and so on. So if you...
So main takeaway, CO2, rise in CO2 does not rise temperatures. Temperatures make CO2 go up. So their data for causal effect is incorrect. That's basically the main takeaway of that video. So.
There are almost daily reports that black holes have been found. Has anybody actually found a black hole?
The answer to that is no. No one has ever found a black hole. There are two characteristics that are alleged for these black holes, and one is an event horizon and a singularity, and no one has ever found either one of them. And the other thing is that the true definition of black hole universe is that it contains only one mass, and that's the black hole itself. So you can't have multiple black holes. So consequently, no one can say that there are black holes all over the universe. And so they can't find any because there's nothing to find.
You say that there are different types of black hole universes and Big Bang universes, and they can't coexist. What does that mean?
Well, there are 4 different types of black holes that have been alleged in theory. And I can list them for you quickly. It's non-rotating charge neutral, non-rotating charged, rotating charge neutral, and rotating charged. So there are 4 types. Sizes don't matter. And then there are 3 types of Big Bangs. One is a spatially finite universe that's expanding, and the other 2 are spatially infinite universes of different characteristics, and they're expanding. And so by their very definitions, they can't coexist because, let's take, for example, black hole universes are all eternal, but all Big Bang universes are of a finite age. And so similarly, black hole universes are spatially infinite, but we have the 3 Big Bang universes. One is finite and 2 are infinite in a different characteristic. So they can't coexist by definition. So when you hear a person talk about black holes and Big Bangs together, they never specify what type of Big Bang and what type of black hole. They always just say Big Bang, black hole. Well, this doesn't tell us anything. And the other thing is, as I pointed out, they can't coexist by their very definition. So it doesn't make any sense.
Scientists tell us that they have found a radiation relic of a Big Bang in a cosmic microwave background. Where does this radiation come from?
The idea of the scientists propose is that this Big Bang is radiation in microwaves is a relic of the early stages of the universe from their Big Bang theory, and that they carry out a number of experiments to detect this radiation. However, they've never proven that this radiation comes from space. The truth of the matter is, if you put a glass of water in a microwave oven and turn it on, what happens to the water? Anybody who's used a microwave oven knows that the water is hot, and it does so by absorbing microwaves. So that means water is also an emitter of microwaves. Well, when we consider this very simple truth, we know that the surface of the Earth is mostly 70% covered 70% by water, and there's water in the atmosphere all the time. And in steady state conditions, we have microwave radiation throughout the atmosphere. And the most distant detection of the microwave, so-called microwave background, has of the mean temperature of the universe that they tell us has been at an altitude of 900 kilometers with a satellite that could not protect itself from microwaves. So the truth is that the microwave detection for the temperature of the universe is actually microwave signals from water on Earth. It does not come from the cosmos.
Okay.
Big information right there.
Thanks for the interview.
Thank you very much. I'd like to first begin by dedicating this to my brother, Paul Crothers, who died in 2008. And the first thing I'd like to point out to you is that you might not be aware of it, but there are more than one type of black hole. When you hear a proponent of black holes and Big Bangs talk about them, do they ever tell you what kind of black hole and in what kind of Big Bang universe? Never. They seem to be even unaware of it themselves, that they have 4 types of black holes and 3 types of Big Bang universes. Let's run through them very quickly. We have non-rotating charged neutral, so-called Schwarzschild black holes. Then we have non-rotating but charged black holes. These are called Rosen and Nordstrom black holes. Then we have rotating charged neutral. This is a Kerr black hole. And finally, rotating charged black holes. This is a Kerr-Newman black hole. But with Big Bangs, we have 3 different types. And it all depends on this strange thing here called K. It's called a curvature, a constant curvature. That's what we'll say about it. And it tells you which one is which. Well, if we have K equals -1, we have a negatively curved space-time. It's spatially infinite and expanding. If we have K equals 0, we have a flat space-time, which is spatially infinite and expanding. Now we have K equals 1. This is positively curved space-time. It's spatially finite, expanding, and later contracting. So I pose to you again, when a proponent of black holes and Big Bangs says anything about this, do they ever tell you which one they're combining with which? Never. Why? They don't seem to know. But without specifying what black hole in what Big Bang universe, they're not telling you much. Right? So let's have a look at what they actually do here. But before so, the first thing is, let's compare all types of black holes, the 4 types. Now, I'll point out quickly that the sizes of black holes don't matter. We're all certain types of human beings. There are races of man. I'm a Caucasian. Probably most of you are. Some of you might not be. But that's a type of human being. But small or big, I'm small. But I'm still a Caucasian human being. Well, black holes, size-wise doesn't matter either. They say that there are micro black holes, mini black holes, intermediate black holes, supermassive black holes, ultra supermassive black holes, and now they're telling us we have obese black holes. I don't know where they're going to stop. They don't seem to stop. They just keep adding adjectives, and that makes bigger and bigger black holes. But the fact of the matter is they're all only of these 4 types. Now let's compare the black holes to Big Bangs. All types of black hole universes are spatially infinite. We go to the Big Bangs. Well, one of them is spatially finite, and the other 2 are spatially infinite, and there are 2 different types of infinity. Do they match? No. Let's have a look at this one. All black hole universes are eternal. Technical terms are static or stationary, but they're eternal. Well, every one of the Big Bangs, rather, that are alleged are of a finite age. How old? Well, they tell us maybe it's about 13.8 billion years. But does that match? No. Black hole universes, well, they actually only contain 1 mass. I'll talk about that a bit later. And we can compare it with Big Bangs. They're supposed to contain radiation and many masses, including black holes. But that doesn't match. No black hole universe is expanding. All black hole universes are not expanding. But all Big Bang universes are expanding, except the finite one. That might contract. We don't know when, but maybe. And finally, this is a little bit of a technical term, all black hole universes are asymptotically flat, or asymptotically fat, they could be, asymptotically flat, or asymptotically curved. And all Big Bang universes are not asymptotically anything.
He kind of
So
did.
Match? No.
where we got 5 mismatches here, and these are all generic characteristics of these different universes. And I'll point out also, we saw in the last slide, a K curvature. Well, notice that no black hole universe possesses a Big Bang constant K curvature. That's another big difference. Well, that's what defines the 3 different Big Bangs. It's got nothing to do with black holes. So we see that these universes are mutually exclusive. How do they then put together a black hole universe? It's infinite, spatially infinite, and it's eternal, and they stick it into what? Maybe a finite one that's of a finite age. Finite in size, finite in age. It can't possibly match. Whether they stick that into one of their infinite ones, well, the 2 infinite ones of Big Bangs don't match the infinity of the black hole.
He's really making a
because this one doesn't have a K curvature.
Standard physics.
It's still eternal.
What's established.
They're Big Bangs that are expanding. They're still a finite age. How much? Still, we're around about 13.8 billion years. They've edged it up from 13.65, and over the years it's got up to 13.7, 13.72, 13.75. Now it's 13.8. They're tweaking all their little bits and pieces. But you see, none of these match. So when anybody says to you, I've got all these black holes floating around in the universe and it's expanding, what are they talking about? Nonsense. Their very definitions, which they forget, exclude this. It's not possible. The theory doesn't allow it. Now, if you don't know which Big Bang you're going to talk about, let's talk about the whole lot at once. That's what they do. Look, now Lineweaver and Davis wrote an article for the Scientific American. They say this: the idea that the Big Bang was small is misleading. The totality of space could be infinite. So which Big Bang are they talking about? The infinite ones? There are 2 of them, and they're different. And the finite one? Well, it could be, because the totality could be finite, could be infinite. That means it could be finite. They're giving you 3 at once. This is not science. This is what we call double talk. Now we come here. Weinberg. Weinberg's at the University of Texas at Austin. He's a Nobel laureate. He says all space in this context may either mean either an infinite universe or all of a finite universe. So he's giving you 3 Big Bangs at once. Well, you can't have 3 Big Bang universes at once. Which one do you want? You only live in one universe. Unless, of course, you're Larry Krauss, you have multiple universes called a multiverse. And the Big Bang happened everywhere. In the room in which you're reading this article, in a spot just to the left of Alpha Centauri, everywhere. But the space between the galaxies and us is expanding. Now notice this. Where is the spot next to Alpha Centauri? A spot is pretty small. Bill Gates talked about spots. And where's Alpha Centauri? Well, it's smack bang inside, yes, the galaxy that we live in. But the space between the galaxies and us is expanding. So the Big Bang happened everywhere, but only the space between the galaxies is expanding. The spot next to Alpha Centauri, they're not separating from each other. Why? The Big Bang happened there too, didn't it? Yes, it happened here on my desk. Happened everywhere. But for some reason, you're not allowed to have the space next to the spot, or the spot next to Alpha Centauri expanding. Nothing else is expanding except the space between the galaxies. So they give you a balloon, they blow up a balloon, they put spots all over it and say, look, the balloon is blowing up and the spots are moving apart. But the spots themselves, they don't change their size. Really? If you put spots on a balloon and blow it up, do the spots expand? Yeah, obviously. No, not according to a cosmologist. The galaxies don't expand. Only the space between them. Although their Big Bang happened everywhere, including the spot next to Alpha Centauri in our galaxy. Here is a technical reason why you can't add Big Bangs and black holes. We've already seen you can't because their definitions preclude it. Here's a little bit of mathematical mumbo-jumbo that they violate. General relativity is what's called a nonlinear theory. And this means that the principle of superposition doesn't hold. What does that mean? Well, it means if I've got one mass and I take another mass somewhere and I'm going to stick it together in the universe, I've superposed that those masses now together in the universe. I can put in more and more, can I? Well, if you're talking about Newton's universe, you can. Newton doesn't put any limitation on how many masses you can have. And when you look in the sky, you have to have a theory that will allow you to put all those masses in, because there are lots of masses out there, right? But can you do it with general relativity? No. It's a nonlinear theory. So let's take a specific example. X, let X be some black hole universe, and Y some Big Bang universe. And let Z be some other black hole universe. Remember, there are 4 types of black hole universes, and they're all mutually exclusive. You can't put 2 of them together. Let's have a look at this. X plus Y is not a universe. Why? Because there's a nonlinear system. This is a linear combination. X plus Z is not a universe. So we've got a black hole and a Big Bang. You can't put them together. The theory says you can't. Well, we've seen you can't because the definitions don't allow it either. Well, X plus Y plus Z is not a universe either. They're superposing. But you can't superpose in general relativity because the theory is nonlinear. So that superposition is not allowed. Nonetheless, proponents of black holes and Big Bangs, they take some Big Bang universe, they never tell you which one. Then they take some black holes, and lots of them, and they never tell you which type. Then they superpose the whole lot together in violation of the very structure of the theory that they're using and the very definitions of holes and bangs, and tell you we've got lots of black holes in some non-specific Big Bang universe. Well, this is Tolman. He wrote a book long ago on general relativity, and he tells us this. Well, you'll see that Big Bangs are actually one mass universes. So you can't even have multiple masses. We can then treat the universe as filled with a continuous distribution of fluid of proper macroscopic density and pressure, and shall feel justified in making this implication, since our interest lies in obtaining a general framework for the behavior of the universe as a whole, on which details of local occurrences could later be superposed. So Tolman's telling us that we can superpose all these things. You can't. The very theory that he's using prevents it. In general relativity, superposition is forbidden. Can't do that. In other words, when I gave you the example of X and Y universes, a black hole and a Big Bang, those 2 universes pertain to completely separate Einstein field equations, and they have absolutely nothing to do with one another. Why? Because they're very different equations. So you take a solution X for the black hole universe, and you take a solution Y for a Big Bang universe, completely different equations, and then stick them together, maybe with glue. But it doesn't work. It's a nonsense concept because it violates the very theory that they're using. Here's an interesting little argument. Einstein says his principle of equivalence is very important to general relativity. He tells us, I've shortened it because it's very long. All we need to know is this. Let now K be an inertial system. Masses which are sufficiently far from each other and from other bodies are then, with respect to K, free from acceleration. We shall also refer to these masses to a system of coordinates K prime, uniformly accelerated with respect to K. Notice that he's talking about lots of masses. Then he says another way of saying this is that in any sufficiently small region of his space-time, and they can be anywhere, those regions, the laws of special relativity must hold. So we see from both of these 2 points here that each one of them requires the a priori presence of multiple, arbitrarily large, finite masses and some photons to be able to see anything. But where do they come from? All the black hole universes and the Big Bang universe violate this principle. Why? Well, we just saw that the Big Bang universe is a one mass universe because it's continuous, homogeneous, can't be divided out. You treat it as though it's wholly full or completely filled by a continuous distribution of matter. It doesn't break up because as soon as you break it up, you've got multiple masses and you have no expressions for that. So black hole universes and Big Bang universes violate the very principle of equivalence that Einstein lays down as a basis for his theory. So that doesn't work. Let's consider forces, gravitational forces. If you put 2 balls, solid balls on a strings and hang them from the roof, and you hold them still, and then you let them go, what happens? Well, we know from the laboratory that they approach one another somehow. Cavendish did experiments like this. He found, yes, they go together somehow. But we find that in general relativity, in Einstein's new theory, gravitation is of a much more fundamental nature. It becomes almost a property of space. Gravitation is thus, properly speaking, not a force in the new theory. This came from Willem de Sitter, a Dutch astronomer who was a contemporary of Einstein. Well, That's true, because in general relativity, gravity is not a force. It's what? The curvature of space-time. So what's happening here is the curvature of the space-time here somehow pulling the curvature of the space-time here so that these two things go together, because we know that that happens in the lab, right? And it's not a force, mind you. When we look at it in the lab, it seems to be some kind of force. But in Einstein's theory, it's not a force. Right? So this has no explanation in general relativity. In fact, general relativity can't even account for the presence of two masses, and it can't even account for the experimental fact that those two masses will approach one another if you release them. You hold them still, let them, then release them, they come together. General relativity cannot even describe it, let alone explain it. And yet we have general relativity being used to talk about black holes all over the place, you know, the expanding Big Bang universe, and it can't even deal with two masses. This is not a NASA photograph. I know that because it's an artist's impression. I know the artist. It's me. I drew this. You can tell I can't draw. This little astronaut, well, let's have what Hawking tells us. This is called spaghettification. You take a person and you stretch them like this and you turn yourself into a piece of spaghetti. Well, Hawking tells us gravity gets weaker the farther you are from the star. So the gravitational force, yeah, he's invoking forces again. Where did he get those forces from? It's not Einstein. There is no force in gravity in Einstein. This comes from Newton. So now he's mixing Newton's theory with general relativity by invoking the forces. There are no forces in general relativity. And our intrepid astronaut's feet would always be greater than the force on his head. Well, when you look at my little drawing here, is he falling head first or feet first? He could be falling head first. That means this black hole or star might be above his head. Well, he's talking about feet, so we'll put it down here. So he is falling feet first. But you can't tell from the diagram. This is very interesting because every time you see a presentation of black holes and big bangs, they put up little diagrams like this sort of thing, and they put all this sort of double or vague talk in here, and you think, oh, he's falling. Yeah, but which way? We have to be sure. This is a technique that advertising executives often use to sell you things. Put up diagrams and drawings and things, and you get a sort of a subliminal effect. And so since there are no gravitational forces in general relativity, there's no weight. You go to the shop and you buy yourself some apples, right? Remember the old days? I remember the old days because I'm old. Because you used to go to the grocery store and you would have a dish hanging on a spring balance, and you put your apples in there, and the apples would be pulled down on the spring balance. The spring balance stretches, and the indicator goes like that and says, "Oh, you owe me €5." I don't know. You didn't have euros back then, whatever it was, right? So you paid for your apples. You take the apples out, and the spring balance pulls it back up. The spring balance exerts a force against the thing that's pulling it down. We're talking about forces. Can general relativity do that? No, can't explain it. Has absolutely no way of even describing it. So what's happening in our spring balance and our apples is the curvature of space-time of the spring balance somehow causing the curvature of the space-time of the apples to interact somehow to make the spring stretch so that the indicator works and you can know how much to pay for your apples. It can't do it. So we see that it's all done by invoking Newtonian forces in a clandestine way. You're talking about general relativity, and then you talk about forces of gravity. That's a violation of logical thinking. Here's a little diagram of a black hole to explain to you why it is that a black hole is an infinite universe. It contains only one mass. If there is a mass, we're assuming that there is a mass, the black hole. We'll see later that there is none. But let's assume that there is one. Here's flat or curved space-time. So we see what we mean by asymptotic. You remember this from school. An asymptotic curve. It gets closer and closer. Does it ever touch? Never. Is there any limitation on how far this goes out? No. The word asymptotic means there is no bound. So if you don't have some sort of asymptotic feature here, right, then you don't have a black hole universe, because we saw that they're defined as being asymptotically flat or asymptotically curved. So here it is. This goes to infinite curvature. That's an infinite gravity according to Einstein, because gravity is space-time curvature. So here, infinite means the gravity must get infinite. Where? At a point. Maybe. I'll see later. We'll see later. It could be something else. So here may be a point. It's asymptotically flat. Yes, all right. As you increase the radial distance away from your singularity, you go asymptotically. Okay, that's good. We've got a pictorial idea of what it is now. We see there's no boundary here. So this describes what they, or this illustrates what they're talking about. Let's think of two of them to start with, just two. We put the two together. Here he is to the singularity of a black hole. It doesn't matter what type. I haven't specified what type of black hole here because it pertains to all of them. And this goes to another singularity, infinite curvature again. Well, let's look at black hole number one. Is that asymptotically flat there? No. Is it asymptotically curved in here? No. And if you go away from this black hole and you encounter this black hole and you come to another, infinite curvature. Infinite curvature is a long way from being asymptotically flat or asymptotically curved. Now let's look at number two. Well, is this asymptotically flat? No. Is it asymptotically curved? No. And this number two encounters an infinite curvature at black hole number one. So neither of these can be asymptotically anything. Well, we've already seen that the definition of a black hole is asymptotically flat or asymptotically curved. So if you've got two of them, is it possible to have a black hole? No. Is it possible to have two of them together? No. Because this violates the very definition of what the black hole is. So how do they put all these black holes together? Well, according to Daniel Stern, he must be right. He's a NASA scientist. He tells us we've got the black holes cornered. Really? He says, well, they reckon that they found 2.5 million black holes with the NASA WISE survey. So he's got them cornered, all these 2.5 million of them. Well, let's look at this one, lots of black holes. I can't put 2.5 million in there. My box is not big enough. So we'll think about the 2.5 million. Well, let's think of one of them. Here it is, one of them. Each one of these 2.5 million black holes encounters 4,499,999 infinite curvatures all around it. Is that asymptotically flat? Is it asymptotically curved? Not a chance. So this is what? Complete and utter nonsense. Here's another gem. I love this one. I think you'll like it too when I explain it to you. Black hole escape velocity. No proponent of black holes even understands escape velocity. Yeah, they have no idea. Right? Escape velocity is a very simple concept. They don't understand it. Let's think of this. This might be the sun or the earth, say. If you have an escape, if you project an object, maybe a ball or a rocket, with the speed of the escape velocity or escape speed, this thing will get away and it doesn't fall down. What if you throw a ball up into the air? What do? You throw it up into the air, the ball goes up, and it falls down. Why? Because its speed wasn't fast enough. It didn't have the escape speed. Did this leave the Earth? Certainly. Did this one leave the Earth? Well, it escaped, so it certainly left. This one didn't escape, but it certainly left. It went out, it got to a point where it stopped, and it fell back down. We know that every day. According to history, Newton was sitting under a tree, and an apple hit him on the head because it fell straight down. Now, let's consider a black hole. We have an event horizon. What do they tell you about an event horizon? They tell you that the escape speed is at the velocity at the event horizon is the speed of light, or maybe even greater than the speed of light. They tell you that the black hole, things go into the black hole, but nothing can come out at all. Well, here, things come out. Yeah? Here, nothing can come out. You go in, when you're in, you can't come out. You can throw a ball here, it won't get there. Nothing can even leave the event horizon. And there are no other bodies present. So what escapes from what? If you've got a one mass universe, as we've seen with a black hole, how can you get the other mass to be even present to escape from it? You can't. And here, even if there was one, can it escape? If it goes in here, you're in here, can it escape? No, because here at the event horizon, the speed of light is the escape speed. They say nothing can escape. That's the escape velocity of a black hole. Really? But can anything leave here? No. Did anything leave here? Yes. So this idea here that nothing can even leave violates the concept of escape velocity. Just because you have an escape velocity doesn't mean things can't leave. It means things can leave and fall down or they can escape depending on their speed when they're at first projected. But here, there is no such thing as escape velocity. But they tell us nonetheless that the black hole has an escape velocity and that the event horizon, it's c, the speed of light. Not only that, this is what we find in the dictionary of geophysics, etc. Black hole, a region of space-time from which the escape speed exceeds the velocity of light. They're telling us it's got an escape velocity. We just sort of can't have one, but they're telling us it has one. Here's Hawking. I had already discussed with Roger Penrose the idea of defining a black hole as a set of events from which it is not possible to escape to a large distance. He's talking about escape again. It means that the boundary of the black hole, the event horizon, is formed by rays of light that just fail to get away from the black hole. Instead, they stay forever hovering on the edge of the black hole. What? They stay forever hovering on the edge of the black hole, but the escape speed of the black hole is allegedly what? The speed of light. Well, this is amplified by Professor Josh Bland Hawthorne of Sydney University. He's at the Institute for Astronomy. He's an astrophysicist. He got on television, Australian national television. He said this. I really like this one. A black hole is a massive object, and it's something which is so massive that light can't even escape. And he's talking about escape again. There is no escape velocity. Some objects are so massive that the escape speed is basically the speed of light. Yeah, a black hole. And therefore, not even light escapes. So black holes are themselves are basically inert, massive, and nothing escapes. Let's have a look at this. He says it's basically the speed of light, and therefore not even light escapes. Well, the speed of light travels at what? The speed of light. He tells us that the escape speed is the speed of light. Then he tells us that even though the light is traveling at the speed of light, and therefore the escape speed, light can't escape. I wrote to him, and I said, can you explain this, what you just said on national television? You know what he said to me? Stop sending me emails. That's his solution to this complete and utter nonsense. Right? But people don't realize what they're being told on television or in books or papers. I like this. This is really nice. Meisner, Thorne and Wheeler, they've had a mention today in some ways. Meisner, Thorne and Wheeler wrote a book on gravitation. It's the size of a telephone book. You can use it as a paperweight or a doorstop, right? But he says here, or they say, one crucial assumption underlies the standard hot Big Bang model, that the universe began in a state of rapid expansion from a very nearly homogeneous isotropic condition of infinite or near infinite density and pressure. Now I ask you, how close to infinite do you have to get to be near infinite? Really? Is it infinity minus one? Maybe it's infinity plus one, or infinity minus a billion. This is nonsense. You can't get near infinity, near infinite. Well, not to be outdone, Larry Krauss, the famous Larry Krauss who gets on television all the time, tells everybody everything about Big Bangs, ridicules lots of other people. He tells us, but this is what he did on 18th of February in 2013, last year, on Australian national television again, on a show called Q&A. You can get the transcripts, so you can get it and read it for yourself. But he says this, but it is that, in fact, because of discovering that empty space has energy, it seems quite plausible that our universe may be just one universe in what could be almost an infinite number of universes. And in every universe, the laws of physics are different, and they come into existence when the universe comes into existence. Well, how close to infinity did Larry count to get almost an infinite number? You tell me. Can you count to almost an infinite number? Not a chance. But he's telling television land, all the people in Australia at least, on national television, that he reckons you can get an almost infinite number. They do a lot of magic with these infinities. Here's another one. The work that Roger Penrose and I, this is Hawking speaking, the work that Roger Penrose and I did between 1965 and 1970 showed that according to general relativity, there must be a singularity of infinite density within the black hole. Well, now we come to the question of the singularities. There are two types alleged. One is a point. A point has 0 dimensions. It's a mathematical thing. The other black hole, it's for rotating. So we've got 4 types of black holes. 2 of them are non-rotating. 2 of them are rotating. So we have only 2 types of singularities. A point and the circumference of a circle. I'm not saying a circle. A circle has area. This is the circumference of a circle only. Now you tell me how you get mass into a point or into the circumference of a circle. You cannot. So what do? They say, well, the singularity is volume. That's 0. And we got the mass of the black hole. That's some mass m. Yeah. And we divide by naught. and we get infinity. They do that. They say, you can divide by naught. Well, you know you can't divide by naught. Every schoolboy knows that. Every schoolgirl knows that. And they get infinity. Well, when did infinity become a number? You can't do algebra with it. You can't do arithmetic with it. But they tell us that you get infinity to get an infinite density. So they divide by naught, get infinity, and assign physical properties to it. Well, that's their singularity of their black hole. Now, do they divide by zero? Yes, they do. Because this is from a book on astrophysics by Carolyn Ostley. A non-rotating black hole has a particularly simple structure. At the center is the singularity, a point of zero volume. Yeah, we divided by zero according to their rules. And infinite density, where all the black hole's mass is located. Space-time is infinitely curved at the singularity. The black hole singularity is a real physical entity. It is not a mathematical artifact. So they're dividing by naught. Here again, this is from Dodson and Poston, a book on tensor geometry. Once a body of mass, of any mass, of matter, of any mass m lies inside its Schwarzschild radius. That's the event, the so-called radius of the event horizon. It undergoes gravitational collapse and the singularity becomes physical, not a limiting fiction. So it's not elementary calculus where you take a limit. No, you actually divide by naught. Well, that's nonsense. Here is the universe comes from nothing. Hawking tells us at the Big Bang itself, the universe is thought to have had zero size and to have been infinitely hot. Let's think about that. It's zero size, but it has infinite hotness. What is there to have infinite hotness? And what is temperature? According to physicists, temperature is all these particles jiggling around. And the more they jiggle, the hotter it is. You put more energy, whatever that is, into it, and it jiggles and jiggles more. This is hotter. Well, if you've got zero size, how do you have space for particles? And where do they jiggle? And if it's infinitely hot, how fast are they jiggling? I don't think Hawking's thinking very clearly when he says this. Here, zero size and infinite hotness. This is a meaningless statement. This is Larry Krauss again. So 18th of February 2013, on the same television show, he tells us that there's no real particles, but it actually has properties. But the point is that you can go much further and say there's no space, no time, no universe, and not even any fundamental laws, and it could all spontaneously arise. And it seems to me if you have no laws, no space, no time, no particles, no radiation, is a pretty good approximation of nothing. He's telling us that nothing is an approximation, a good one, of nothing. In other words, zero is a good approximation of zero, really. But it all came from nothing, mind you. That's zero. Oh, here's another good one. Again from Larry. He tells us, but I would argue that nothing is a physical quantity. It's the absence of something. I remarked in Albuquerque 2 weeks ago when I gave a talk there, I wondered, does this include the absence of neurons? You know, these are the bits in your brain. He got on television a second time. This is the 27th of May. He loves getting on television and telling his stories. There was nothing there. There was absolutely no space, no time, no matter, no radiation. Space and time themselves popped into existence, which is one of the reasons why it's hard. Someone stopped him talking there, see his little dots. You can see that in the transcript. Someone interjected. But with all of this, and they tell us dark energy, we need dark energy to make the universe expand. Hey, but Hawking tells us in his book, energy cannot be created out of nothing. They've just told us everything came from nothing. But he says, oh, but you can't create energy out of nothing. And they're dark energy. Isn't that energy? Yeah. Well, you can't create that out of nothing, according to Hawking, but they do. Now they talk about numerical methods. They have these magical numerical methods. You can't solve Einstein's field equation for two masses. You can't even write a set of field equations for two masses, let alone more than two. So they say, we'll use numerical methods. And they give you, well, binary black holes. Well, where do they get the binary black holes from? They superpose one black hole into another one. We see you can't do that. Then they say, let's apply numerical methods to these two things we just superposed, that you can't superpose, and we'll get some stuff out of that. And says, we can now find out lots of things about the universe by numerical methods on the two things we just stuck together that you can't do. So numerical methods on nonsense produces what? More nonsense. Now I'm come to a little bit of technicality here, so please bear with me. These are ugly customers, I know. This is Einstein's field equations. This thing here, let's identify them so that everybody knows what it is and doesn't get confused or afraid, because it's really simple. This looks really tough, complicated. It's really simple. This thing here is Einstein's tensor, the Einstein tensor. That's its name. We don't have to know what a tensor is. Don't worry about it. This thing here altogether, this is the cosmological constant. And they talk a lot about the cosmological constant. Yeah, we've included it here. And this thing here, this T, this K is just a constant. It's nothing. You know, Y equals 5x. 5's a constant. K is just some constant like that. T is energy momentum tensor. Now we've named the bits. This equation, Einstein's field equation, is no longer confusing. We have a word expression for it now. So we can reduce this, or now that we've identified the parts, let's reduce it to what it means. Space-time curvature, yeah, that's his alleged gravitational field, is matched to the material sources. Why? Because he still has to have mass, or matter, to cause the gravitational field. Otherwise, if you don't have mass and matter, you don't have any gravity. So he says his field equations couple his gravitational field to its sources. Yeah, there it is. Here's the gravitational field with the cosmological constant, and it's coupled to its sources. There's the name of the bits. That's what it does. According to Einstein, everything except his gravitational field is matter. Yeah, radiation, charges, mass, electromagnetic fields. All of this is matter, according to Einstein. So, okay, matter then induces the space-time curvature. He still has to have a cause of his gravity, so that's it. Let's have a look at them. There's the co-equations again, just to remind us of the bits and pieces. And let's compare. He says, well, if you set the cosmological constant to 0 and you set the energy momentum tensor, that's the sources. You take out the sources from the equations, make them 0. His G, that's naught, that's naught. So this becomes G equals naught. But this G thing reduces to even something more simple called the Ricci tensor. So the Einstein tensor becomes a Ricci tensor. Note, but I'll put it in red, energy momentum tensor equals 0. But he tells us that this describes the gravitational field outside a body. When he took them out with this hand, mathematically, and then he puts the mass back in with the other hand by saying outside a body. So this is a circular argument. Well, here it is, energy momentum tensor. This produces the Schwarzschild solution for a star or a black hole. Now let's go over to this side. T equals 0, material sources are gone again. The lambda, it's not 0, and we get this equation, because that reduces to this, and this thing stays there and it arranges so it comes out like this. Ricci tensor equals a cosmological constant term. Notice again that the energy momentum tensor is 0. Yeah, T's naught. There are no material sources. This one is called de Sitter's empty universe. Why? Because it contains nothing. There's no matter whatsoever. So we see here that according to Einstein, momentum tensor equals 0. That means material sources are both present and absent when energy momentum tensor equals 0. The very same mathematical constraint gives matter and a one mass universe and an empty universe. Well, that's not possible. You can't possibly do that. So what's this mean? It means this equation is nonsense. It means this equation is nonsense. Do you have a universe with nothing in it? Look into the sky. Yeah? See this one here? This doesn't mean anything. This contains nothing. This contains nothing. So as I said before, even their black hole solutions don't even contain a mass. It contains nothing. That concludes my little talk on black holes and big bangs. But I want to talk a little bit more about some other things, the cosmic microwave background, because this is now getting a lot of airplay. You have a recent report, BICEP-2 telescope in Antarctica. They found Einstein gravitational waves in polarizations of the cosmic microwave background. No, they haven't. They think they have. It's a figment of their imagination. Let's have a look here of a basis of this. This relates to Kirchhoff's law. In German, I think it's Kirchhoff. Kirchhoff? Yeah. Kirchhoff's law of thermal radiation. He takes a box, he lines it with graphite. He checks the radiation. After a little while, he waits and some radiation comes out. Here he gets this nice little, this sort of expression, nice curve. This is called a spectrum of the frequencies that come out of this radiation. And he calls this a black body. Why? Because it's lined with graphite or soot or lamp black. Yeah? And so he gets this in here. It's lined with graphite, etc., etc. And you get this black body emission spectrum. Now, the cosmic microwave background is alleged to be a black body spectrum at 2.725 Kelvin. That's just a little bit above absolute zero, right? Black body, remind you. Now, Kirchhoff made the mistake of thinking that he could make a box like this out of anything. It could be made of silver or mirrors or anything. And he would get, if he waited long enough, he would get a black body spectrum. So he made one out of graphite, yeah, he gets this. He made one out of soot, yeah, he gets this. So he makes one out of something else, a reflector, a very reflecting material. So he makes a box like that out of reflecting material. He waits. He waits, it goes past lunchtime. He's getting hungry. He says, well, it's getting late, I'm hungry, and there's no radiation like this coming out. I wonder how long I've got to wait. So he skips lunch and he waits till dinner time. He gets there. I'm not lambasting Kirchhoff. I'm just illustrating the waiting time. So he waits and waits and waits, but he doesn't get this spectrum. So he scratches his head and thinks, I wonder if I put a little bit of graphite in there, if it will squash up the waiting time. In other words, I wait less. So he takes his little box that's full of all this reflecting material instead of graphite. He puts a bit of charcoal in there, or Planck does. I'm not sure which one of them did. At least one of them did. Certainly Planck did. So they put a bit of charcoal or some graphite in here, and then he waits. All of a sudden, out comes this. He says, look at that. I've got now a black body spectrum. Marvelous. That piece of charcoal I put in there was a catalyst. I don't have to wait so long. What does a catalyst do? It increases or reduces the speed of a chemical reaction, right? So he puts it in there as a catalyst. Instead of waiting past dinner time or 6 months, he waits a few minutes or an hour and he gets a black body spectrum. So he says, this little piece of charcoal, that's a catalyst. No, it's not. As soon as he put the charcoal in there, this is a reflector. But the charcoal is an absorber. The radiation in that box there's radiation emitted by the charcoal. It bounces off all the walls, they're reflectors. It goes back into the charcoal. That's an emitter and absorber. It emits again. After a little while, the interior of the box is dominated by the charcoal. It is not a catalyst. It produces the radiation. So Kirchhoff made a big blunder. That's 150 years ago in 1860. Right. But all of this time, recently, Professor Pierre-Marie Robertet of Ohio State University in the United States has proven that Kirchhoff's law is false. The radiation that comes out of a cavity also depends on the nature of the material. This is very important for physics. It's at the foundation of quantum mechanics, because when Planck formed an equation for black body radiation, he introduced the quantum of energy. But this does not hold. So quantum mechanics, the foundations of quantum mechanics are in big trouble. Much of physics now has to be rethought because Kirchhoff's law is not valid. We see it all hinges on the insertion of a carbon particle. Now, if you take a glass of water and put it in a microwave oven and turn it on, what happens? Right? Does it get hot? Yeah. If you leave it in long enough, does it vaporize? Yes. So I ask you, does the water reflect or absorb the microwaves? It's pretty obvious, isn't it? The water must be absorbing the microwaves. Now we know from physics that a good absorber is a good emitter. That's why carbon, charcoal, graphite, it's a good absorber, it's also a good emitter. So water must also be a good emitter at what? Microwaves. So water absorbs microwaves, we know that from ovens. Anybody who's been in a submarine knows that you can't communicate with microwaves. Why? Because the water absorbs them. You have to use really long radio waves to be able to communicate underwater. Microwaves won't do it because they're attenuated so much in a very short distance underwater. So submariners know this, and anybody who's used a microwave oven knows this. But if you're a cosmologist, you have no idea. Right? They have no idea. Now we look at the Earth. It looks to me there's a lot of water there. And there's a lot of water in the atmosphere too. And all of this water must be emitting microwaves. Right? How does the water emit microwaves? Let's take some molecules, water molecules. It's H2O. These are water molecules. Well, water has a very peculiar character. And one of the things it does, it forms a hydrogen bond. Here's a hydrogen bond with the dots. The hydrogen here, it's bound to this oxygen by a hydroxyl bond, is weakly bound to this one here by a hydrogen bond. So energy that goes into the water can go in here and it can go in there. But this is a really weak bond. and this is a very strong bond. So the energy is not distributed evenly. A little bit will go in here because it's such a weak one, and a lot will go in there. So the theory, or rather the theorem of equipetition, which is used in physics all over the place, is also false as a direct result of the invalidity of Kirchhoff's law, right? So this is very important. So the mechanism by which water emits is the same kind of way as absorbs. Well, not quite, but the way it can emit is that these go like oscillators. Like if you take two springs, one really stiff and one really weak, and you can put them together and make a straight line, and then you can jiggle them up and down. This soft one will jiggle a lot, and the other one won't jiggle much. It's too strong. So that's the strong part. This one here, and this is this bit here. This can emit. This is the cause of the microwave emissions from water. Now let's have a look at a raw microwave image of the sky. It's made up of, let's think of transparencies. You know, the old days you used to take a transparency and put it on a machine and it would project. We take those transparencies and we lay them all together. We've got the galactic foreground. That's in microwaves. It's noisy. Monopole means it's the mean temperature of the universe, they say. And behind the monopole is the dipole. The dipole signal is a signal that's produced by the motion of the satellite because it's around Earth or something, right? And the Earth is moving around the sun, and the sun is moving around the galaxy, and the galaxy is moving with respect to the local group. These motions produce a dipole signal. This is well known. The galactic foreground, that's emitted by the galaxy. The galaxy is the Milky Way. We're in the Milky Way, and we're trying to look out of the Milky Way, through the guts of the Milky Way, into space. So this is noise. We want to get rid of that. We want to get rid of the dipole, and behind it is multipoles, and it's an infinite series because the model, mathematical model that they use here is what's called spherical harmonics, and it's an infinite series. So this is the first component of the spherical harmonic, this is a second, or rather this is a 0, this is 1, this is 2. You get quadrupole, octopole, a hexadecapole, and goes on, right? So we see here that the galactic foreground, that's in what, it's in millikelvin, thousandths of a Kelvin. The monopole signal, it's supposed to be isotropic. That means it's the same everywhere. Anisotropic means it's different everywhere. Which way you look, what time of the day, it's different. But if it's isotropic, it doesn't matter where you look or what time, it's the same. And the monopole signal, this is supposed to be the temperature of the universe. The dipole signal is anisotropic and it's noise. We want to get rid of that. It's in millikelvin too. The multipoles, the quadrupole, the octopole, the hexadecapole, and all that, all the rest of them up here, they're in microkelvin or smaller even. So that's a millionth of a Kelvin. Now, balloons and rockets were in Earth's atmosphere. Yeah, there's a lot of water up there, and they're close to the water on the Earth. Kobe-Furus, this is a satellite that's launched by NASA to find the monopole, the temperature of the universe, and this Kobe-DMR, which is to find all these multipoles, anisotropies they call them. And WMAP was another NASA program to find only anisotropies. They can't do any of this other stuff. You can only find multipoles. And the Planck satellite was to find multipoles, but it could also determine a monopole if they wanted to. Let's have a look at the Kobe satellite. Here we see important thing here. Here is FIRIS, the far infrared absolute spectrophotometer to measure the temperature of the universe. Here's the DMR antennae. These are two antennae to define these are differential microwave radiometers. And here we find a shield. This shield around the instrument. Yeah. Why? To protect it from radiation. You don't want radiation that coming from up here, down here rather than going in here, because it contaminates everything. So we want a shield to block it all. So they put a shield on, but does it block microwaves? No. Their shield does not block microwaves. It could never do that. And it operated from 30 to 3,000 megahertz, or gigahertz. You cannot build a shield to cover that range even. It's impossible. There's no such animal. So they build this shield. It's basically radio frequencies and thermal, but does not include microwaves. Here's its orbit. Here it is here. What's the altitude? 900 kilometers. That's not very far. And the Earth is what? Covered in water, and the atmosphere is covered in water. So there's lots of microwaves coming here, and it has a shield that can't block microwaves. So all the microwaves are coming up from under the Earth, under the satellite. They go up there, they diffract in, and they're getting microwaves from Earth. There's no way they can stop it, right? But they think they measured the temperature of the universe. They actually measured what? Microwaves from water from the Earth. But they think it's cosmic. Here's how it works. Now, Furious is an absolute instrument. This is a bit of a misnomer because it's a comparator. But they call it an absolute one because the sky is compared not to the sky, but to a calibrator. They put on board a calibrator and it's a black body. They made themselves a black body, a Kirchhoff black body. They lined the thing with black stuff and it gets a nice black body curve. And so the idea is take the sky signal, plug it in there, and take the signal from your calibrator. You can vary the temperature a little bit of your calibrator and you plug it in there, and then you take the difference between the two. And if you get 0, you know that the sky matches this. So you can say, the sky has the same temperature and nature as the calibrator. This is black body, and we set it at a temperature. They set it, they say they got a temperature of 2.725 Kelvin. But, the thing is, if and where the sky matches the onboard calibrator, they call it a null, or 0. If it's a difference of 0, it's a null, or 0. Or 0 should occur in the interferogram. What's an interferogram? It's the map of the difference between the sky and the calibrator. Let's have a look at one. Here it is. The Kobe-Furious team produces this graph. They say, look at this. The internal reference, that's the calibrator, is set at 2.759 Kelvin. And the sky data is near null. Oh, yeah, it's a nice, there's very little bit there. This is all nice and smooth. And yeah, we've got this. Here's the internal calibrator at 2.771. Sky data goes in and it's off null. Yeah, well, it doesn't match that one. They say it seems to match this one. And look at this. There's a big chunk. There's a big blip here. And here they've got 2 calibrators, one internal and external. They compare the 2. Yeah, there's a big blip. They couldn't get their 2 calibrators to match. Well, did they get a null or 0 anywhere? The answer is no. See this one here and this one here? The amplitudes of these 2 graphs have had have been suppressed by a factor of between 3 and 5. So this one here and this one here do not match the scale here. Do they tell you that in their graph? No. How do you know that? You have to be an expert in imaging science to spot it. Who did it? Professor Pierre-Marie Robitaille did that. This comes from Mather and his colleagues. Mather was the principal scientist on the Kobe-Furious. So we see that this and this are not on the same scale as that. If you amplify this 3 to 5 times, is that flat? No way. Did they get a null? No way. And they reported a temperature of what? 2.725. Here they say they got a near null at 2.759, but they didn't get a null at all because this and this are not on the same scales. In 1990, they first reported that they were taking samples between 1 and 2 centimeters to the -1. This is effectively their wavelengths, right? 1 centimeter down to 0.5 millimeters. But after 1990, they stopped reporting. After that report, they stopped reporting all data less than 2 centimeters to the -1. Well, you know, we were talking about the satellite and the diffraction over the shield. The lowest frequencies are the ones that diffract the most. An acoustic engineer will tell you that too. The lowest frequencies of sound are the ones that diffract the most. So they dump that. Why? They're the ones that are very important because they'll really tell you if you've got diffraction. But they decided, we don't like that data, we'll throw it away. As I said, it's the lower frequencies that do this. Now, everything else that didn't fit their curve, they threw into a thing called the calibration file. Oh, that doesn't fit. We'll calibrate that. So put it in there. This doesn't fit. We'll calibrate that. So they got rid of this data, then they calibrate everything else, and they get themselves a perfect curve, which they say is this. It matches the Planck black body curve at 2.725 Kelvin perfectly. So much so that the thickness of this line is 400 times greater than our error bars. You know, you have to expand this 400 times to be able to see their little error bar. That's how accurate they say this matches the theory. Where's the data less than 2 centimeters to the -1? It's not there. Is this labeled properly? Let's count. 1, 2, 3, 4. Is this labeled properly? No. This is advertising executives at work. You produce a graph, you put in this sort of thing, you don't say anything about it, people look at it and say, isn't that marvelous? But it's deceptive. Bearing in mind the interferogram, how did they get this perfect curve? And remember, we've already seen that Planck's law and Kirchhoff's law are invalid. So you can't get a black body curve from anything but a solid. How did they get this from space? They didn't. So this graph is totally meaningless for the cosmology. the universe is not in a cavity. So you can't even use thermal emission theory because it all comes from radiation from a cavity. Is the universe in a cavity? Is it in a box? No. You reckon it is in a box? I beg to differ. Here is how the Kobe differential microwave radiometers work. Now, the DMR was a differential instrument. What does that mean? It means you take the sky signal from one antenna and you stick it in here. Then you take the sky from another antenna and you stick it in here. Then you take the difference. And anything that's isotropic, like the monopole signal, right, that's the same everywhere. So it will be the same here and the same here. Now, if you subtract something from itself, what do you get? 0. So if the monopole goes in there and the monopole goes in there, you have no chance of detecting the monopole, because when you take the difference, the monopole drops out. And all you're left with is little bits that are different in these two channels. And they're called anisotropies. This is how you get maps of these so-called anisotropies, or the little variations in the cosmic microwave background, by using this kind of thing, a differential instrument. Here is an artist's impression of the monopole signal. This is the whole sky. Well, it's an oval, but that's how the WMAP team and Planck present it, so I do the same. And this is an artist's impression because I drew it. And you see here, everything's nice and smooth. If I take this away from itself, what do I get? 0. That's the monopole signal. It's isotropic. And you can subtract that. Yeah, we saw how you can do that. You just put the signals into the comparator and you take them all apart. Now, here's the dipole signal. This comes from the Kobe team. This dipole signal we mentioned before is due to the motion of the satellite against the galaxy, against the galactic group rather, local group. And this varies in time and it varies in direction. So they take a snapshot. Here's one example of the dipole. It changes all the time. Here is one. And when you take a snapshot and we want to get rid of that, the dipole signal is anisotropic. So you can't subtract that out, can you? No. You can't get rid of that. If you subtract signals, you will get this bit left. So how do you get rid of it? You data process with computers. Here is the map from Smoot, who was a principal scientist on the Kobe DMR. Notice this big band here. What do we recognize that as? Well, that's the galactic foreground. Why is it present? Well, it's a big anisotropy. He can't get rid of it because you're all looking through the galaxy. There's a lot of radiation there. This is microwave, right? But this is the anisotropic. So he's data processed out the dipole signal we just looked at. The monopole disappeared because he subtracted it with his instrument, differential instrument. So you're left with anisotropies. But the galactic foreground is a big anisotropy. And how do you get rid of that? Well, you have to data process that out because the galactic foreground can't be removed. So he gets an anisotropy map. He can't get rid of the foreground. This is a big problem with all of these satellites. So he gives you a map. All of these are the wrinkles in space-time. He calls this the wrinkles in the fabric of time. All of these little things here. And this one here, what would be behind that if you could get rid of it, if this is true? Would you expect more little green and blues and white and yellows and things? Yeah. You would expect that. If you could get rid of this, behind all it, you'd have all of this stuff filling the sky, wouldn't you? You'd expect that. Yeah? Well, if you can't data process it out, how do you get rid of it? Well, you can use scissors or Photoshop. Here we have another step. Where's the foreground line? This is not I didn't do this. This came from the scientists. Here you got the anisotropies here. What's this? Did you use scissors or Photoshop? One or the other. So this is what? All this stuff that's supposed to be in here, and you tell us that this is the galactic foreground subtracted. Well, that's not subtracted. That's just nothing. And as I said, he calls this stuff the wrinkles in the fabric of time. Here's a really interesting thing. I'll read this out. I have to read this out. This is Smoot. We were confident that the quadrupole, that's what I should have mentioned to you. He couldn't get the foreground. He couldn't get his anisotropies. He scratched his head. He got rid of the dipole. He got rid of the monopole. He couldn't get rid of the foreground. But he says to himself, the anisotropies should appear now. I've got rid of these two noisy things other than the foreground. He scratches his head. He says he couldn't figure it out. Why? Well, then he went to the quadrupole. Remember the slides I gave you? It's one behind. It's one behind the dipole. He says, I should have my anisotropy. So he says, we were confident that the quadrupole was real. That's the one behind the dipole. By late January and early February, the results were beginning to gel, but they still did not quite make sense. I tried all kinds of different approaches, plotting data in every format I could think of, including upside down and backwards, just to try a new perspective and hoping for a breakthrough. Then I thought, why not throw out the quadrupole, the thing I'd been searching for all those years, and see if nature put anything else there? Why, I puzzled, did I have to remove the quadrupole to see the wrinkles? So their own theory was telling them, take out the foreground, we couldn't do that. Take out the monopole, yeah, we can do that. Take out the dipole, well, we processed that one out. And now nothing's there. We'll remove the quadrupole. And what does he get? All of these anisotropies. Marvelous. We found all the little wrinkles in space-time. What does Robitaille tell us? He analyzed all this. What does he tell us? Robitaille's an expert in imaging science. He says this: the answer to this question is one of data processing. When Smoot and his colleagues imposed a systematic removal of signal, they produced a systematic remnant. In essence, the act of removing the quadrupole created the multipoles and the associated systematic anisotropy. Once the quadrupole was removed, the multipoles appear as extremely consistent variations on the maps. And Robitaille adds that apparent anisotropy must not be generated by processing. So in other words, Smoot and his colleagues could not tell the difference between data and data processed spots before their eyes. This is all produced by what? Their data processing. We know in many other areas of imaging science that data processing will produce ghost images. They're not there. He couldn't tell the difference between it. Now, here is L2, the WMAP and Planck satellites. They're orbiting Earth. They're here. Here's L2. This is where Planck and WMAP were located. L2 is how far away? 1.5 million kilometers from Earth. There it is. Yeah? And there's Earth. So it's further away from the sun than Earth. That's L2. Yeah? Here is how WMAP worked. It's a differential instrument. Remember I put up a simpler diagram? Well, here it is, one of their own diagrams with all their electronic gizmos. Sky goes in here. That's a comparator. It spits out something. The difference between the two. That's how they design their radiometer. Same thing as what's here. Now, here's their maps. They sampled at 5 different frequencies. Look at this one. See all that red stuff? That's the galactic foreground. That's pretty dirty. This one too, this one too, this one, these two here have got a lot of noise in them too, but they don't like this one. They don't like that or that either. So what do? Well, the first thing is they have to make a single map out of all of these 5 frequencies. So they superpose them all in a way. And they arbitrarily decide on what weights they'll lend to each of these maps. And what do they decide to do? I don't like that one. I don't like that one either. So they decided, let's go for this one. And so they gave this prominence. And they downplayed all of these. You know, this is mapping by trickery. Then they get this beautiful map. Where's the foreground? They've got rid of it. How do they do it? By data processing. All of these things here, they're the anisotropies, the same things that Smoot got. This is WMAP. What's the alleged signal strength? Well, all of this is microkelvin. That's 1/1,000,000th of a Kelvin, right? So it's in microkelvins, microkelvin. But what's the galactic foreground? The galactic foreground is in millikelvin. It's 1,000 times stronger. So we know something about this. If you have a signal that is 1,000 times weaker than the noise, we know from laboratory experience that you cannot remove the noise unless you have one of 2 options. One, you have a priori knowledge of the nature of the source, or 2, you can physically manipulate the source. If you can't do either one of them, you can't get rid of that noise. It's impossible. They say they did it. Well, they did better than any radiometric laboratory in the world can do with this satellite, they say. That's not a chance. Here's the Planck receiver chain. The sky goes in, and they use as kind of like FURIS. They compare, remember FURIS had a calibrator on board. This one has a load, a reference load, a 4K black body. There's 2 of them. Planck carried 2 4K reference loads. There were 2 kind of detectors, the low frequency instrument and the high frequency instrument. I'll only talk about the low frequency instrument because once we've done that, it's all over. So they take the sky, they put it in here, and they compare it to their 4K reference. That's emitting black body. They made a black body out of black stuff in a box. Then they compare them, they take the difference and they play around with it and they say, well, we got all these anisotropies like WMAP. Let's have a look at their black body comparator. Well, how do you feed the radiation from your black body into the comparator? Well, you have to have a horn to collect it, just like their antenna or their horn collects from the sky. Got a big horn, comes in. Well, they use this one. They've got a horn here, and the radiation's supposed to come off here. It's supposed to be around about 4K, and it's supposed to be black body because all of this stuff's black. Yeah? So if you've got radiation going into here, you can take that off and stick it in your comparator and compare it to the sky up here somewhere and spit out the answer. Right? Let's have a look at this. Here's your black body reference material inside here, your reference horn. This thing here is an aluminium casing. Yeah? And this here, well, they had a problem. They couldn't keep the black body at 4K because they didn't have any convenient cooling method. So what did they decide to do? Well, the high frequency instrument had a shield. And so the high frequency instrument was kept at 4K as well. So they decided, well, we'll keep it at 4K, easy. We'll bolt this against the high frequency shield. That's at 4K. That will keep us in thermal equilibrium and we'll have a 4K box. Yeah, great. So they did that. The trouble is, see these paths here? They did that with steel washers and they put in screws. That's metal. What does that do? That creates a conduction path. Now you have conduction from the black body. This is no longer a black body. Why? Because it cannot emit photons. In fact, it doesn't even have to emit a single photon. All the energy to keep this at temperature can be drained into the shield by conduction. This is not a black body. Both of their black bodies are mounted like this, so they have no black bodies on board. They are effectively getting zero from here, which means that they are getting zero into their horn here and comparing to the sky. And what did they report? We got a really good result. The reason why? They're comparing zero from here to zero from the sky. That's why they got a good match, which means there's no monopole signal. That means there's no cosmic microwave background at L2. This proves it, and they don't even understand that that proves it, and they don't even realize that they're stuffed up because conduction ruins this. Now, that comes straight from the papers, the design papers by the Planck team. I didn't make this up. So they have none. So we're getting close to the end. Without the 4K reference loads, Planck has actually confirmed that there's no monopole at L2. Why is that again? Because their black body is not emitting photons. It's not black body. That means they're getting effectively a 0K signal. There's no signal. Then they compare it to the sky. They get a really good, nice match. Why? Because the sky must be at zero. If they didn't have that, if the sky was at some higher temperature, they would have a really huge offset in their device. They could tell straight away the power levels would go up. They didn't get that. So the only possibility is, since their black bodies are not black bodies, they are comparing 0 to 0. They have proven, without realizing it, that they have no monopole at L2. That means this cosmic microwave background measured by Kobe is not cosmic. It comes from water on the Earth. It's got nothing to do with the universe. It's Earth. And they can't get a black body curve because Kirchhoff's law is now invalid and space doesn't emit in black body. Gases don't emit. They emit in bands. Gases absorb and emit in bands. You will not get a continuous spectrum from a gas or from space, right? So there is no cosmic microwave background. That's the history of the Big Bang. Well, we've already seen that general relativity can't manage more than one mass. We've seen that the equations that they compare for black holes and Big Bangs are incompatible. And we've seen that when the energy momentum tensor in Einstein's field equations is zero, there's no matter. He has no set of equations that mean anything. So it's the end of general relativity, and it's also the end of the Big Bang, right? Now, here's an interesting thing. It's now claimed that the axis of evil, I don't know if you've heard of it. George Bush once said about the axis of evil. That's a different one. Yeah. Bush doesn't know any science, of course. I don't think he even knows English. Anyhow, the axis of evil. It's claimed that the quadrupole, remember Smoot had to remove the quadrupole because he was wondering why he doesn't get inside anisotropies. Well, the quadrupole and the octopole of the alleged CMB, the octopole is behind the quadrupole, and then the hexadecapole is behind that one. They say, well, we have a definite alignment with one another, with the ecliptic plane, the dipole, and the equinoxes, so that the Earth is the center of the universe. I'm not kidding you. They're telling us now that we're going back to a geocentric universe. The Earth is not just at the center of the solar system. They're using the CMB to tell us that the Earth is at the center of the universe. Well, really? And what shape is the universe, since it's got a center? Microwave radiation from Earth has nothing to do with cosmology. Cosmology is not even a science, you know, and we do not live in a geocentric universe at all. Thank you very much.
Get on my spot. Get on my site. Get on my site, kidding. What? What's up, people? We're still here. All right, that's probably pretty close to the 8 here. Let me see. Yeah. Take care, everybody. Thanks for hanging out.